was wrong in it?
What was science associated with gravity and astronomy? I pointed out to you that astronomy doesn't follow the scientific method. You can find citation in the side chat if you scroll up. I also made the claim, and you were talking, so you probably don't fucking remember, that gravity doesn't follow the scientific method, i.e. you won't be able to prove it to me using science.
He says he's done speaking to you, Jedi. You're big meanie, Jedi.
Good. Thank fuck for that.
He says you don't understand basic physics, bro.
Uh-huh.
Like, you're not incorporating Stephen Hawking, bro. Like, you really gotta like get up to date on Stephen Hawking. It's
too much Carl Sagan's probably what it is. Yeah, need more Stephen Hawking.
Look, yeah, I kind of lost it. I lost it when he said, Newton, Einstein, Stephen Hawking. Like, what? That's got to be a first, dude.
I mean, Newton, that genius that couldn't solve the longitude problem?
All I'm saying, no multinational, multi-generational conspiracy out to debunk you. There's nobody doing that. There's no evil scientists that are coming to, we must hide the truth from these people.
What the fuck is he gibbering on about now? Why have we listened to
Apparently he's never heard of the Freemasons.
About the general consensus.
Multi-generational group trying to hold us back.
Scientists have been lying to you for ages. For example, the chemical industry and the medical industry. But hey-ho.
So even I can reference different cultures that have contradicted.
I don't think anyone cares, dude.
The archaic European understanding of Earth and the sun and
That's
moon.
nice.
Earth. Like different cultures have different things of this, and in their Islamic age, they were able to advance astronomy farther than primitive idea in Europe.
Question: Is astronomy the study of the Earth?
It's the study of the universe.
Okay, so not the study of the Earth.
The Earth is a part of the universe. So
okay,
yes.
So the study of astronomy, does that beg the question that the Earth is in the sky with the other things that we look at?
Yes. Wait, what?
Okay. What evidence is there that the Islamics used to prove the Earth was a sphere?
What? That's not what I said.
I know, this is what I said. It's like you can't follow conversation. You thought that you could stand on a soapbox and start preaching to us for some reason. Again, I've decided to hold you up on what you fucking said to see if you understand what you say or could even give evidence for anything you're about to say. I'm starting to think you can't.
Never got to. I didn't even make a claim besides telling you what you
I know, I'm trying to get you there. Are you not following again?
Dude, I've done nothing. I haven't made a
stand on a soapbox and make bullshit claims.
I haven't even told you what I think of the Earth. I haven't made a claim. You're arguing with nobody.
I'm arguing with you, ancient Muslims.
I'm arguing with you, dude. I don't care. Like, you're just, when you make a false claim, I'm going to tell you where and when you're wrong. Just
really?
Like
you're the person who thinks that you could educate me. Really?
I did, because dude, they backed me.
Dude, everybody in this room sat back and laughed at you.
You're right.
Everybody laughed at you, dude.
I don't care who your Discord buddies who are fully as uneducated, bud.
Dude, are you just going to ad hominem your way through this conversation?
No, sir, but you've been...
Stop it. You came into the conversation saying that we were stupid, that the flat earth was an archaic idea, and we only believed in it because we were fundamentalist Christians.
When I was... No, I didn't.
Time here has run out.
We were speaking about Vikings. We were speaking about Vikings, not just Christianity. We were speaking on different cultures, not just Christianity. No, you don't even know what we were talking.
It's here the entire time, dude.
Jedi, you're disrespecting his Viking heritage, bro. That's not very nice, man.
I love these advances in astronomy, even though we couldn't build a decent telescope until the 20th century.
The most intelligent thing that boy said was that they double charged him at McDonald's.
Well, so, may I ask a question?
Please save us. Yes.
Okay, so let's say, hypothetically, that the Earth was proven to be round. Would you believe it then? Like they made an observation that you could actually go and test out. Would you believe them then?
Easy. You're talking about hypotheticals when we already measured it. It's not curving. So why are you asking silly questions? You've been in here long enough to know that it's not curving. Bring us some measurements of surface curvature instead of coming in here asking hypothetical questions about things that we already know are not going to happen. You understand? The Earth is a ball. If the Earth is a ball, it would be obvious after all of the people looking for the curvature didn't find it. You understand? Come on, buddy. Don't come in here with these hypotheticals.
But let's check for double standards. Easy. If it was proven that it was flat, would you be okay with that?
If it was proven, like, and everybody knows it, then sure.
No, not everyone knows it. It's just if it was proven, you're on board?
Well, it depends on if the majority is on board. Like, if it's actually like proven and tested and like verified by other scientists, then sure.
That's not what I mean. That's like a weird double standard. It doesn't require everyone to believe it along with you if it's proven. Like, there's still going to be people who believe in whatever they want to believe, regardless of the proof. But I mean, John makes a good point, though. It's already been proven. That's why we're flat earthers.
Okay, sir. Sorry for the stupid question.
It's not necessarily stupid unless you have like a double standard where you expect flat earthers to like switch their position, but you wouldn't switch your position in the face of proof. You know what I'm saying? I don't think we're really that dedicated.
Why it isn't a smart. This isn't a good question, CB, only because he's been in here for days and he's asked every single question under the sun. He's been presented with every long distance observation, laser test, and he's still going to come in here asking silly hypotheticals. It's ridiculous. Not like he hasn't been presented with the data.
Well, I still have more pages in my textbook I haven't read, but I have to get that tomorrow. It's in my locker at school. But I'll get it and I'll read it out. So, yeah.
Oh, great. More lore. That should be fun.
Because, see, I could post a photo of my bedside where my books usually are, and they're not there.
I would say the answers are not in the books. They're outside. Like, it's the behavior of the earth is where you'll find the answers. Any man can put anything in a book and say whatever they want. But the earth is truly where the answers lie.
That's a very sweet message. Thank you. I'll look more into that.
Aww.
But yeah, I started school. Like I'm learning stuff in school now, so I might have more info to use apart from just sticking to some stupid books.
Like in regards to the everyone else must believe it thing, my parents taught me when I was growing up that if everyone jumps off a bridge, that doesn't mean you have to. You know, so just be mindful of that. If every book or everything in the book is saying oceans are curving, then you go into reality and they're not curving. You know, you might have this peer pressure to think that it's curving because everyone else does. But again, you don't have to jump off that bridge just because everyone else is.
Okay, sir.
John says he needs to concede, so he needs to be unmuted so he can concede. Well, he conceded there in the text chat, so that's good enough.
What does concede mean?
To admit, to basically be like, okay, yeah, you were right.
Yeah, I was extremely wrong. I'm just following what the books are saying and what my professors taught me. And now
No, you're not. No, you're not.
No, I'm believing you now.
You keep arguing for both Newton and Einstein. Einstein superseded Newton, and you keep denying that. So you're not even following your own lore, like you say you are.
Don't forget Stephen Hawking.
I take it back, dude. I was wrong. So I just want to understand now. Does Earth have a core or no?
Probably not.
Probably not. So, how does it look? Is there how do volcanoes happen? Like, where is where the pressure? Like, how does no core or any of that? I'm just trying to understand because I know I'm wrong. I can be wrong, okay? But with your idea and understanding of flat Earth, how does it look like in space? Like, if I were to look,
okay, so nobody here has a God's eye view, right? We can only go up so high, e.g., high altitude weather balloons, right? And when we go up there, it just looks like a flat horizon, right? It's no curve anywhere. So that's as far as God's eye view we can get.
John, hold on, dude. The Earth is not in outer space. So let's rip that Band-Aid off. Number two, there's no such thing as seeing the whole Earth in one shot. Like, it's for the same reason you can't tell me what the universe looks like. Why? Because you're inside of it. You can't leave it and say, oh, okay, well, it looks like this giant egg or whatever. Like, you're never going to be able to say what reality looks like as a whole. So no flat earther, nobody is ever going to be able to tell you what it all looks like. And so your next question was, well, what's under it? You're thinking of like a flat object in space where there's an edge, there's a bottom side, it's floating around in the galaxy. This is not flat Earth. That's a really terrible idea that you probably came up with. So the Earth is not in outer space. That's the key point here. And you can't know what the shape of it is.
Oh, I was just confused because I understand your analogy with understanding the universe, but what the books taught me was that we were able to determine that the universe was expanding, and like how the universe was, like, by observing the light from distant from galaxies far away. And
That's cool, bro. But that doesn't mean you're going to be able to know what shape it is. Even if you had, like, let's say you had a balloon and it was expanding, it has a shape, it's just expanding. But, you can't know the shape of reality, whether it's expanding or not, which I don't agree with. But
so time dilation, where is Earth if it's not in space?
Earth is that's like asking where is the universe. That is the where. That is the place. So that's what I typically say. For you, the globe is a thing or an object within a place, the universe. Flat Earth is not like that. Flat Earth is not a thing in a place. It is the place. So, yeah.
Okay. So like I kind of thought that they figured out the shape by like seeing the cosmic radiation from, like, they can go back and, like, the farther you look into space, the farther in time, like, there's this time dilation, which sounds completely fucking stupid if I'm being honest. A lot more sense, and I'm not being sarcastic. Y'all have more logic than this. But what I was taught is that there's this microwave background radiation that's coming from the beginning of the universe, and we can observe it somehow through some kind of telescope. And I'm not really sure how any of that works. But I digress. So, my question was, how do volcanoes work?
I think the chat said lava go burr.
Why can't we have a explanation of things that, like, why can we not? Is it just not possible to understand what's on the other side of Earth, or like if it's not possible to understand these things because you're kind of telling me that?
Wait, what do you mean the other side?
You're just like when I ask you some of these questions, you're like pretty much telling me that, like, it kind of, so your ideas contradict everything that I've been taught in academia, right? Everything, like the very, very fundamentals of this. Like when you make this claim, it changes the idea of even archaeology, like everything.
Give a solid example.
All right, so with the understanding of the core of the Earth and tectonic plates and gravity, like it correlates. But if gravity isn't the way we think it is, and Earth isn't in space, and like, what about the sun? Is the sun in space? And is the sun in outer space? Like these are questions that are being risen by the claims that y'all are making, and I'm not disrespectful to ask these questions.
There is no outer space. And,
the sun.
Yeah, but see, no one knows what the sun is. Like, you don't know what it is. I don't know what it is. No one knows what it is. So, what you can't do is take your current understanding of the sun and then implant it into an idea of a flat Earth, because then they're not compatible. They don't go together.
So we don't have understandings of chemistry and stuff. We can't observe chemistry like through experimentation and say, look, this is hydrogen. This is what hydrogen does. We can observe the things on the periodic table, and we can use that to understand, the sun and like its mass and the vacuum of space. So is whatever they call space, like the above, is it a vacuum?
No.
It's not a vacuum. Oh, okay. Because, dude, I feel so stupid because I don't know physics. I don't understand science. For real, like I didn't even understand like social constructs. I was just looking into it, and I went on to jw.org, and I figured it out a little bit, like the perspective that I align with, and personally, I think the Bible says the Earth is flat too. I think. It says there's a circle. It's just a circle in the Bible.
I mean, I don't think anybody's going to use the Bible as like globe or flat Earth proof in here necessarily. But look, man, it's pretty simple. We've got like 3 core, no pun intended, tenets here. Basically, the first thing is the surface is flat. So this doesn't say anything about the shape or the boundaries or anything like that. We're just describing the surface. There's a lot of water on the
around their surface.
All right, bro.
So there's no core. Then how is gravity a constant? Wouldn't it mean the farther and farther out you go, the less gravity you experience? I'm trying to, because this is debunking all science. It's debunking archaeology.
Gravity being a constant either.
What's that?
Can you say that one more time, Jetta? One more time, Elijah.
You don't experience gravity being a constant either.
I can say that I do, because in my experience, it feels I'm the same weight. My body itself changes, but the same force is I'm being pushed down. Our bodies were designed through evolution to for example, for instance, our hearts can't function with a human being upside down. There's a reason why we would our hearts would stop working when we're consistently upside down.
It makes a problem for being weightless in space.
Excuse me?
That's a problem for being weightless in space.
Oh yeah, it does create issues with the human body.
Hey guys, how are you?
They're astronauts in the International Station. They're in orbit. They're not in outer space. They're not.
How does the liquid in that inner ear know which way to go?
Excuse me?
The vestibular system inside the inner ear that shows a person their balance, it knows your orientation, it helps you fucking figure out where you are and orientated in the world. That's a liquid. Now, being as you're in zero gravity in, the International Space Station, how does the liquid know which way to go?
I mean, they've done this experiment with cats because they brought cats up into space to see how they react. Because they have kind of a similar system, but how they always land on their feet. I can't reference it off the top of my head, but the scientists who are the liars, they've explained this somewhat, but that's why I'm trying to understand your perspective. I think the Earth is flat, but it's
it's measured that way.
Is it forever? Does it go on forever?
Me being a finite being, I wouldn't be able to experience eternity.
What about Antarctica? Is it all around us? Is are we just
No.
what's our border look like?
Pardon?
Our border, the border of Earth.
I never experienced it.
Oh, okay. What about people that sail from one part of the world to the other part? How do they do that? How did
sail from one part to the other part?
How do they go from Europe around Africa and to the Americas again? And then how can they go around the Americas back to Europe?
It's a circle.
Wait. So you don't believe in the map that
there's lots of different maps, dude. You were asking, how the hell do people navigate the seas and then where they started from if they go in one direction? So east and west are circles around poles, so they went in a circle.
But they're whoa. Because if it's flat, they would have to turn around to get to the other side.
The other side? No, we ended up where we started from. Remember your example about sailing around Africa and then coming back again? That's a circle. I'm pointing out that, for example, in this example, they travelled east. So east would be a circle around a pole.
If
A
you went,
circle, you can draw a circle on a flat piece of bloody paper. You're asking how this works on a flat Earth. It's a circle.
all right. So let me ask this one. I don't think I quite understand. So if they go in one direction, and let's say
East.
there's, so they go one direction. So
East.
just straight east, right?
Straight east. No, east isn't straight.
They were at by going straight.
The east isn't straight.
I mean, from where they're at, I know it's subjective to where the person's at. So if they went direction, can they get to the same place? Because that's the spherical art. Like,
well, if you travel in a circle, can you end up where you started from? If you travel in a circle, yeah.
Yeah, but that's not what I'm asking you.
Yeah, but that's
that means,
east.
like, because on the flat Earth, like from what I've talked to other flat earthers, they say that it's a plane, and that would suggest that there's
you can't travel in circles on a plane.
Yeah, but I'm saying one direction. Can you get to the other side? How do they get to the other side? Going
What do you mean, other side, dude? Other side of what?
So let's say for a European, right? Let's say you in the UK, right? You get a ship and you go west, and you get to China.
Yeah.
How? If
you went west.
No.
West, like east, is a circular direction around a pole.
I mean,
do you know what compasses are? Do you know what a compass is?
I do, but that's not really.
Awesome. Do you know what both types of compass are? The one that draws a circle and the one that orientates you to cardinal directions.
Asking about your interpretation on.
No, I'm trying to explain to you what directions are for some reason. Because you're asking the question, how can I travel west and end up where I started from? I'm trying to explain to you that this direction of west is a circle around a pole.
Around?
Oh my God.
I'm trying to
you go to university and you've done physics 1 and 2. Fuck me.
Listen, I'm only a sophomore. I'm not smart. I'm kind of stupid, all right?
No shit.
I got you. But I'm trying to understand. Because
what a circle is.
Round, like they're moving around something.
Yeah, around. Right? Can I go around a flat surface? For example, if I put a pole in the floor and I say, this one is north, and I point to it and I travel in a circle around it, that direction will either be east or west. Because I've gone in a circle around the pole, I can end up where I started from.
So the poles are in the middle.
The poles, too, are in the middle. What?
So you're suggesting that the poles are in the middle of the flat Earth?
No, I'm saying that when you travel around using cardinal directions like east and west, don't be surprised if you end up where you started, because it's a circular direction.
So that's not really what I mean by...
Well, you were talking about navigating the fucking seas, and now the hell on a flat Earth do you end up where you started from? Because you think you can only travel in circles on spheres.
I'm trying to understand the depiction of Earth that y'all are giving.
At the moment, I'm not trying to give you a depiction of Earth. I'm trying to tell you what fucking cardinal directions are.
Someone else told me that there's a border, and if you there's Antarctica is the border, so you can't just keep going. You can't
You shouldn't listen to fucking people on the internet, dude. What the hell?
Listening to you. But all right. Okay, so
I mean, don't argue with me if you're going to bring up points that other people that I'm not associated with bring up.
The directions are. I know it has something to do with the North and South Pole, but with the spherical theory of Earth.
No, that just cardinal directions, dude. Poles. What's a pole?
On the opposite side of each other.
What is a pole?
Like that's how, bro. The
Fucking hell.
Earth, and there's a South Pole and polar opposite.
Now.
How does that work on the flat Earth model? With the way you're explaining it, how does that work?
Because we get north and south from celestial rotations in the sky.
Yeah, rotate. What do you, so it's a disc spinning around.
No. I mean, how did you get that from when I said?
He said
that moving in the sky.
And then you keep saying, I'm honestly like, I'm coming in an open mind, and I'm like,
not really.
But
no, but you're mixing the globe and the flat Earth together, right? You're trying to like you're stuck on your current like religion, and then you're coming. Okay, well, how does the globe work on the flat Earth? Right? It doesn't work like that.
Can we get like somebody to draw it out or something like on video? Like I'm trying.
Like we said, we don't have a God's eye view. We can only see what we can see and how far we can see due to perspective. Would you agree?
The maps lies too.
No, the maps are maps. Maps are like based off like geography, right? Based on like, you have elevations and stuff like that.
Yeah. But so on flat Earth, does it end somewhere? Does Earth end? Like
okay, that's been answered already. And do you remember the answer?
No, it wasn't directly answered. Yes or no question.
It's not a yes or no answer. It's we don't know. So I can say no, definitively. Okay, how do we know? We haven't been that far. We haven't seen it. Right? We haven't seen an edge.
Okay. Well, we've had people that have have sailed around the Earth. That's what they say. Just like he said, around. So when the way he's describing it, it leads me to believe not a spherical Earth. I don't think that's what he's saying. What it leads me to believe is that the poles are in the direct center, and that there's a circle around these poles, and that when you look at a map from the North Pole being in the center, and you put this map
I'm going to stop you there. But he said the poles were in the sky, right? The stars, Polaris, right? And the Southern Cross.
So I'm going to show this. So this is how he's I'm going to copy and paste this source real quick. It's off. It's just a picture. And I want to say, is this how you go around? Is this how you go around? So in that map, you see that map? All right, I'm gonna ask a question. So is that the way he goes around from the U.S. back to the U.S.? Because they're going around it. So is it like that? Is that what he's describing?
So if you're at let's say California, all right, and you go around, and then I don't know, I'm not sure if you can go through South America. I'm not sure if there's an inlet there. I'm not sure if it's all land.
There's canals stuff.
Okay, so let's just go through a canal there. Let's just skip the South America. Let's just go through that little part, and then we'll go back to Boston. There we go.
But if you can't travel in a straight line though, hypothetically, in the same direction, you're telling me that these directions, it changes depending on where you're at. That doesn't make sense, because what Jedi's depiction of the compass and what north, south, east, and west, it doesn't really. It's subjective to where you're at. And I know y'all don't believe in the hemispheres, and I don't believe in them either. So my question is, do they have to literally change direction though, to move around it, or else it's not a perfect flat Earth? Because if it's a flat Earth and they're going, they'll literally have to change direction to move around it. Like they're gonna have.
I'm getting it. You're confusing me. Anyone else want to take this up? I'm gonna go work on my bike.
I don't know.
It's in the word. They call it circumnavigation. Maybe you should look up what it means to circumnavigate. It means to go around in a circle. It's in the word.
All right, so I want to send a picture of the map. Okay, this map, and I'm just using a picture off Google Images. Okay, just to reference. I'm going to be looking at the same map. Okay, there's the map, right? That Plumbot put down. So let's say I'm at California, right? He's telling me if I because of some kind of rotation when it comes to north, south, east, and west, that if I travel solely, I can't just travel west. That's pretty much what he's saying. Like it's.
No, that's not what he said. You didn't listen to anything. East and west, doesn't matter which one you pick, is a circle around north. East and west are not straight lines. They are circles.
Oh, Adam, he's walking in circles, though. Like it's
like even on a globe, they're circles, dude. On flat, they're circles. On a globe, they're circles. East and west are circles, dude. Period.
But it's how is
okay? John, let's scale this way back, John, let's scale this way back. Imagine that you're at the North Pole, and let's pretend that there's an actual pole there, okay? And that's where your compass points. It'll point to that. It's north. And if you're going to go around west, you're going to put your hand on the pole and swing yourself around the pole and make a circle around the pole. That's west. Now put your other hand on the pole and walk the other way. That would be east. And you walk around the pole. That's circumnavigating. Now let's move back a little further so that we can't touch the pole and go in a circle around the pole. You still go in a circle around the pole, the place where your compass is pointing, and you go east or west. I don't know why you can't figure this out. This is common stuff.
They can't go straight, like, because even in this picture that Adam sent, it's literally a man. But we can move on to another thing, because I just don't think I can understand that, because
you can understand circles.
South are in reference
for you, dude. I'm so embarrassed for you that you can't understand circles, man. This is ooh boy.
I think he's putting us on
understand
now.
what's north,
gone
east,
way too far.
west.
This is nonsense.
It's in reference to, like, oh my god. All right, I'm gonna just cite my source when it comes to it. There's this isn't. It has nothing to do with astronomy. Whatever. What exactly are you telling me? North, south, east, and west are? Like, are they direct?
Navigation. Your card's direction. Oh my gosh.
It's in reference to where you're at. How is it a circle?
No, it's north, like south, is an absolute direction, because that is a definite geographical position on the Earth. That geographical position is underneath a celestial rotation in the sky. For example, celestial north. Directly underneath celestial north, we can affix a pole. East and west will be circles around that pole.
So you just told me there were no poles, because oh
my god, he's fucking retarded.
So
my brain just broke.
Model, there's polar opposites on the axis of how Earth revolves. Like there's the North Pole and South Pole. They're not literal poles. It's just based on.
Dude. All right, we understand that they're not literal poles, even though you can go to the South Pole and see a nice fucking pole. But we understand that these are geographical and celestial positions, absolute directions for cardinal directions, north, south, east, and west. north and south being poles, east and west being circles around them. You're asking us how we can travel in circles on a flat surface. It's a circle.
So they're really going straight, right? Okay. Yeah. They're really going straight. Is that what they're doing? Even though they're going down the North Pole.
Wow.
No, they're actually going in a circle. Actually going in a circle. Do I need to say it again? They are actually going in a circle.
How does that side with the flat Earth theory? That makes more sense.
This is dumb. What's a circle?
You're saying that is some kind of like flat. I don't.
Circles are two-dimensional what shape?
Anything what you're depicting.
You asking that how you could go in circles?
Two-dimensional plane,
on flat surfaces.
North and south has been we use it to navigate, but
that's what we're doing. Yeah.
The North Pole and South Pole when it comes.
Hold on a second. I gotta unlock my card.
Something that's like meant for the north, like that we use. You told me that the North Pole is a star.
I'll be right back. I gotta unlock my card.
Like,
yeah, I told you, celestial north. The clue's in the fucking name. Celestial. It is in the sky.
What are you talking about? Like the North Star or something?
Oh, has it got north in the name?
Okay, so what else can we use like to navigate? Like, because we cannot use north and
south. All we can use to navigate is the stars. The stars is how you navigate.
Stars. What the fuck? We can use also magnetic field lines.
All right. Okay. So,
it's not that hard. It's not that hard. You go in a circle around a star, dude. That's it.
Some flat Earth depiction. My idea of a flat Earth was that like the literal archaic depiction of a flat Earth.
Oh yeah, that's a straw man.
No, it's
not. That the Earth is a disc where the center is the north and the circumference is the south. No, that's a straw man.
How's that a straw man?
Because we're not making a claim to that. That's a claim that other people are making on our behalf. This is the archaic model that they think that we're talking about. We're not talking about that, so it's a straw man.
So explain your depiction, because you're not.
You haven't asked me to. At the moment, you've asked me how do we go around in circles when we navigate the Earth.
You're just saying we don't
know the dimensions of the Earth. I did say that earlier.
So you can't tell me how the Earth looks, because
I'm not God, for example.
You have to be God to see that?
Sorry, do I need to step back from the Earth to see what it looks like in its entirety? Isn't that what you had to do when you went to the moon?
Experiments, like you brought up.
Start saying words you don't understand again, please.
Dude, I haven't made any claims, so if you don't
experiments,
I haven't made any claims.
Just experiments.
Yeah, you claim that there's experiments. So, what's an experiment? Can you go ahead and define what an experiment is in science?
That's a straw man. Like, no, he said
it's
that
not a straw man.
That I can do to see the curvature of the Earth. With
you apparently don't know what an experiment is.
That's what I'm talking about. So now I'm trying to understand his depiction of the Earth.
I don't have one.
It has none. So
I don't have one. I don't know what the entirety of reality looks like.
Then how are you making claims on
because the surface of water measures horizontal.
What was I about to ask you, sir?
I don't care. I'm telling you why.
Are you making a claim about the flat Earth? If the Earth is flat, why are you making a claim about that? That's what you're going to ask.
So why
the first rodeo?
Lying so much to scientists?
Do
what?
God.
Why are they lying about it?
Oh, we don't know.
Did you know science has nothing to do with the shape of the Earth?
What literature is like? Where's your supporting literature? Where's anything that's on your side?
Would you like some?
Would you like some supporting literature?
A doctor.
We've offered you so many citations, but you haven't read them. But do you require supporting literature for the water's horizontal on the surface?
Sure. I would like to.
Perhaps you'd like how airplanes fly over a flat and motionless plane. Perhaps you'd like that one.
He just made a claim that you would only know from a God-eyes view. He just said that it's a flat and motionless plane. So,
dude, no, don't strawman me.
The other person is saying,
asshole, don't do it. Don't strawman me. That is not what I said. I was answering your question, but you asked me. Don't talk. Look, my friends, right? I'm going to be honest with you. I could remove you from the channel. You've been here long enough and you've tried everybody's patience. Now, bare face to everyone, you're going to try and build a straw man. I'm not going to fucking hold for it, sunshine, because that's not what I fucking said. I was answering your question. Oh, he's going to talk again. What an intolerable man.
Dude, I was talking to the other guy. I wasn't saying nothing to you. I didn't say nothing.
Flying fuck, dude. And I do apologise for swearing. But my goodness, you've tried our patience.
Well, somebody else said something about not having a depiction. You haven't made a claim. I'm not talking about your claims. Someone else said that the Earth is a motionless place. I'm not talking about you. And you can ban me, but that's just intellectually dishonest. You're a miserable, single, fat old man, dude.
Dude,
John,
if you
shut
feel
up, dude.
done by, instead of complaining, you can reiterate your point if you feel hard done by.
Way too much time on the board.
So here's the problem, John, right? Here's the problem, John. Here's the problem, right? I'm not giving you a God's eye view. There's flight manuals out there that tell you that when you're flying a plane, you treat the surface of the Earth as if it's flat and motionless. Everything that we do is based off of a flat, non-rotating Earth. That's the way the mechanics work out. You know why they say that? To simplify it, because it would be over. You would have to overthink everything. Oh, what's the tangential spin of the Earth based off the angle that I'm flying, and how do I maintain this? You'd have to do all this extra unnecessary math because the Earth is flat and motionless. That's why they treat it as such.
I kind of came in here thinking that flat earthers were skeptics and they were challenging the status quo. But I come in here and I face like suppression, like insults. Like I came in with an open mind. I haven't said nothing just because I don't understand your ideology, and I'm cross-referencing other areas.
It's not an ideology. Can I explain how? Listen to this, okay? If the surface of the Earth is not curving, then the surface of the Earth must be what?
I mean, it's not a perfect sphere.
If the surface of the Earth is not curving, then the surface of the Earth must be what?
How do you know it's not curving?
Then.
Because of what you can see from the horizon from your 6-foot perspective? No, when you go up in a plane, you can see the curvature.
No, stop trying to defend it. He's just asking you a good faith question. Just answer the question. Stop getting so defensive. Just answer what he's asking you.
If it would be flat, I guess. I mean, I don't know.
Yeah, that's the only alternative. If I put a TV screen in front of you and it said that TV screen is curving, and you said no, it's flat, what would we do to make sure to determine whether or not that TV screen was a flat screen TV or not?
By looking at it?
No. Yeah. By definition, lines, straight ones and curved ones, they can't be the same thing.
But you argued that there was a 2D, like this is like almost like a flat Earth. And like
no, it's not 2D. It's a surface description.
So how do you move around something then like that in that way?
Well, how do you move around a flat surface?
You said the pole is in reference. What exactly is the North Pole?
Exactly, it's the North Pole. It's a point of celestial rotation in the sky.
Yeah, everything's based off the stars. The only thing that's not based off the stars is the surface of the Earth.
So, where do these ideas originate from? Like, are you guys on atheists?
You know, somebody decided one day to go out and look at the surface of the Earth because they said the Earth was 24,901 miles. They said the horizon was 3 miles away from a 6-foot observer. And someone was looking out one day and said, well, holy, that island might be 30, 40, 50 miles away. I shouldn't be seeing that island. I thought the horizon was only 3 miles away. And so they decided to go and do some geometry and some calculations, and they find out there's no way that they could see that island from 30 miles away or 20 miles away. And so they doing other observations, and they start finding out that the horizon is actually in the wrong place. It's not anywhere near where it's supposed to be based off of the what the globe says it.
It depends how high up you are. Of course, when you're like literally, if you
that's why he said 6 foot.
Right. So when you're 1 foot observer height, how far away is the horizon?
I don't know the mathematics off the top of my head.
We do.
We do, and you should look into it.
So you're right. I mean, well done for pointing out that the height of the observer is going to change the distance to the geometric horizon. The mathematical formula to figure that out is 1.225 multiplied by the square root of that observer's eye height in feet. So that's why Sheepdog just said, if you're a 6 foot observer, if you're on a sphere, then the horizon's 3 miles away. If you're 1 foot, square root of 1 is 1, times that by 1.225, and that gives you a distance to the horizon of 1.225 miles. Conversely, 8 foot above sea level, that's a horizon of 3.46 miles. Increasing or decreasing the eye height of the observer would change the geometric distance to the horizon. You understand this? Well done. Sorry, Sheepdog, carry on, mate.
No, yeah, we all agree that, like, based off of the geometry of the Earth, the supposed geometry, as you get closer to the Earth, the horizon would get closer to you. We're not disagreeing with that at all. What happened was somebody showed us some things, and I don't know Jedi's entire story, but for me, when I saw people doing long distance observations, I was like, I've seen things that look like I shouldn't see them, but really the horizon's that close? No, there's no way, man. Let me go look for myself. And that's when I started down my own little path, and I went from believing the Earth was a ball to knowing that the Earth was flat because of long distance observations. All these things are done over water because water, when at rest, always seeks horizontal equilibrium. We can observe this with a cup of water, the surface is flat. Observe this with a puddle of water when it rains, the surface is flat. We can observe this with a bathtub, a swimming pool, a pond, a lake, a river, whatever you want to call the surface, any body of water, the surface of the water is flat. So then it's like, well, now we're going to beg the question, we're going to go out and test this over longer distances. So we're going to use large lakes that we can't see the beach on the other side, or maybe we'll go out to the ocean and we'll find things that are demarcated out in the middle of the ocean at a set distance and see where the horizon ends up along that observation. So we don't disagree with you at all. The difference between you and I is I was skeptical, but at the same time, I'm like, that can't be true. Let me go look for myself. So I was skeptical both for flat and globe. And I just decided, you know what? I've been lied to before in the past. I've been gaslit before in the past. Let me go check for myself. I bet you've never done that for yourself.
I'm not skeptic, but I I wanted to ask y'all about your worldviews because is there any other ideas in your worldviews that like reinforce these?
No.
That's the main point.
It's math and science, bro. I don't need the idea of a creator. I don't need the Bible. I don't need scripture to confirm my worldview. All I needed was geometry and science. Knowing the difference between the two, that you don't need geometry to do science, and you don't need science to do geometry. When it comes to the shape, whether it's a cube, a pyramid, cone, a triangle, a square, whatever the shape is, that is not a science question. That's a geometry question. And the way that you go test those things is you look at the lines that are involved with it, and you look at the angles that are involved with it, and you compare it with what Euclidean set out for us, right?
Is the sun a sphere?
Huh?
Is the sun a sphere? And furthermore, we can also...
I have no idea. I see the sun in the sky. I know. I see the sun in the sky. It looks like a circle. It could be a sphere, right? But I can't go there and check for myself.
Okay, so
whack-a-mole
to a flat Earth astronaut.
Y'all need empirical evidence. All right, I get that. So, okay.
Let me ask you something, John. When you look in the sky, do you see the sun moving or do you feel the earth moving?
I don't feel the earth moving. I feel gravity upon me, but
you feel gravity upon you. Okay, that's a good one. Explain that.
Gravity, our weight is determined by like.
If you're just standing there, you don't feel gravity upon you. So, like saying you feel gravity upon you, that's the most ridiculous thing, bro. When you look at the sky, do you see the sun moving?
Gravity.
Do you see the sun moving, or do you see the earth moving? When you look into the sky,
the sun moves.
Okay. All right. We experience the same thing then. We see the sun move. We don't see the earth move.
John, sit down. Somebody else needs to talk.
Contradicting the ideas of the
solar. Off again. It's going to start preaching now.
Thank you, John. We appreciate your question and little honesty, but next.
Yeah,
we'll come back to you later, John. I think you need to think about some things. Maybe do a little research.
John, take a break. Take some coffee.
Understand, like, dude, you just.
It's not your invitation to keep talking, John.
This is a toxic server, dude.
All right, what's your close? We'll give you 5 seconds. What's your closing statement?
Stay in school, kids.
Okay, bye.
All right, that's John, ladies and gentlemen. Thank you, John.
John seemed like a vibe. He was pretty cool.
I mean, overall, like, he seems like a nice guy. It's just this conversation will trigger people because they can't fathom anything but the globe. And
Mr. Tides,
you figure after you told them.
Brilliant. John's passing remark in the side chat is Jedi is a virgin. I mean, this is the standard that we're dealing with, guys.
I know, right? Seemed like a real cool. Yeah, you still think he seemed like a cool guy. I mean, he just heard that there's no measurable surface curvature, and he went on to ask, "What about the sun?" So he didn't want to learn how anybody is making that claim or why anybody's making that claim. He didn't want to ask about long distance observations and how would we know any of this stuff. He just went on to ask about the sun and what do we know about the sun.
And here's the weird thing, right? Like, here's the weird thing. We were all taught the Earth is too big to see the curvature of the Earth, right? So we know it's flat, but somebody else has to tell us that it's curved. So there you go, John. If you're listening, like, you know the Earth is flat. You knew it was flat all along. You just chose to ignore your senses and go with what somebody else was telling you. You got fooled like we all got fooled.
Well, please, I'm banned from these side chats by someone. I don't remember who. But I was banned to watch a video. So I did watch most of the video. Yeah, so I'm here to provide the conclusion or summary of what I watched for Mr. Adam Unsalted.
Go for it.
Just so you know, Mr. Tides, you are hot miking, so just be careful.
Okay, so in the beginning of the video, he showed the, from what I remember, I'm not looking at the video right now, he showed something like a flat earth map with Greenland in the middle, and then he was talking about, is it 16th or 60th, like, ring of the earth, and then like, we can't go past the south part of that. I know I'm not putting the words clearly, but like, you get what I mean. Yeah, so we're not allowed to travel down there without like heavily guidance and stuff. And then animals aren't allowed to travel there. And then yeah.
Right. So does that make the claims verifiable necessarily?
Well, it does make the claim that Antarctica might be an ice wall a little verified, yeah.
Verifiable, like how verifiable are claims from Antarctica, particularly inner Antarctica?
Well, I don't think any claims in Antarctica will be verifiable since, you know, Antarctica is this place and then we aren't allowed to see most of it. We're only allowed to see the tippy tip.
Yo, pause.
Hey, just FYI, y'all, I muted Mr. Tides because he was hot mic. If y'all want to talk to him, just unmute.
Oh, by the way, could I get unmuted from side chat?
So, like, Antarctica may as well be like outer space, right? You know.
Yeah. And then in the video, they compared Earth to like a ring magnet. And they were showing how stuff can stick onto it and stuff.
Is that all? Or do you have other things to add? I don't even know. What did Adam and Salted, can you summarize what he presented to you so that way we have a little more clarity on what you're specifically interacting with?
It's not here. I think it was Antarctica's Closed, that YouTube video, I think.
Also, over fences for like 3 months now or something, he's been calling me a troll. And I'm not a troll. I'm a real person. I have my own thoughts and stuff, so I'm not a troll.
Trolls are real people that have their own thoughts and stuff.
Damn, over fences, you're gonna sit there and take that?
Guess so.
Damn. No.
So yeah, just to clarify, if I'm acting like a troll, I'm very sorry. I'm just here to provide my insights on these topics.
What do you think about geometry?
Real quick, before you answer that question, I want to respond to you about what you just said about being a troll. Like, so just so you know, some people have concerns with you changing your voice. And so we're very honest people here. So if you're changing your voice, like the best thing you can do is just use your real voice. That's more important than anything else.
Okay, so you're saying my voice is getting on your nerves, right? So should I just like deepen it or what?
No, your voice is not getting on our nerves. We just want you to be yourself, not try to be somebody else's voice. Don't change your voice. Don't change the sound of your voice just because you want to do it for humor. That's something that trolls do. Trolls do things to mess with other people's minds and it's a very dishonest thing. So if you're going to be honest with us and you want us to be honest with you, it's best to establish yourself as yourself and not try to pretend to be something else.
Okay, I'm gonna be 100% honest here. Number one, I'm not using a voice changer, but I am putting on a voice. Like, it's kind of stressful to do this voice, you know? It's kind of hard.
Why do you do this voice? Why don't you do your regular voice? Be yourself.
My regular voice is, like, since I'm in Africa, I have to speak pretty deep to people, so my regular voice is a little deep, so I don't think it will help.
Go ahead, give it a shot.
Oh, really?
Why not?
Okay.
They're really deep, bro.
Anyway, so what were you talking about again? Somebody asked me what is geometry, right?
Dude,
No,
you sound perfectly clear.
I ask you, what do you think about geometry?
Geometry. I only know the basics of geometry. Probably a little more advanced than basics, but like, you get the gist.
Okay, if we have a pyramid and pyramid is 700 meters, how we will know that that pyramid is 700 meters?
You ask the person that built it.
I'm asking simple question.
Yes, and we ask the person that built it what the height is.
How you will know that that height is real, 700 meters?
Because he built it. He built it.
He built it. I can build now house, and I can ask you, how tall is my house?
How the hell would I know? How tall is your house?
Okay, great. How we will find out how tall is my house?
I ask you, go take a ruler and measure.
Okay, but how you will find out?
How I will find out? Why would I need to know the height of your house?
Okay, can we do the same thing with the Earth?
No.
Why?
Because we are not like 1/3 the size of our house. Earth is gigantic.
Okay, how gigantic Earth is?
Okay, Earth is very gigantic. Like, very gigantic.
Is it there a number, or is it 2 million miles?
Oh my god, I'm never going to say it's 2 million miles. It's a set measurement, but I have to Google search that measurement right now because I do not know at the moment.
Did you know that all of us did that years ago?
You're saying years ago like I'm a kid. Like,
okay, you're a kid.
Like,
you can watch. You're a kid. You can look it now. You can look it now and see how big Earth is.
Okay, but which side do you want? The radius from the horizontal axis or the radius from the vertical axis?
Radius. Okay, radius.
Which radius? From horizontal or vertical axis?
Radius is 1.
Radius is not 1 because the Earth is not a perfect sphere. So the vertical.
I'll say this, Sasha. There is a polar radius and an equatorial radius based off of what NASA presents.
Okay.
But the 3959 is an average of all the radii.
Okay. If he has some another number, he can say, okay, it's not 3959, it's 3958.
That wouldn't matter much at all.
Yeah. No, I think the polar radius is 3950 and the equatorial radius is 3963 miles.
Yeah, I think it's something like that.
Yeah, what will give
a 13-mile difference. 13 miles out of 3,959 miles or whatever, like a difference of 13 miles it might as well be a sphere. It's 13 miles ain't nothing in the big scheme of all that.
Yeah, but with that given number, will give us that with our height, how much we can see in distance with that given radius.
Like, I'll give you an example, easy. Draw a circle or draw an oblate spheroid where the equatorial radius is 13 millimeters shorter. Like, do a 3,000 or 24,901 millimeter circumference circle with the polar radius 13 miles or 13 millimeters shorter than the equatorial radius. I guarantee you it's going to look like a
all my
sphere.
books at home. I can't draw.
But it's going to look like a sphere. It's not going to look like a...
yeah, it's going to be like almost a perfect sphere.
Sorry, go ahead, Sasha. My bad. I just wanted to clarify that. People get all nuanced about an oblate spheroid, and it's very close to a perfect.
But it is good to say that Earth is an oblate spheroid instead of a spherical plane.
Why?
Because the reason is are you hot micing, Jedi, or are you gonna
Sorry, I
say
do apologise. Yeah, no, it's not. Yeah.
Okay. Well, what I was saying is that it's very good to say that Earth is an oblate spheroid, because even though it may be just a few miles, it's really how do you put this? It's really important to how measurements are made and discussed, because if it was a perfect sphere, does a perfect sphere even exist? Like, does a perfect circle even exist?
No. But how do you know it's not a perfect sphere?
Well, how do we know it's not a perfect sphere?
Yeah.
Well, you don't really, according to NASA, this I've not conducted it myself. Why am I stuttering so much today? Anyway, according to NASA, the Earth is an oblate spheroid because it's too tiny to be an actual sphere. Like, Jupiter is more of a sphere than Earth because it's gigantic and its gravity is bigger. And then because its gravity is bigger, it pulls the stuff closer to core.
Okay, I mean, that's a lovely story, but that's not telling me how we know the story's true. I'm asking you, you understand the difference between a perfect sphere and an oblate spheroid. The surface would still curve, but on the oblate spheroid there'd be a change of the rate of curvature, but there would still be curvature. I'm asking you how that change was measured. So we know that it's an oblate spheroid because when we measure the surface of the Earth, it's not always curved the same amount.
Okay, so the reason we know, like, we don't really know it. We don't know anything in life, but yeah, we don't know if we have hands or not. But like, apart from that, we don't really know if the exact dimensions of it. But
really, we don't know its radius, diameter, or circumference.
What?
Radius, diameter, and circumference, the values that go along with the Earth, its size and dimensions. We don't know these things?
No, we know them. You're confusing it. Like, it's a normal measurement, but like,
What measurement? What?
Okay. We have the measurement because everybody on Earth took a ruler, put it down, and then attached some string to it.
Okay.
Of course not. That's not how life works.
Sorry, that's not how we... Sorry, I appreciate your vague analogy of using a ruler, but that would be just using a straight edge to measure a deviation from horizontal or an elevation.
Do you know how to calculate a curve on a map? Do you know how to do that?
Excuse me. We've let you talk and talk and talk, and we've been very patient with you and really have tried not to interrupt what you're saying. Why are you talking through me?
Sorry, sir.
I appreciate the ruler idea, but we can survey the world, right? The land upon which we build upon, the level of the building, your floor is level, right? The building is fucking straight and true. We understand these things because we survey the world around us. We build, for example, upon a level. A level is a straight line from left to right. Its orientation in this instance is horizontal. That's perpendicular to vertical. You know, up and down.
Yeah, up and down.
Yeah, we can measure these things on the surface of the Earth. That's how we build upon the surface of the Earth. Like, for example, the tunnel underneath the English Channel that connects England to the rest of Europe. We can measure the Earth. When we measure the Earth, we measure the Earth to lay horizontally over distance, not curving.
Well, yeah, that's true. But speaking about levels, that just gave me an idea. Thank you for the idea, sir. But couldn't we just use a leveler to find out the curvature of an Earth?
Yeah, we use things like laser levels.
But
so a
still,
laser level will be a laser level will be a transit of a spectrum of light hitting a receiver, most commonly an optic or a reflector. This is how we survey the land, for example. When I brought up the English Channel Tunnel, that was using laser spectrum analysis across the English Channel from one coast to another. That's a direct measurement of the surface of the Earth. So when we survey the land, it's flat, shock horror.
Yeah, I understand, sir. I'm gonna keep quiet and recollect my ideas because I'm having a brain fart.
No problem. It's just because you seem to think it was impossible to measure the Earth, but we do it every day.
I never said it was impossible to measure the Earth.
But yeah, you started bringing up the analogy of the ruler, and like, oh yeah, I'm going to get my ruler out again. Like, kind of like pouring fun of the idea that we measured the Earth. We obviously measure the Earth, dude. This is how we like live on it, and this is how we navigate. This is how we construct like engineering projects on and under the surface of the Earth at huge distances. We even have to make the water flow. Now, understanding how water flows, you'd most definitely come to the understanding that the Earth can only be a horizontal plane.
Well, that is not really true, because according to what I learned in physics class, wait, I'm coming to change your voice. According to what I learned in physics class, my teacher, Miss Juliet, that doesn't matter. Anyways, she said that gravity, it depends on how big the object is. So if we have an object and another object next to you, let's say you have it, like take anything, it's an experiment right now. You have any two objects, sir?
Yeah, my head and my phone.
Okay.
Are you going to tell me that? Are you going to tell me if my head was big enough and my phone was big enough, my phone would orbit my head?
No, not at all, sir. It will actually crash into each other. But that's besides the point. That's besides the point.
I mean, that's interesting and all, but we measure the surface of the Earth to be horizontal. You seem to be coming up with an idea that creates curved surfaces. If your gravitational story was true, then the surface of the Earth would be curved. Something we would observe, something we would measure, something we would actually practically have to take account for. But we don't do that. The surface of the Earth is observed, measured, and practically taken account as a horizontal plane. So I don't know why you're bringing up a story that creates curved surfaces. The Earth isn't a curved surface.
Sir, wait, how do I say this? Okay, you didn't allow me to finish my analogy. So, I
do apologise. If you feel hard done by, I'll stick myself on mute and you can continue.
Okay, sir, thank you. So, your head and your phone, right? both of them are attracting each other at a set mass, like at a set gravity, like they're attracting each other with gravity. But that gravity is so insignificant that you do not count it when you're measuring force. Now, if we were to get a slightly bigger object and another slightly bigger object, and we were to put them next to each other, they'll also have a force of gravity connecting to them, but it will still be insignificant. This is because gravity is the weakest force known to man. That's why we can jump up and fall down.
That's
Very
nice.
easy.
What's this got to do with the surface of the Earth, though?
Sounds like you're reading from a script.
Breaking up. What did you say?
What's this got to do with the surface of the Earth? I was talking to you about how we measure the surface of the Earth, and now you've gone out into this realm of, big things being attracted to other things very weakly. I don't understand unless you're going to tell me that eventually, if the things become big enough, then the things that they will create will be curved surfaces, like spheres in the vacuum of space. I mean, that's the only reason why you can be talking about what you are at the moment. If you're trying to address what I said, I hope.
I should explain how gravity makes things spherical, right?
Okay. So that would mean the surface of the Earth would be curved.
Yes.
We don't measure that.
May I do another analogy?
Yeah, if that one wasn't good enough, I'll give you another go.
Like on top of that analogy.
Oh, on top of that one. All right then.
Yeah.
You want to, mate?
Do you have any flat objects in your room, like a bunch of soap?
Yeah.
So take two soaps, flat soaps, and then put them next to each other.
Okay.
Okay. Now that they're next to each other, find the center of the soaps.
Okay.
You see the center?
I mean, yeah.
Now, according to physics, that's where gravity acts upon. So, when the thing gets bigger, the gravity is not only pulling to another object, it's also pulling to the center. That's why we have center of gravity. Now, because of this center of gravity, when the flat soap becomes bigger, it all gets, since the center is where the gravity is getting attracted to. Why are you laughing? Anyway, so all of the soap stuff come into the middle, and then they become round because that's how gravity.
They become round. That means the surface will be curved?
Yes, the surface might be curved.
That's not what we measure on the surface of the Earth. The surface of the Earth measures to lay horizontal over distance. Horizontal is not a rate of change of slope.
Yeah, what does that have to do with my analogy?
What does that have to do with it? Mate, you're giving me a creation story of spheres. Like a ball, you said. The consequent on the surface of a ball is that surface is curved. I assume, and forgive me if I am incorrect, you're trying to make this analogous to the Earth, meaning that the surface of the Earth would also be curved. Curvature is a rate of change of slope. When we measure the surface of the Earth, we measure zero slope. That's horizontally. So the Earth is measured flat. Why are you bringing up creation narratives for a sphere which the Earth most definitely is not measured to be?
Okay, now you're saying the Earth isn't measured to be a sphere, but that's not what I'm getting at. I'm not talking about this specific measurements. I am talking about the fact that if you get something, there will always be a center, like a center that it will gravitate upon on.
Guys, I don't get it. What is this all about?
At the moment, this guy's trying to tell me that curved lines are straight lines.
No, that's not what I'm saying.
You're saying that gravity forms balls. That's a curved line. I'm telling you, the Earth measures flat. That's a straight line. Are you trying to tell me that straight lines are curved?
I am not telling you straight lines. You know what you're doing? You're bringing up, like, let me use another, like, analogy.
Easy.
You're bringing up the horizon when I'm talking about space.
Easy.
I didn't say anything
Easy.
about
Can you hear me?
Yeah, sorry.
Easy. Can you hear me? Okay. Again, you've heard all of these arguments plenty of times. I don't think we should be wasting time on somebody who's heard every single long distance observation, been given countless stuff to go and research, and then you still coming back in here playing stupid. It's ridiculous. So if somebody else has any questions, hey, listen, I'm over it, man. So is a lot of the people that have been listening to you for I don't know how many weeks you were in here before. But I know if DJ was here, he would not be wanting to listen to this junk. So if anybody else has any questions, that'd be great. We can move on.
Is anyone here a flat earther?
Yes.
So you're basically debating on whether Earth is like flat or spherical.
Yeah, if you want to debate an objective subject, yeah, I guess.
Well, but we need an opposing like side, because I guess I'll take the side I believe in. So the Earth is spherical.
Okay. So why do you say the Earth is spherical?
Okay, there are actually like lots of reasons, even the ones you can prove to yourself.
Should we start with those ones? Those sound interesting, things that I can verify for myself.
Like if you have like a basic telescope, you can see Saturn, Jupiter, you can see Mercury, especially Mercury. If you know it makes lots of revelations around sun per year. So Earth, it takes Earth to go one time around a sun, 365 days, right? For Mercury, it's so it's closer to the sun, so it's rotating faster. And from the movement on the sky, you can actually like draw on the map, but it will be like a 3D model, like on paper, that it's moving around object and it goes behind the sun.
So when you get your telescope and you look at spheres that move like Jupiter and Mars, how do you also know that the Earth is a sphere that moves?
Look, starting from the orbits.
Okay. How do you know the Earth is like those things that move in orbits in the sky? For example, you're claiming that they move. When I stand on the Earth, I don't feel any motion of the Earth. I just see the things in the sky moving. So how do you know that we're moving also?
No, you don't feel that you move, because it's the same as in the train. You don't feel like you move unless you accelerate.
Or go around the corner.
But Earth is not accelerating.
Excuse me. Or go around a corner. Like in a circular path, you feel that. That would be analogous to your idea that the Earth is in orbit, a circular path around the sun. The Earth's not going straight in your model. So why are you talking about a train that's going straight? To make the analogy fit, the train would have to go in a circular path, and you'd feel that.
No, actually, we're not going around a roundabout here. Actually, I don't like the ideas of analogies when it comes to like materialistic things.
Okay, I'm still trying to ask you how you prove the Earth is like those things in the sky.
We have satellites.
Okay, can you prove that they rotate around a sphere?
look, actually,
yes,
if you look at the sky, have you ever noticed like little stars that move?
Yeah, things in the sky that move.
Have you noticed that it became more like frequent than it used to be like 5-6 years ago? Because actually, look, 4 years ago or 5 in 2020. On the sky, it was 4,000 satellites, and right now, at the moment, it's above 13,000.
More things in the sky. Okay, there's more things in the sky that move. Okay, and
so if Earth is pulling it down, yeah.
What?
Why is it not falling down?
Sorry, wait, what?
Why are they not falling down?
I don't know. Why are you saying the Earth is pulling them down?
Because of gravity.
What's that?
The same reason when you jump and then you fall back.
The same reason that when I let gas go, it comes back, right?
Gas, look, gas has less density than air. Air has
less density. Gas, sorry, hold on. Gas has less density than air. Air is made of
mixture of different gases. Yeah,
mixture of different gases. The air is mixture of different gases. Oxygen, nitrogen. They expand.
It's different, but look, you can even prove that it's pulling down just because of the pressure. Difference in pressure at different heights. Look, you go to mountains. There is less. There is
What's
less
the cause of pressure?
It's harder to breathe.
Excuse me. What's the cause of pressure?
Density?
No, not density. Density doesn't cause pressure. What causes pressure, gas pressure?
Force over area.
Force over area. The force that the gas exerts upon the walls of its container. To have gas pressure, you require a container. If you don't have a container and there's more available volume to fill, the gas will fill it.
So why is it not leaking out?
Because we're contained.
How are we contained?
By a container.
What container?
I don't know. The one that causes gas pressure.
Why is it different at like different heights?
Because there's gas production that takes place primarily on and within the surface of the Earth. Oxygen cycles, nitrogen cycles, the absorption, reabsorption, dissolution of gases and liquids on the surface. There's more of it down here where it's produced and circulated.
That's a solid point. I don't even notice. Not because it's not something that I really agree. Because I mean, what you.
I mean, you didn't think science was that simple, did you?
Oh my gosh! No, I know.
It's not that you don't agree. It's not an agree or disagree general of what he told you. It's not like politics. The gas pressure is the force that the gases exert on the walls of its container. That's not an agree or disagree thing. That's the way it is.
No, about what he said, that the reason why it's different, the pressure is different at different heights, is because the production of gases or circulation of gases takes place like closer to us, where all the grass, trees.
We don't disagree.
Makes total sense. Silence.
Where's the density of the gas the greatest?
Sorry, what did you say? I didn't hear.
Where is the density of gas the greatest? Do you want the answer? Where it's produced?
No. You know the metal things, aquanauts, like the people who go underwater, swim underwater. They have these like bottles with pressurized gas. There is a lot of gas, like contained in the.
Yes.
This is where.
What happens when the diver breathes and opens the valve inside the container? Does the gas come out?
Hold on, I don't understand this.
The answer is yes, because that's how the diver breathes. Right, he opens the valves by the inhalation, and the gas comes out and fills his lungs. Right, that's the high pressure in the container on his back, moving into the lower pressure environment of his lungs. High pressure fills low pressure environment.
We know, high pressure fills low pressure. So
good. Good.
If there is no gravity.
Oh my God, he's going to bring up gravity again. There's no gravity in the second law of thermodynamics. There's no gravity in PV equals nRT. There's no gravity in gas behavior.
Okay, fair enough. Wait, Jedi, I have a very a straightforward question for you. That if really Earth is flat, then this is unexplainable.
It really is flat, though. That's the thing.
Huh?
It really is flat. That's the problem.
After his convincing argument, so yes.
I mean, the Earth is too big to see curves, so you already know it's flat, right? I mean, the Earth is too big to feel any motion, so you already know that it's not moving. And then you know that you can't have gas pressure next to an open system because all the air would go and fill the available space. There's not a single force in the world or in the universe that could keep gases glued to a ball next to the vacuum of space. And when I say vacuum, it's not a sucking power that's going on in outer space. It's just a void of matter, and the void of matter makes it easy for gases to go and fill those available spaces. So gas should have really just gone away from the Earth 4.6 billion years ago.
But from the other point, if you look at Mars, so scientists believe that Mars used to have a lot of gas in its atmosphere, but because unlike Earth, it doesn't have magnetic field, strong magnetic field. It actually does have magnetic field, but like way weaker than.
Yeah, okay, buddy.
So the sun winds of Ionic, we actually get it. Like
have you tested this before?
I saw the lines on the sky, green lines from that's when Ionic like that's I don't know if it's matter, if it's particles, but this is what comes of from sun.
You're talking about like you're talking about the Northern Lights?
No. You know when you go to
Aurora Borealis?
Polar lights. I'm not sure.
Yeah, the Aurora Borealis, the green lights of the north.
Yeah. And why are they seen only like in northern area?
I don't know. It's a crazy phenomenon, right?
Mm-hmm. And another thing, why
it doesn't prove that the Earth is a ball.
Look. Why is so I've actually been to Australia myself. I saw moon being upside down. I swear.
Yeah, that's because you're looking at it from the south, not from the north.
So the moon is not moving like
so the moon moves between the tropics, right? Just like the sun does.
So that it can be seen from any point of the Earth, like at the same time.
I'll give you an example, right? If we're standing in your living room and I draw a number 6 on your ceiling, and I stand at one end of your living room and you stand at the other end of your living room, and I label my end north and your end is south, and I look at the 6 and I say, oh, it's a 6. And you look at me and say, no, it's a 9. You drew a 9, dude. You didn't draw a 6. It's the same thing.
But hey, okay. Even if this works, but why from one side of the Earth and from another you don't see moon like together? Like if you know that you are at the opposite
side. How far away is the moon? How far away is the moon?
It's 3. It's always different number, but about 384,000 kilometers.
How do you know that?
We can send signal to moon and receive it back. So it's the same way.
How much signal do we send to the moon, and how much do we receive?
We are communicating right now because we have this radio technology. So Wi-Fi, it's all electromagnetic waves.
Yeah, it's done with cellular towers.
And we can send those radio waves to the moon. And we
never done
it back.
You've done this before. I can tell you've never done this before.
So you didn't.
So when they send these photons to the moon, right? They send trillions.
It's not photons.
Right?
It's
do you know what the number trillion looks like?
Look, it's
how many zeros are in a
electromagnetic
trillion?
wave. It's not a particle.
How many zeros are in a trillion?
Bro, that's not the question.
No. I need you to understand how small of a number of photons you get back versus how many photons are sent out. So how many zeros are in a trillion?
12. Oh, wait.
All right, it's a very big number. Do you think you could ever? Do you think you could count to a trillion in your lifetime?
What do you mean?
Do a Google search for me real quick.
Yeah.
All right. Search. How long would it take a person to count to a trillion 1 second at a time?
No, that's obvious.
How long is a trillion seconds?
No, look.
How long is a trillion seconds?
What about your camera, your phone that you are holding? You taking picture of millions of photons. Yeah, it comes
Why are you avoiding
on
my
the
question?
matrix. It's on the matrix because it's not a person who's taking the photons. Yeah, it's not that I'm counting one by one per second, one photon per second.
You don't understand what I'm trying to say. You just cut me off because you're trying to make an excuse. You don't know what I'm trying to tell you. You want me to just tell you what I'm trying to tell you?
I don't know, because you're giving me.
So when you shoot a laser at the moon, right? When you're bouncing sound waves off the moon, whatever you're bouncing at the moon,
sound
bounces back to you. Whatever it is that you're bouncing off the moon, sound waves, light waves, whatever. You're sending trillions of photons, trillions, not just 1 trillion, several trillion of photons to the moon.
How is it trillions?
Listen to me. You're sending trillions of them to the moon, and what bounces off the moon and comes back is like 2 to 4 photons out of trillions. So how do you even know that those photons are the photons that you sent up?
It's not how it works. Like light it's not the particle. Like it can be wave. It's electromagnetic wave with intensity.
What does one photon look like when someone flashes a light at you? How do I flash? How do I flash? If I was to flash a light at you, I want to flash 4 photons at you.
Look, usually you cannot produce.
Would you be able to perceive 4 photons?
I think our eye in the night at night can perceive 3 photons.
So now we're way off on the weeds on this one, man. So you don't know how any of it works. You're just trying to reason with yourself. So when it comes to the curvature of the Earth,
what's your point?
You can't prove that this was ever done, and you've never done it yourself.
What exactly wasn't done?
Bouncing radio waves off the moon.
Okay, fair. But the argument about no, I'm saying that you cannot prove as a person who doesn't have a simple radio. Like if you have a radio station or communications, I used to have a ratio like a policeman's. They have. I had a toy one, so it doesn't work at long distances. But
right. I've had those too. I mean, do you have a ham radio?
What?
Do you have a ham radio?
Not radio, no.
Yeah. So again, like you're just talking about something that somebody else has done that you think they've done it, but you can't verify what they've done because you've never done it.
But isn't that how like the humanity and the knowledge is? Like one person cannot learn and do everything in their timeline, lifetime.
But I've got a bridge to sell you in Wyoming, man. You know what I mean?
It's like gathering of knowledge.
I'll sell it to you for $100.
Like if you have people who do psychology.
You do realize that people will gaslight you and say things just to mess with you, right? Just because they know something you don't, and so they're just gonna like tease you about it. So I don't. You ever heard the term trust but verify?
No.
So let's say and someone said, "But you're sure that check to make sure that they."
I'm sorry, it might be my internet connection or it's just.
He's speaking 3 photons.
What?
We couldn't hear you for like 10 seconds.
Can you hear me now?
Yeah.
Hello. Can you hear me now?
It's coming through.
So
So, and then silence. I don't know if you're still speaking, but we don't hear anything after that.
how about now?
We currently hear you. Speak more than one sentence.
So speaking one word right now, I'm just going to speak until I get cut off. But yeah, trust but verify, man. Like you can believe them. That's fine. Like some people will believe some people, other people, and they won't even go behind them and check them, right? Like if a plumber comes and fixes the plumbing in your house, sure, yeah, most people are going to trust that the plumbing is fixed until another problem comes up. But if you know a little bit about something, you might go in and just double check to make sure they didn't do a quick job on you, right? And so, some of us, we've made a hobby out of like learning how things work in this world. And we like to go in and check what we can behind people that are saying one thing. And we call bullshit on each other, excuse my language, we call BS on each other all the time. It's not just the globe that we're calling BS on each other. We keep each other in check. And that's what good people do to each other. They make sure that we're all walking the straight and narrow together and we're all on the right path. So trust but verify, right? Go. You can trust what they're saying, but if you can verify it, go verify it. If you can't, just say that you can't, and that it's pure belief, and that's all it is. But when it comes to flat Earth, like we don't believe the Earth is flat. We went out and verified it ourselves, so we know the Earth is flat. You're like, oh, that's a bold statement to say, but there's so much science and evidence to support the globe Earth, and it's like they're wrong. I don't know what to tell you. They're wrong.
But what evidence you actually find in that proves that Earth is flat? You actually deny
the lack of curvature. The lack of curvature.
What of curvature? What is it?
Yeah, if I hand you a bowling ball and told you your bowling ball is flat, how would you know that the bowling ball was flat or curved?
I don't get this analogy. Sorry.
You would look at the surface of the bowling ball, right?
No. What do you mean about curvature? Like, from what perspective? Being on the surface, or like?
Well, I mean, if you're just a little ant on the top of a beach ball, there's still a rate of curvature going on the ball.
Because it's kind of small comparing to the.
It's not as big as you think it is.
Like the
24,900 miles is really not that big.
But that's around the Earth.
Your eyes are better than you think they are. They're not perfect.
So,
but they're better than you think they are.
So
we use our eyes all the time.
What is about?
We build things all the time by eyeballing things.
So what about the curvature?
Yeah. So if the surface of anything is not curving, then the surface of that thing must be what?
But isn't Earth curving? Like when ships go behind, like
I'm not even talking about the Earth. I'm just asking a basic question so that you understand logic. If I give you something and it has a surface, and I tell you that it's curving, and you want to know whether or not it's curving, what are you going to do? You're going to measure it, right?
No,
you're going to look for curvature on the surface.
Actually, it's a simple geometrical question. You just build a triangle. Build a triangle, because on the.
You don't even have to build a triangle. You just got to draw a straight line. You just got to draw a tangent over the surface.
If the Earth is flat, yeah, any given 3 points on the planet, you can join them together and measure angle, right?
Yeah.
And the sum of those angles will be 180 degrees, right?
Absolutely.
Yeah. if it's spherical, and you do like on purpose 90 degrees,
no,
90 degrees.
No,
you can't do 90 degrees on a circle.
You, so I mean, like you
already said it.
Where?
A triangle has 3 straight lines.
90 degrees. Sorry, 90 degrees is the intersection of 2 straight sides. You can't have straight sides on a sphere.
90 degrees. It's not straight.
That's 2 straight sides.
Yeah, he wants to do 390 degrees.
No,
he wants to do 390-degree turns and say that he's got a triangle with 270-degree internal angles. What the heck, bro?
No, that's actually what it is. Like 90 degrees angles from 3 points, and they all join.
That won't make a triangle. That will not make a triangle.
But that's on a sphere.
Yeah. If, for example, you have one vertex at the North Pole, one side following down a line of latitude, meeting the equator, and that circumference along the equator being a quarter of the circle, and the line back up from the end of that quarter back up to that. Yeah, that's spherical geometry.
But yeah, I can agree that to build it such a triangle on Earth and do the proper angles. I mean, for a single human being, it's like a very.
Has anyone done that? Has anyone done it?
For a single human being?
No, like how you imagine it's not gonna work on like near your house in your garden. It's like a big triangle you need to build.
Yeah, it has to be a massive triangle. For example, 2 sides have to be the distance from the North Pole to the equator. One side has to be a quarter of the circumference. It's the only way you can do it.
Yeah.
Has anyone done it?
You would still need the radius value to know that you're doing it correctly.
In theory, actually, you can do this. So using radio again, I mean it's basic, but you can send signal to one of your friends like that way, and so horizon is 360 degrees, and you just know he's like there, and then you measure like roughly 90 degrees like to the left. So
that's a circle of equal altitude.
One friend is directly in front of you, and contact another friend that is like left to you, and so this will be 90 degrees.
Yeah, these are azimuthal angles. We can replace the 4 people with north, south, east, and west around you at the center of the circle.
Yeah. It's not proving the shape of the ground because Marconi sent a signal from England to Australia, and they're opposite sides of a sphere, which we could also say that it was just a line of sight because it was being projected over horizontal plane.
So we have
you're just assuming that the assumptions you're making are true, and you're not validating that the assumption you're making is true.
No, but look, England. So in this case, England, then Australia, and maybe South Africa, and then it's not going to be 90 degrees, but it's going to be more than 180 degrees. So it's the surface is curved in the geometry.
Yeah, we measure Euclidean geometry on the surface of the Earth.
Yeah, I guess maybe another argument why, like, it's not even an argument.
That's a hypothetical.
It's more like a question to those who, I don't know, have alternative way of explaining the thing. How shadow on the moon, like from the Earth, like how
doesn't work.
Gosh, Marian.
Yeah,
bro, let me explain something to you, okay? Whatever is happening in the sky if the surface of the Earth is flat, whatever is happening in the sky only happens over a flat Earth, right? So what you really need to do is you need to draw a tangent over the ball of the Earth, and then you need to measure the deviation from the tangent over distance.
When moon is getting completely
occurring here on Earth.
dark.
Problem is,
retard.
Yeah, it's happening over a flat Earth. Why? I don't know. Because that's what happens in its cycle.
All right, question. So if the floor of your room is underneath two objects on your ceiling, how is the floor casting a shadow from one light source to the other object on the ceiling? Simple answer is it's not. The floor is not casting a shadow on the moon. The Earth is not casting a shadow on the moon. So whatever is happening on the moon, it's not due to the Earth. What you're doing is you're taking the flat Earth and putting it in a heliocentric model and saying, hey, this is it.
But
I'll put it to you this way. Once you find out, hold on, Marion. Once you find out that the surface of the Earth is flat, the entire story about what you think is going on in the sky is completely wrong. Now, we still see the moon, the sun, the stars, and the planets. We don't dismiss those observations, but the story that's attached to it is completely wrong. So when you say, how do you explain this? How do you explain that? I don't need to. You need to explain why the surface of the Earth doesn't measure curvature.
Yeah, but I mean, it explains a lot of things, especially like red moon. Why is
bro? There is no way flat Earth before GTA 6, bro. Very easy. Wait, what?
I'm still trying to figure out what it is about an eclipse that proves that the Earth's a sphere.
No.
Wait, apologize, guys. Apologize.
Shh.
You can continue, guys. Oh, you can continue, guys. Wait, why there's nobody talking? What happened?
Why? I
don't know.
Okay.
Are you? Did you have a question, Handsome?
Happens locally on Earth. Like if sun is above us and the whole surface of the Earth is flat, why is then like night and day happens and we all have different time zones?
Sun moves. It's like
no, bro. Because if you go to space. If you go to the space,
I want an answer. It's okay. I'll tell you what. You ask the questions and answer them yourselves. You're asking how day and night works.
Yeah.
It's like it's a light source that moves over the surface of the Earth. Depending on where you are, it will appear a certain way. As it traverses over your head, for example, it will appear on one horizon, move across the sky towards the other horizon, and carry on going. You're asking how day and night works when day is dictated by when we see the sun in the sky, and night times when it's dark and we don't see the sun in the sky. It's like, what else do you want me to tell you? The sun's moved.
But it isn't like flat earthness is just denying every single fact.
Like what? These facts are they denying? Are they self-evident truths? Are they? Give me a fact. Let's see if it is one with regards to your claim that the Earth is a sphere.
Scientific facts you don't take into account because all those scientists they
like what? For example, a scientific fact will be based on a hypothesis that's repeated through experimentation. What one of these scientific facts pertains to the shape of the Earth? I am speaking English, right? You do understand what I'm asking you, yes?
Yeah, remember you said that the shape of the Earth is a geometry question, not a science question, remember?
We are dismissing scientific facts. To say it again, scientific facts are based on hypotheses. That's a prediction of what causes something else to happen. That hypothesis is tested through an experiment where you see if it causes that to happen. Now, which one of these scientific facts pertains to the shape of the Earth?
I don't know. You tell me.
Neither do we.
Well, it's an oxymoronic question, right? Science, and I told you, deals with the prediction of phenomena. What makes that happen in the physical natural world? It elucidates causes of phenomena. When you're trying to figure out the shape of an object, you're not going to employ the scientific method. Right? So there could not be any scientific evidence for the shape of the Earth, whether it was spherical, whether it was flat, or whether it was a fucking three-dimensional rhombus or something. Science doesn't answer identity questions unless the identity is the cause and the phenomena.
Hey, y'all, give me a second. Hey, Jada or Elijah, do y'all know who Charlie Kirk is? Jedi?
Mm-hmm.
You know who Charlie Kirk is?
What?
Charlie Kirk.
Charlie Kirk.
Oh, Charlie Kirk. Oh, yeah, I know who he is.
Yeah, he just got shot, dude.
No fucking way. Serious?
Seriously, dude.
Whoa, okay, give me 5 minutes, man. I've got to go and see what this is about. Thank you for letting me know, dude.
Yeah. I'll put a video on my chat.
No, that's newsworthy, man. Like, thanks, bro.
Guys, I was thinking about like a thing that you can maybe see by yourself, not like scientific stuff that you can of course deny. Like I was really thinking about like
I looked out at the horizon, and the horizon wasn't in the location where they told me it was. That's why I'm a flat earther, because I know that there's no measurable curvature. Whatever's happening in the sky, if the surface of the Earth is not curving, the surface of the Earth must be flat. If the surface of the Earth is flat, then whatever's happening in the sky can only happen over a flat Earth. No matter how ridiculous it might sound, if the surface of the Earth is flat, it's only happening over a flat Earth.
Except for the stars, because you can map all of the stars spherically around us, because you don't see all the stars.
Due to perspective. That's due to perspective. That's due to your observation, where you are at, and where the sky is above you.
You move.
Has nothing to do with any sphere other than your vision.
And you see different set of stars. I mean, on one side of the sky, from where you came from, it's the same stars. Maybe some side of them, but new stars.
I'm going to tag you in a video, and I want you to watch this video where an airline pilot flies from the northern hemisphere to the southern hemisphere, and I want you to see what the stars are.
Okay. So, but it's a close picture. Like if you walk around the Earth and map all the stars.
How do you do that? How do you map stars?
Look, if the Earth is flat, yeah,
how
then you
do
can
you
only
map stars?
You just draw them. Like you
just draw them. let me ask you, how high is that star, let's say Polaris, above the horizon? How would I measure that?
But you don't need to measure that. You just look. You just You do the picture, yeah, wholesome picture.
It's based on your location, its direction due to your location, and its movement across the sky, and you measuring that location and movement in vertical elevation angles or horizontal azimuthal angles. I'll cut this short. For you to map the sky, you require a horizontal plane to measure from. Because, like I said, every measurement is going to be a measurement of an angle.
Not necessarily, because all you need is relativity. So you take one star, and then you start mapping all the stars from it, yeah? But then when you start moving on the other side of the Earth, you see on the horizon all stars that you already mapped, and you have new stars. And that's at some point when you get even like further, around the Earth, you see completely new set of stars. But then if you go more around the Earth, you start to see the same stars that you saw.
Wow! It's like, do you get confused when you walk around your house? Yeah, we see lots of things, and dependent on their motion or your location, they will appear in a certain way at a certain time of year. Now, we measure my friend, shush. We measure, that's the physical measurement that we're going to do to map how the heavens appear in the sky. We measure angles of elevation. For example, not only a solar elevation angle. That's the elevation angle of how the sun appears in the sky at a certain time in a certain location to an observer. For you to map the sky, you require a horizontal plane to measure from.
Well, yeah, you can't get an angle from a ball. You have to have a flat surface to get an angle from.
Yeah.
I'm still trying to figure out what this all has to do with relativity.
I mean, I was going to ask that, but I just let it go because I think it didn't.
Well, yeah, he just threw that word in there just to think that it meant something, and it doesn't mean anything. It was meaningless.
You just have to put yourself on another star, and then all of a sudden you got a whole new set of stars to look at.
But you don't answer the question.
So stars are flat then? If you're on a star, to get an angle to another star, you'd have to be on a flat star?
This was not the initial question. I asked this 5 times. So if the Earth is flat, why don't we see all of the stars, like all of...
Because the sky is really big, and you only have a certain field of view of the heavens. As you move under the heavens, you see more stars. When you go around and follow the stars that are circumpolar, rotating around an axis in the sky, you might see the same ones eventually that you started mapping before because you went around a circle, probably.
Look, maybe I don't understand what exactly you mean, like when you explain things, because I'm not familiar with the flat Earth model.
Okay. No, there is no model, Marian. Let me ask you this. Why do you keep saying if the Earth is flat, then it has to look this way?
Like from the physical principles.
Of what?
What do you mean, of what?
So if Earth is flat, then water must be flat and level. But those kind of physics, yeah, okay, we get it.
No, if the Earth is flat, what principles are you basing all your observations on?
What do you mean? The Earth is flat, and I don't know. I'm trying to understand.
Well, you think you know how everything's supposed to work on a flat Earth. So, what principles are you basing this on?
I'm just trying to get and understand your view on that.
You see how that puts them up, y'all?
You're trying.
So here's the problem, right?
Because
all you got to do is look at the surface of water. Go ahead, Sasha. Get him, Sasha.
No.
He doesn't know
what man, you don't know with what to compare. You said you're always saying if
Earth is flat. What Earth flat you are imagining?
Spherical. But then when you
Spherical
explain
flat Earth.
things,
You're imagining spherical flat Earth. You're always starting with this. If Earth is flat, is that correct?
huh? No,
You're always starting with this sentence. If Earth is flat, is that correct?
If Earth is flat, yeah.
Yeah. What do you mean by that?
That's what I'm trying to say. Maybe I don't understand how you like perceive the flatness of the Earth. So maybe it's like a coin.
How you perceiving the flatness?
I don't know. I saw pictures online where there is a like ice barrier, and it's like UN logo.
Barrier. No, we're not talking about dumb shit.
Not that. Let's say like a small flat surfaces. How you will say this 10 miles it's flat? How you will know that?
10 miles maybe is not enough.
No, I'm asking you. How you will know that 10 miles it's flat?
10 miles is not enough. The Earth might be flat at 10 miles, bro.
Look, when you have a boat in the ocean, and you look at it, and in 16 miles it will get smaller, but you will see all of the boat, but smaller. But if it's curved,
I didn't mention the boat. I'm speaking about the surface, man.
okay, on the surface it's the same thing. Why skyscrapers on the?
No, I'm asking you a simple question. How you will distinguish 10 miles of the flat surface with the 10 miles of the curved surface?
I guess 10 miles is not like how can you possibly do that?
Are you saying there is not possible that we can have 10 miles of flat surface?
No, you can have 10 miles of flat surface. Like
okay, great. But listen, this is very important. You cannot have 10 miles of the flat surface on the sphere with the radius of 3,959 miles.
By the way, I'm operating in kilometers, so I need to
okay, you cannot have 16 kilometers of flatness with a radius of 6,300 something kilometers.
Yeah. Thanks. Why so?
Because that is like saying these 10 centimeters on basketball, it's only 10 centimeters on a basketball. It's not the same comparison, but you cannot have because of geometry. Because geometry.
The tallest mountain.
You could have maybe visually 16 kilometers of the flatness, but only visually. But sphere should be 10 times bigger radius. That means the distance between New York and London, it's not, let's say, 2,000-3,000 miles. It's 30,000 miles.
I mean, through the Earth? You mean through the Earth? If it's... I don't know. You talking from the spherical perspective, or like...
Well, no, I'm speaking from the Earth perspective. When you go outside and you watch in reality 10 miles, you say 16 kilometers, and you say, look, this 16 kilometers is flat. Then you say, okay, 16 kilometers is flat, it's nothing, it's only 16 kilometers. But that 16 kilometers flat you cannot have on this ball.
Not on this Earth. The Earth is way too small for 16 kilometers of flatness.
But I mean, when you said about it's impossible for like 16 kilometers to be flat radius.
I will give you an 8. You cannot have 8 kilometers of the flatness on this ball. You cannot have even 4 kilometers.
If you talk about like ratios or like possibility or like imagining this,
no, I'm only speaking about the sphere.
Oh, I see. Because look, the tallest mountain, Everest, is 8 kilometers tall, and the whole radius, or like the whole
8 kilometers tall. What 8 kilometers? What that mean? 8 kilometers. What?
That's
from the level of
sea.
And where is the sea from Mount Everest? Is it near?
Oh, not very near, but
how much? Like 100 meters, 100 miles, 1,000 miles?
No, it's actually true. I've been thinking about it. So if sea is very far away and it's curved, how the hell do you tell from where to measure the height? Like, I mean, I'm not talking about spherical like Earth, not flat, because if Earth is flat, then you can maybe measure, like estimate, not very precisely, but estimate the like.
No, we'll measure it from mean sea level. The elevation of the mountain will be above the mean. That's the average of the level. That's the horizontalness of the water. Mean sea level being the horizontal reference datum that you will measure the elevation of Mount Everest from. You can use a right angle triangle to do this if you want to.
But you can't.
Yes, you can. So in celestial and navigation across the seas, this will be. So my friend, no, Church, you said no, you can't. I'm going to show you that the practical application of measuring an elevation angle of a known object when navigating. For example, when we take a running fix, if I can measure the elevation angle of an object in the distance, like a mountain, and I know its height, then I can calculate the distance between me and the bottom of the mountain, working along the horizontal adjacent. You use this practical methodology for, like as I said, when taking a running fix that's navigating across the surface of the earth. You can use such things like lighthouses as well, because we know how tall they are above mean sea level. We put them there at the height, so when we measure the elevation angle, we can figure out our distance between us taking the measurement and it.
Okay, then logical question. Can you see Mount Everest and the top of Mount Everest from a beach, from the sea level, if it's tall?
Depending on how far away I am.
Okay, let's say you were in, I don't know, Bangladesh, Indian Sea, which is like 1,000, okay, in miles it's 800 miles.
Okay.
And then,
if I'm not mistaken, you can see.
Let me write this down.
If I'm not mistaken, Marion, if I'm not mistaken, you can see on certain days Mount Everest from Bangladesh. I think I've heard this story.
No, of course, because it's kind of close from Bangladesh, and because it's very tall.
Yeah.
Right. So you can see it from Bangladesh.
And the closer you get to it, the bigger it looks, and the further you get away from it, the smaller it looks. You can measure the rise and declination of its elevation angle to figure out the distance, or if you know the distance, its height. It's a right angle triangle, dude. You utilize this methodology for mapping the world.
I'm gonna try to use the trigonometry. 1 second.
Well, we were talking about the height of a mountain. You asked what that was reference to. I told you the height is above mean sea level. I told you how we could practically use this piece of knowledge to navigate around the world. Like I said, when taking a running fix, that's a running fix whilst you're in motion, taking measurements to different objects along a coastline, say. So you can traverse that coastline knowing your distances to those objects. The methodology is an elevation angle taken from the horizontal mean sea level.
no matter how you slice it, man, it's all measured from a flat baseline surface. I know it's a hard thing for you to understand because you didn't think it would be this easy, but that's just the way it is, man. If there's no measurable curvature, if there is a lack of curvature, the surface must be flat, right? And then once you determine whether or not the surface is flat, then you know that whatever is happening in the sky, whatever is happening day and night, it's all happening only over a flat surface because you never measured any curvature to begin with.
I don't know. For me, at least, I don't know. Now it still seems like flat Earth theory. Like I still listen.
It's not a theory, man.
It's a closed logical chain system. So what I mean by that, a lot of things you can explain is like a logical chain. I mean,
let me ask you this, right? Based on what the globe says that the Earth is 93 million miles from the sun, right? The sun's 93 million miles from the Earth. It's like 150 million miles, 150 million kilometers, right?
What's your point?
Right. They tell you that the moon is 400,000 kilometers from the Earth, or however far they say it is from the Earth, right?
Mm-hmm.
And they say that satellites are orbiting the Earth, right? Right.
Yeah. What's your point? What's your point? Right.
Well, I'm getting there. Bear with me. I'm just asking you to follow the logic. So you got the moon, you got this distance to the moon, you got this distance to the sun, and you got these satellites orbiting the Earth. All of those are based off of a radius of 6,371 kilometers. Because you have the surface of the Earth that's supposed to be curving at a certain rate, and then all you're doing is you're drawing an even bigger circle around the Earth in order to create the orbit of the satellite. And then the distance from the surface of the Earth to the surface of the moon is based off of the radius of the surface of the Earth to the center of the Earth. Same thing with the radius of the moon to the surface of the moon. These are all geometry questions, right? No science involved. So if you go out there, and we can't test the circumference of the moon, right? We can't test the radius of the moon. We can't test the circumference of the sun. We can't test the radius of the sun. We don't have any direct measurements, right? All we have is like angular sizes. We assume the angular size because we assume the distance to the object, and we assume the distance to the object because of the assumed circumference of the object or the assumed radius of the object. So we can't verify any of those things. So what do we have left? We have the surface of the Earth. Well, if we go out and we check the proposed curvature rate of the Earth based off of what they say the radius is, 6,371 kilometers, if we go out and check that and we notice that there's no measured drop over distance, in fact, things that should be obstructed by the curve of the Earth are now, the horizon's now behind those things. You no longer have a measured drop over distance. It appears flat. So then if it appears flat, then the entire story about what they told you is going on in the sky is complete and utter bullshit. Now, whether or not they're lying, I have no idea, but I can easily just say they're wrong. And that's the end of the story. We don't have to go out and determine whether or not they're lying. If you want to know whether or not they're lying, fine, go out and search your heart out. Hope you find the answer.
Okay, yeah.
Hello.
I got it. Hello. Okay, not debate related. I just wanted to ask: is Moon flat?
I have no idea.
I mean, it only shows us like.
Sorry for laughing.
It doesn't matter, bro.
Sorry, Sheepdog. He told you that these things are unverifiable. We've only got the surface of the Earth that we can verify. And then you ask him, the thing that he said that he can't verify, what is it? He's not going to be able to tell you. He can't verify any speculation he has about the moon. No one can, unless you go there.
You don't think that we think the Earth is like a disc in space, do you?
I don't know. That's what some people imagine. There are 8 billion.
You have gas pressure without container?
There are 8 billion people in the world. I don't know.
Can you have gas pressure without a container?
Yeah. What do you mean?
So what?
Like if you place an object inside like a gas that has
already
energy.
existing gas pressure, and you make the object that is physical collide with the gas, that will cause a dynamic pressure. You know the pressure that you put the object in, how's that caused?
You already told me that.
Yeah. A container.
By container, like, what do you mean?
Physical boundary surrounding the gas, where the gas that has kinetic energy given to it by the temperature that moves freely and randomly in all directions collides with other gas molecules in the confined volume and collides with the walls of its container, causing pressure.
Okay, why can't you have a cluster of gas that is pulled together by gravity?
Because that would be a violation of the second law of thermodynamics. Gas doesn't compress all by itself. Gas has the power of indefinite expansion. Because of the kinetic energy given to it by temperature, it has free random collisions,
like the temperature
creating the expansion.
But where is this kinetic energy came from?
Temperature.
No, temperature is a fact of kinetic energy, not otherwise.
Dude, the temperature gives the energy to the gas. Because the gas always has temperature, whether you think it's hot or cold or not, it will have the power to move.
The kinetic energy of the particles is what we call temperature.
Are you aware of kinetic molecular theory?
Yeah.
Good. So you'll understand that pressure is caused by the force of gas exerted upon the walls of its container, because I've just cited it.
Not necessarily, no.
Okay, then give me a practical demonstration where you have an open system and pressure of gas is caused.
Look, in our hot environment, of course, gas will escape because it has kinetic energy to move randomly in all directions, blah, blah, blah. But we also know that
it has temperature, always going to move, even if it's cold to you. It's got temperature, gonna move.
Okay, it's gonna move, but also it's gonna attract by intermolecular forces.
Yeah, those attractions happen under extreme pressures and temperatures.
So, look, if you have no container, just
the attraction is caused by extreme pressures and temperatures.
Now,
if you want to change the state of matter because you've changed the temperature and the gas, let's say it's water vapor, it's now going to turn to water.
Just look,
that will be under a change in temperature or a change in pressure.
In the vacuum.
In a vacuum? So no gas, nothing. A vacuum is...
If you add gas to vacuum, you have like it won't be a vacuum anymore, but it will be only gas, like closed system without any other
the gas
object.
that's in that three-dimensional volume, now that you've put it in there, is going to move freely and randomly, the volume hitting the walls of its container.
But if you have kind of a lot of it, and it's like a cloud of a lot of gas, not like a...
Please don't tell me that a lot of gas makes gas compress all by itself. Please don't tell me that, dude. That's a violation of the second law of thermodynamics.
All objects attract each other. Yeah.
Gas expands to fill space. Before you're going to get...
what happens on Earth. And of course, like in space, it will also expand because...
gas expands.
It has energy. It will lose energy. It will dissipate. It will spread out. Yeah. What you mean is it will spread out. It will spread out. But when it's in large quantities, when you have a lot of it, it will get pulled by gravity.
No. That's a violation of the second law.
How is it so?
First description of the second law of thermodynamics is a gas expansion into a vacuum. To put it more simply, gas has the power of indefinite expansion and high pressure moves to low pressure. This is a universal law, takes place in all space and at all time. So this always happens.
You just have...
Excuse me. Excuse me. They don't act as one body.
You're saying that if there's enough gas, that the gas that has random collisions, which creates the expansion, will not expand and contract. It's a violation of that law.
Look,
you're saying what always happens doesn't always happen.
Look, from what you said, I imagined like I don't know, space rocket with like astronauts and people, and they have air inside, and then
that's good because they're surrounded by a container.
Yeah, container, and then when this container breaks, I don't know, there is a hole, all air escapes. You're right. That's what I imagine. When you say it goes from high pressure to low pressure, it will happen because in the spaceship, it's the pressure that we have 100,000 pascals, 100 kilopascals.
Mm-hmm.
So the astronauts can survive the pressures out there. And if the pressure changes, we can, like, it's a physical change for the body. So we need to maintain that pressure. And because it's high pressure inside, it will go, like, it will escape because it's high pressure, like highly high pressure.
Yeah. And pressure moves to lower pressure environments, doesn't it?
Yeah, and I think vacuum is estimated. I don't know how they did it. Maybe it's wrong. Okay, it can be wrong, but they say like in the space, even like nothing. It has average number of 5 atoms of hydrogen. So it's not nothing, but it's almost zero pressure.
So ultra high vacuum, deep space, 10 to negative 17 tool.
Yeah, so it will escape, of course. But when you talk about like very large quantities of gas, not like a space rocket inside the gas that was inside the space rocket. I mean, a lot of gas, like the size of solar system. Like it's gonna get pulled by gravity.
So you're just gonna get it.
Do you know about the experiments with balls that proves that even objects on Earth can affect each other gravitationally?
You're just never gonna get it.
What do you mean?
You won't be using gas balls, bro.
Not gas balls. I'm saying on Earth, you can prove.
Do it with gas balls. Do it with gas balls. Why couldn't you do it with
Too
gas
lost
balls?
in your sci-fi
Why?
fantasy, dude.
Why couldn't you do it with gas balls, bro? Why?
Okay, you can do it with gas balls. I mean,
okay, do it. Show us how you do it with gas balls.
How is it to do with proof that of the gravity?
No, there's no proof of gravity. You're making a claim that violates laws of nature. You're saying that because it's on the Earth, the laws of nature don't apply to the Earth. You're saying in the vacuum, which doesn't fucking exist because nature abhors a vacuum.
What is
the vacuum where there's space? Be quiet, please. Out in the vacuum where there's space for gas to fill, the gas will fill it. It's a universal law. It's a law of nature that takes place on the Earth. You're saying on the Earth, the law of nature doesn't take place.
Wait. Different things now. We're talking about gravity now, or still about pressure?
Both.
Oh. Okay, if we talk about gravity, I don't remember what you said.
You're saying that the amount of gas, if there's a lot of it, the gravity will stop the expansion and it will compress. This is a violation to something that always happens. You're saying that the thing that always happens doesn't always happen if you have a large amount of gas.
Gravity-wise, I don't know. What's your point you're trying to make?
You're talking about pseudoscience, bro. It's not demonstrable.
Because
it's not
gravity, you can
demonstrable.
What is the force that is accelerating us towards the Earth? We are accelerating.
That's a loaded question. That's a loaded question, bro. You've already assumed that there's a force, and then you're asking me to describe that force.
No, okay, logical chain. I'm not doing analogies, really. I'm just stating what it is. We know that in order to accelerate, you need force, because force acceleration equals to
not according to Einstein.
No, according to Newton.
You don't agree with Einstein, then? So you disagree with
according to Newton.
But do you disagree with Einstein?
Why so? Acceleration is force over mass.
Do you disagree with Einstein?
That's a very broad question.
But he says you don't need a force.
So you're now saying about like a four-dimensional like a space-time collapse that actually makes objects to kind of get attracted together. So essentially gravity, but without force.
Yeah, he didn't describe it as a force.
Okay.
He described it as the curving, the warping of space-time. Mass warp space-time. Then other objects follow the path of the curve in space-time.
Okay, so why can't a big, massive cloud of gas form curvature in space-time? And
what about the clouds above you? The ones you actually see out in nature when you look up in the sky and you see clouds.
Yeah.
Yeah. Why aren't they falling?
Because their average density is smaller than here.
Okay, so this is a relationship between
that's
density.
buoyancy. That's like in water you use different I think different sets of mass in submarines to get to different levels of underwater. So the same with clouds. They are at different heights because they're different masses, structures. No, like it's all water, vapor, kind of sort of stuff.
So not everything falls down then.
What do you mean? It's falling down when it's forming like raindrops that weigh more than I don't know air. I mean density wise. It's like you drop a rock into the lake and it goes to the bottom. Same with droplets.
At what rate? At what rate?
Rate?
Yeah.
With acceleration?
Yeah. How fast?
I don't know. Fast. Also considering the air resistance, so it's not constant acceleration.
So it's a relationship with the medium which surrounds it. But if you let go of a helium balloon, which way does it go?
It goes up.
It goes up.
But did you know that it will eventually stop when it will reach its density medium? Did you know that it will not go? I don't know.
So it's
to the sun,
so it's a medium. So it's a relationship between the object and the medium which surrounds it.
In relation with gravity. I mean, mgh is the formula. G is gravitational acceleration.
So it's not you're adding the gravitational part into it, right?
No, it's actually part of the formula.
Yeah. You think that there's this thing that is making things want to go down, but that's not what we observe. We, like you said, let go of the helium balloon, goes up.
Because helium is the gas we can measure density of, and it's less than 27 grams per cubic meter, which is air at our level. So the balloon will go up. The same with like when you do when you push football underwater, it will go up. It will float.
Nice.
Right. So it's a medium relationship, right? So you have the density of the object and the density of the surrounding medium. And that will determine whether the thing goes up or goes down, right?
No, not this way. Actually,
isn't that what you just described?
No. Like in
you didn't
water.
just describe specific gravity, relative density.
I said that gravity is one thing, and like gravity is the reason why there is pressure in the first place, and density. Because why, like some of you said that if there is no gravity in the space or like vacuum, it will just spread out. It will not be like on Earth that closer to the ground there is more air particles per meter cube, so it's more dense.
The gas is produced where the surface is.
Yeah, I heard this too. From you, yeah, I remember.
I mean, we get the story, but the story can't be validated through scientific experiment, and the story violates laws of nature. I keep highlighting that because the laws of nature apply on the Earth. And you're saying that on the Earth, the laws of nature don't happen.
No, I'm discussing what's happening on Earth.
The gas expands into a vacuum. High pressure moves to low pressure. The mixing of ideal gases happens on the Earth.
Yeah.
So why? If the Earth was a thermodynamically open system, the physical matter, the gas that had energy given to it by temperature, is free to fill the available volume because the system is open.
Okay, don't shout. Why is it not?
Helping you understand.
Why is gas?
Gravity cools gas.
Why is gas not escaping the Earth then? So there is gravity.
Because the thermodynamic system is closed.
How is it closed?
So how is a volume contained by a container?
Okay, where are the walls of container that hold it?
I guess you could suggest that maybe you're standing on one of them. You could point in any other directions and say that if I'm within the contained system, then I must be surrounded by the container. Duh.
Where is the container?
I've just told you.
So you want to say that we all live in the box?
So I'll tell you what, I'll give you more directions. Point up. If pointing down at the floor was
in 12, and then in 8 miles, the air will almost like end. Why is it not going further up and spreading out there?
Sorry, what?
Like, you're saying that we're in the closed system in the box and that stuff. Why is gas not going further up than 8 miles?
Because of where the gas is produced, the restriction of volume, and the energy within the thermodynamic system. The system is in equilibrium and non-equilibrium at the same time. It's stable, but constantly in flux. The energy from the sun, for example, moves across the surface of the Earth, heating the surface, and the heat radiates from the surface. Obviously, when the heat source is gone, at night time, there's less temperature held within the gas, so there's less pressure at night.
That's right.
I mean, how far do you want me to explain these things to you? It's going to have to be a closed system.
So you think
it's open,
it's not because of gravity?
So gravity's a vector downwards.
Oh, that's what I was saying. So we had basically the same point.
Like that.
Is Earth an open? I want to know if you know what's Earth. Is Earth an open or closed system?
Earth is not closed system. I mean, we have lots of effects from the sun.
You can still have radiation, like heat, travel from one system to another system if that system is closed. Do you know what thermodynamic systems are?
Not the ones you tell me.
Okay. So, give you a practical example, right? We're talking about how energy and matter exchanges from one situation to another, one area of volume to another area of volume. For example, a can of Coke, a can of Coca-Cola, that's got physical matter inside, the liquid and the carbohydrated gas that's dissolved within the liquid. Now, you know that if you take your can of Coke out of the fridge, the reason why it's cold is because of the temperature surrounding the closed system of the can. You understand why the Coke inside the can is cold? Because of the temperature outside. So, for example, when you take your Coke out of the fridge and leave it in the sunlight and come back a couple of hours later, you notice that your Coke that's now exposed to a warmer environmental area, the radiation can enter the closed system and your Coke isn't cold anymore. That's a closed system. An open system is when you open the can.
Energy can be transferred through the walls of the can.
Yes. So thermodynamic energy, like heat, can be transferred through the walls of the container. The matter inside, though, because the system is closed, can't escape until you open the system. Then, for example, if there's enough energy inside the Coke, you might get it frothing up. because the higher pressure wants to escape. So,
if you talk about closed system that doesn't exchange matter but only like transfers energy.
Bingo, correct. Open system, free energy transfer, no matter transfer. Open system, free energy and free matter transfer. You can only have gas pressure in a closed system. If you open the system and there's an available volume for the gas to fill, like a vacuum, the gas that has energy will expand into the volume. That's a law of nature that applies on the Earth.
The reason why gas is not escaping is because we are in container.
Yes, it's a closed thermodynamic system. The cause of gas pressure is the limitation of volume, the physical interactions with the walls of its container.
But what is that container even?
I don't know. I really don't know. I haven't gone up to the sky and touched it. Right.
I mean,
I don't know.
Like, I understand every single argument until this point.
Let me just say one thing, right? It's a claim that there's a vacuum up there that is a violation of the second law of thermodynamics. To have the system that we have, in that situation, there must be a physical barrier separating our pressure from that available volume, so entropy didn't increase. But my claim isn't that the sky is a vacuum. I don't know what the sky is.
I get every single point, like, but at some point when you do the logical chain, you have this dead end about not knowing what the container is, and when you look at the spherical Earth's logical chain, then you have it complete.
If gas pressure, then container. Gas pressure, therefore container.
It explains like more things like from that. Like,
but there's no logical chain. Right? If we're talking about a logical syllogism where you add truths together to reach a logical conclusion, then the ones that you've got, they haven't been proven to be true.
But like, okay, we know that Earth has gravity. We have like something like force.
No, we don't.
We have a vector direction down.
How do you know that? How do you know that?
You drop objects, it falls down.
I did. I dropped the helium balloon. Remember, it went up.
90 degrees. Okay, it's going either 90 degrees down or 90 degrees upwards. But it only goes upwards.
Gas expands in all directions. Gas doesn't go 90 degrees.
Yeah, listen.
It just goes in all directions.
Sorry. If you're dropping things down and you say 90 degrees, you're dropping things to a horizontal plane.
Uh-oh.
Luckily,
that works pretty good on a flat Earth, actually.
Yeah, it goes down.
Down is perpendicular to horizontal.
Yeah.
Yeah. All vertical lines are parallel.
I mean, if you're standing on the hill, it's going to be like a very bad angle of incidence.
I mean, you can talk about how it's going to be a bad angle, but that's still going to be in reference to a perfect angle of 90 degrees in reference to horizontal. You're only going to be able to talk about this with horizontal included.
Yeah, and that horizontal basically is the center of the Earth, or like center mass.
The horizontal bit is the bit that you're standing on.
There is, there are real lines of, and there are projectile, like there are
imaginary ones.
Imaginary ones. So like, I forgot how they called them.
It's the horizon imaginary line.
So we don't need a physical flat line to compare it to 90 degrees. We just have center mass, which is like under
sorry,
our feet.
you're not in the center of mass to say that things are coming in radially to your position. Every single example that you're going to give now about dropping things will be to a horizontal plane. You'll only beg the question that it's a sphere that this is happening on, but every single measurement, all of the data that you'll gather will be on a horizontal plane. For example, when you level the tool,
Yeah. I forgot. We were talking. I was saying about that logical chain of proofs, blah blah blah, about spherical. If the Earth is spherical, then it explains why gas is not escaping. Because
that'd be affirming the consequent.
Yeah. Wouldn't be a logical syllogism. You know what a logical syllogism is, right?
Not very sure about syllogism as a word.
I'll help you. All right, so it's like a logical framework or step, like you pointed out.
Yeah.
A logical syllogism contains two truths that when added together, you reach a conclusion. So if this and that, it's going to equal this. You understand, right? It's very simple.
Mm-hmm.
Cool. So could you give me two truths added together where you reach the conclusion that you want to get to, whether that's gravity or that the Earth is a sphere? Remember, the two premises that you use must be true or at least verifiable.
So the like factual stuff that can be like 100% proven. And
yeah. Give me two facts that, when added together, prove the thing that you're talking about.
I don't know. Let me think.
Gravity. All right.
I thought about gravity and a little bit about curvature, like proving why Earth is spherical. And then every time I get this, first point, then second point, okay, it seems logical, but then you can say that. So first point is that on the spherical object, when you go further away from like a tall object, the bottom of it will disappear first, if you know what I mean.
Yeah.
And then second point from that is that we can observe that.
Okay, so on a sphere, we're making observations of objects along that curved surface over a distance that object would go over the horizon and appear to be blocked by that horizon. It's your first premise, right?
Yeah.
Okay. I mean, I get it. I mean, you're not far wrong. I mean, you can demonstrate this on a curved surface, that physical obstruction causes physical obstruction. Okay. Second one was what we observe this.
Yeah.
Okay. So we observe the curvature of the Earth obstructing our view for an observer at height above that surface.
Yeah, and comparing to as if it was flat, then getting further away from it, it will
dude, you don't need to worry about if it was flat. We're only concentrating.
Okay, then second point is when you magnify on the flat surface, when the object is far away from you, you can still magnify it and see.
From bottom, because you didn't need to continue about on a flat Earth. We're trying to form a logical syllogism that reaches a conclusion that the Earth is spherical. We need to concentrate on that positive argument, right? So, first premise that things on curved surfaces appear to disappear from the bottom up. Second premise, we observe this, right? So, when we go to the beach and we're standing observing across the water and I'm 6 foot tall, if the Earth is a sphere with the radius that we're given, the horizon from my 6 foot vantage point will be 1.225 multiplied by the square root of my eye height in feet. That gives me a geometric horizon at 3 miles away.
Mm-hmm.
Okay, so when I go to make that observation, I notice that that's only the limitation of my eyes. When I choose a different optic, like a high-powered zoom telescope or camera, or even binoculars, I can see the horizon extend in distance. I can also measure an approximate distance to the horizon.
Can I ask? Isn't in your example, within this range of 3 miles, you can magnify, you can see from bottom to top of the boat or like whatever, but then after 3 miles, it's gonna, like, the bottom of the boat or like the bottom part will disappear first, and however you magnify it from the same level of height, you see the bottom part disappearing first, which wouldn't happen if it was completely curved, completely flat.
It would. So, because I let you go with your two premises, I'm kind of doing it backwards, so I do apologise. You can make things disappear from the bottom up on known flat surfaces. Right, I can just show you something on a flat surface disappearing from the bottom up when I put a camera close to the floor. I can show you that. So your first premise is a single cause fallacy. The other reason is when you're looking over vast distances, the boat is 5, 6, 7, 8 miles away. We have to take into effect the meteorological conditions. because the path of the light can change, for example. We can have miraging effects, for example, that show that there can be things like disappearance from the bottom up of an object just because of the deviation of the light path. So these things can be demonstrated. I appreciate the logical syllogism, though. It's a good effort.
In case of Mirage, I mean, of course, it does happen, it can happen, but the boat will disappear, like, overall, if you take the change of visibility of boat. It goes from bottom to top, like, with the distance it travels from you.
Okay. Now, if we're standing on a curved surface and we've given the radius, then the horizon should be 3 miles. But like I told you, when we change the optic, the distance to the horizon can change. In fact, the distance to the horizon can change depending on the weather. You can figure that out when you open your weather app and it tells you the visibility of the day, how far you can see. Now, when you say that
there are
things,
particles in the air.
it's because you're saying that things are disappearing over a physical curvature of Earth. Now, that physical location shouldn't really change. It shouldn't really change based upon the optic, that's for damn sure. We should be able to see it better. But ultimately, when we change the optic...
It doesn't change with the optic, the distance of the horizon. It changes with the height.
No, you can change the distance to the horizon with height, but you've obviously never looked at the camera before.
No, when you said about putting camera on the floor, if it was perfect floor, okay, like even if it's... Wait, someone tag me? Even if the camera is on the perfect ground that is flat, you can still see and get light from the bottom part of the whatever.
No, so I can find the picture for you. So a long corridor with a door at the end of the corridor, and in the room the light's on. So underneath the door, you expect to see a little bit of light underneath the gap between the door and the floor. Thing is, when you put the camera down at the far end of the corridor, because the angle is too small for the optic to resolve across that horizontal plane, you can't see the light underneath the door anymore. You can demonstrate an optical horizon on a flat surface.
Hold on, that's an interesting example you said about corridor. I just imagine it like putting camera on the like very, very opposite side of the corridor that points at the door with the light from the ground.
Yeah, you'll understand that when you put the camera really low to the floor and say the floor's got a checker pattern on it like a chessboard, with distance you can't really distinguish the lines and the squares and even the colours, right? In actual fact, if you put the optic or your eye really close to the floor, you can't resolve the entirety of that floor if that floor's long enough, because the angles are too small. Even though they're right in front of you, your eye can't resolve them. So this is eventually where you're going to end up with an optical horizon. That's going to be where the angle is going to be too small for you to see at 0.02 of an angle. You can't see any more of that, so that's the limitation of your ability to resolve across a surface.
No, I mean, but are you actually sure that if you have not like a camera but like a sensor, and then it's a straight line, it's horizontal?
Sensors are different. So we're talking about, one, how we see, and then another, how we're going to pass what ray of light from one thing to another.
I see you. Then it's just limitation of like a camera lens that is changing the direction of light. But then if you make a camera made of lots of sensors of light, you essentially get the same light. I mean, if it goes straight line on the floor, it is close to the floor, but you still can catch the light source.
Yeah, with tools.
But if
this corridor.
I can lay down on my floor right now, look horizontal. With distance, the floor that I'm looking across, the angles are too small. I can't resolve it anymore. We understand how optics work. Things like a tree with distance look small when they're far away.
But proportionally small. So you see like the bottom part of the tree and top part of the tree, and it all gets proportionally smaller.
That depends on your eye level relative to the tree. For example, if you're 6 foot and the tree's 12 foot, I give your eye levels like halfway up the tree. But if the tree's 200 foot and you're 6 foot, I guarantee you the bottom of the tree is going to disappear before the top. The top of the tree is anything that's above your eye line. The bottom of the tree is the angle that's below your eye line. The angle that's below your eye line is smaller than the one that's above your eye line. So guess which one's going to disappear first?
The formulation, I guess it was complicated for my sleepy mind right now. Sorry. I'm not ignoring what you said. It's just I don't know, too sleepy to keep track of those complex analogies.
What analogies?
All those analogies we discussed for the last 10 minutes. Corridors, cameras, eyeball.
Description.
Those aren't analogies. Yeah.
But actually, if you think about it, you have a tree, for example, and you stand close to it. I mean, not very close, not that it's beyond your head, so it's not above you. So let's say, I don't know, 100 meters. And it covers maybe 10 how it's called, degrees of your view side. Like if you kind of measure it 360 degrees, and then I don't know how you manage to do that, but let's say it covers 10 degrees, and then you go 1 kilometer, which is 10 times further away, and then I don't know, it takes 1 degrees, but then you can still see from bottom to top, no matter what. It's just getting smaller, but what we are observing, it's fading away from bottom to top.
Yeah, but at 1 kilometer, how much drop are you expecting to see from 1 kilometer?
No drop. It's just a logical point of observation that we can all agree on, that the distance is making the objects appear smaller, but it doesn't.
Right.
It doesn't make, I don't know, top of the object disappear for I don't know, whatever reason.
Right. For the same reason, like if you're standing outside your home and you try to look on your roof from 10 feet away, you can't really see that much of your roof, right?
It's the angle from where you can see it.
Right. But if you walk 1,000 feet away and look, and then turn back around and look at your house, you can see all of your roof, right? Right?
You cannot see from the top. You cannot see all of the roof. You need to.
You can't see from top down, but you can see all of your roof, right?
From where?
Did you get taller than your roof?
If you get taller than your roof, then maybe yeah.
But did you get taller than your roof? You can see everything on top of your house. Did you get taller than your roof?
Huh? Wait, what point are you trying to make? Sorry.
That things move down in your field of view not because of the curve of the Earth, but because of your field of vision, because of how perspective works.
Okay,
No matter how hard you try, no matter what you do in the world, you will never ever see an orthogonal point of view. You will never see anything in Euclidean view. Now, you may have Euclidean shapes when you look at them and they're small and they're close up, but you will never see in a Euclidean point of view. Do you understand that?
So you're not saying about like capabilities of eye and magnification, because you can use telescope, to look at horizon. You're
does
saying
a telescope see in perspective, or does a telescope see in Euclidean?
So I'm saying you are not saying about magnification and stuff, only perspective from how high, and so this effect is caused by perspective angle from where.
So, let me try a different attack on this. Okay.
Yeah.
Let's see if you've ever done this before. I did this when I was in like sixth grade when I was learning about algebra and basic geometry. So you take a thumbtack and a string and a pencil, right? Take a piece of paper, put your thumbtack in the string in the center of the piece of paper, tie the other end of the string around your pencil, okay? Now I want you to take that pencil from the thumbtack with the string attached, and I want you to stretch that string all the way out. You understand what I'm saying?
Yeah.
Okay. Now, what I want you to do is I want you to draw a straight line with the string all the way stretched out. What's going to happen?
I don't know. I've got to test this, but I don't have a string and a pencil. Okay, but I've got.
Okay. Well, I'll tell you what you're going to find. I want you to test it because I want you to see exactly how this works. This is how perspective works. You're not seeing straight lines in perspective. The only straight line that you have in perspective is your direct line of sight, what's directly in front of your line of sight. That's the very limit of your straight line. As you look around you, you then create a circle all the way around you. Same thing with the pencil and the thumbtack and the string. You stretch that string out, that's your direct line of sight. Now, if you try to draw a straight line with the attack, you still there?
Yeah. You just lagged for 2 seconds, but
no, I got a phone call. Don't worry about it. So what happens is if you try to draw a straight line, you can't. You end up drawing a circle all the way around the thumbtack. So that's how you see your vision around you. You see in a circle all the way around you, and because you can look up in the sky, you now see in a dome all the way around you. You would see in a sphere all the way around you, but you have the Earth underneath you. Okay?
It's not necessarily dome. Why are you thinking that it's a half sphere? Dome is basically.
Did you hear what I said?
Yeah. I heard, but yeah.
So that's how perspective works. You're looking when you look out, you're seeing I can't say an infinite amount of cones, but you're looking at a cone everywhere that you look. It's like an overlay of several cones. That's just how perspective works. That's why when people draw in perspective, they draw those converging lines that come together. Well, when you draw converging lines come together, you're using straight lines, but you don't see straight lines when you look out in nature. Your entire field of vision is curved. The only straight line you have is a direct line of sight in front of you. That's how perspective works.
Yeah. I'm actually not very like a specialist to know about
right. I understand that, but that's why there's limitations to your vision and how your vision works. You say, why does the sky appear the way that it does? That's because of your perspective. Everything looks like you're in a dome. because that's what perspective is. So it's not the Earth that's curved, it's your vision that's curved.
I mean, I cannot say it is not curved, our vision.
No, I'm not saying it's not. It is curved. And that's the illusion of it, right? All you have to do if you want to know if the Earth is curving or not is go out and measure the surface of the Earth. You don't have to trust your vision.
Surface,
you can just go check it for yourself.
Surface, you mean you want like a line or like area?
Well, like an area. You're going to have to choose a large area because the Earth is large, right? They tell you that it's 40,050 kilometers in circumference, right?
Yeah, at the equator.
Right. So, and then you have an average radius of 6,371 kilometers average.
Yeah.
So, you know, that, like, if you take that radius, that's like your line of sight. That's that string I was telling you about. And then, so if that string is 6,371 kilometers, the pencil reaches the surface edge of the Earth, and you take that pencil and you keep that string extended and you draw all the way around, that creates a circumference. And then if you want to
wait, I thought you were saying that Earth is spherical. I thought you were trying to conclude that it is spherical.
Well, if it is spherical, you can test that curvature, right?
Yeah, and you saying that it is not
lasers shoot pretty far.
Just because you can't. So just because you can't prove something, it proves otherwise. Like, is it how it works?
Well, if you can't measure any curvature, what does that mean?
It just means that you cannot measure any curvature.
Okay, what's another word for lack of curvature?
If you want to prove like that something is flat,
if I draw two lines and one line is curved and the other one isn't, what's the other one?
You cannot. Yeah, I get what you mean. Yeah, but you cannot prove that something is something just because it is not something else. Like,
if you have two straight lines that don't intersect, what does that mean?
With measurements, you do. Like, it's different if you say, well, I can't go out and measure it, so I can't measure curvature.
Yeah, I get it. Maybe just
but if you go and measure it, right, if you measure it and you don't get a result of curvature,
try again.
This is where sheepdog's going.
Try again, try different method, because if you only tried once,
try different method.
No, bro.
If you have two straight lines that don't intersect, what does that mean?
Parallel.
Right. And in order to have two parallel lines, both lines must be
what?
Straight, flat.
Yeah.
So if you have no deviation from, if you have two lines next to each other and you're measuring the deviation from one line to another, you're either going to have two straight lines that create an angle, right? Because they come together and create a vertex. Or you're going to have one curved line and one straight line. In either sense, you're going to measure a deviation from one of the straight lines. Right?
So what happens with the physical experiments with the curved Earth?
Right. So if I shoot a laser over the surface of water, right, the laser is shooting in a straight line. I've determined that. I've observed that. I've gone along the line of the laser, and I noticed that there's no deflection upward or downward. I know that laser is shooting in a straight line. So if that laser is shooting in a straight line, and then I hit my target at the end of that straight line, assuming, a flat surface or curved surface, I hit my target at a distance, and there's no deviation from where the laser began, it's still at the same height, then it's reasonable to conclude that over that distance, there is no measurable curvature because the baseline under my laser, hold on, the baseline under my laser is parallel with the laser.
Yeah, look, wait, can I ask you something? Would it change your mind if you actually tested it yourself? Like if you set up a laser which is parallel with the level of water and you follow it, you go those 3 miles to the horizon, and then you start seeing, for example, you start seeing that the laser is going more and more up from the water level.
Sure.
Like, would you like finally, like not finally? I'm not trying to be rude, but would you conclude that
hypothetically, if somebody went out and did that and consistently showed that at a certain height where the laser starts, like if we made the laser height 6,
engine, yeah,
and then the distance to the horizon is 3 miles, and then after 3 miles, I noticed that for each mile it was exponentially getting higher and higher and higher for the laser hitting the target exponentially was higher and higher. Yeah, that would prove the curve of the Earth.
Yeah, because laser is straight. I mean, it doesn't go
right. Now lasers can be refracted under conditions, but that's why we do several tests in order to make sure that the conditions are met for the observation.
Yeah.
Right. So if the laser height was increasing exponentially past the horizon, then yes, I would say yes, that's consistent with the curve of the Earth.
We should go test it.
Oh, it's already been tested.
Where
but you can go test it again yourself too.
Yeah, but we can do it ourselves to prove to ourselves. Yeah.
Absolutely. Would you like to see some of the tests that have been done?
Where do you guys want to meet?
I mean, are you in America?
Are you?
Yeah.
Oh, Jedi, you're back. You're back. While you left us. I came up with another. How is it called? Logical syllogism.
Yeah.
Syllogism.
Syllogism. Yeah. So, we were talking about lasers and about if it's straight and you align it with parallel to water, blah blah blah. That's irrelevant now because I came up with something different. So 2 points. First point. So in a self-gravitating fluid, like deformable solid, the internal stresses flow will minimize potential energy, so it will like spread out to minimize the, like, how to explain. It has to be like, this point has to be straightforward, but what we observe, or like what happens when you like put fluid on the table, it will spread out to the least resistance path. Same with the lightning on the sky.
Okay, and with the water, so water seeks the path of less resistance downwards, and then when it reaches a level, it will level itself within that container, like a puddle, for example, right?
Like it will level to minimize the potential energy. It will not try to act weird and gain energy from somewhere. If it's stable, it will stay stable.
Yeah.
So, okay, and second point, then if we, I don't know, wait, can it be a point that the minimum energy configuration under self-gravity, it would be, like, if it has gravity and...
Sorry, you can't use if statements when you're making a logical syllogism.
Okay, wait. It has gravity at the point.
Okay, so when we're making premises, those premises must be proven to be true.
we have center mass?
I really want to help you, but we're already into territory that we're not going to be forming a logical syllogism out of this. If statements and right, at the center of gravity, okay, let's have the center of gravity. The center of mass.
Okay, we have center of mass.
Okay.
We have minimizing potential energy way of acting, like how
modus ponens.
How the matter acts to minimize energy efforts to fill the matter. And if we have central center mass, then the minimum energy configuration for that system would be a sphere.
Oh, hold on. I was with you with the center of mass, but now you're giving mass the power. It's got energy to do shit.
What do you
mean? Mass attracting mass.
Yeah.
You're giving mass, and I was with you when we talk about the center of mass. If we're talking about like a ship that requires to know its center of mass when it needs to be buoyant and all of this type of stuff. Right, the center point of where all of its, let's say, energy is distributed. But you're now saying that this mass has got some kind of magical power. It acts. It does something.
Just a way of distribution of matter that is pulled together by gravity, by central mass.
Hold on, what state of matter are you talking about? Because most states of matter, depending on what they are, will only
I mean, if you think about it, two planets, if they collide...
Planets? No, we're not going to be talking about planets. That's the conclusion you need to reach. Otherwise, we're going to have to prove planets.
Okay. Solids can deform by high...
Okay. Solids can deform.
Especially if they're hot.
I guarantee when you start, if you're trying with this, when you're making your syllogism, like I said, there's at least two premises that must be true. And when you add these true premises together, you reach a logical conclusion based on two obvious truths. When you're starting to do this, I'm going to have serious questions about your premises.
Okay, I'm still learning to do those.
It's fine, buddy. That's why I'm taking the time to help you along. You're obviously in good faith, so I'll take the time to explain to you. I've got no problem with that at all.
Thank you. So maybe what I'm trying to say, without that logical chain syllogism, I guess the sphere with the central mass is just the minimum energy state for matter to group in the vacuum. I mean, if it was a coin, then at different points it will have.
Hold on. What state of matter are you talking about in a vacuum?
Does it really matter? I mean,
yes. So, like a solid object like iron in a vacuum, not much is really going to happen, mate. You put liquid in the vacuum, it's going to immediately start to bubble.
Yeah, but what if you have a lot of iron in the center core of the Earth at temperature of 6,000 degrees and it's melt?
Why don't we start from the beginning? We'll just start with the vacuum first, and then we'll introduce some kind of explosion that puts all of the mass in the universe and separated wherever it's at. Like, if you're going to go down this rabbit hole, bro, you're going to have to start from the very beginning, and you're going to have to place all of these things into their locations in order to prove that this is exactly what's going on.
Yeah, I get it, but yeah. I'm trying not to say if, because apparently you don't like when I say if the Earth is flat, or like if it's coin-like. So
if the Earth is flat, how is it supposed to work?
Because at different distances, gravitational pull is different. So
it only works on a flat Earth.
What?
So if we have center mass,
it doesn't work. It's unemployed.
Look, center mass is a point, and if you even
center mass is a point, but that's not where gravity is.
Yeah, I know. But if you have, but that's where it goes to 90 degrees to the center mass.
No, it doesn't.
Now it's traveling. Now it's doing work. I'm with you if you say that mass, loosely defined, is the amount of substance in a space, or that it's got a resistance to inertia. These are just concepts, dude. But you're giving this mass some kind of power, some kind of energy that does something. Now that's outside the scope of this stuff that just exists, and here's the middle of it.
Yeah, but that's what we observe in our universe. Two objects.
No, it's not.
Attract each other.
No, it's not.
What do you mean it's not? I have in my school, like, look, in my school they had this setup. It was cheap.
If mass attracts mass, then why doesn't the moon fall on Earth?
Because it moves fast enough to bend over the.
Okay, demonstrate that in a scientific experiment.
Okay. You have a cannon, yeah? You shoot a ball, and then...
My cannon is the surface of the Earth is not curving. Therefore, the surface of the Earth can only...
The further you... the more powerful cannon is, the more further it will go, and it will curve more further away. So if you make the cannon powerful enough, or like it moves fast enough to curve.
Do this in a science experiment. Demonstrate it for me.
He shooting himself in the back.
Look, the satellites is the scientific experiment of.
Dude. All right. You have to understand your own actions at this point, right? You're now talking about satellites. You've changed subject, dude. Like, how can we get to a logical conclusion? Like, well, we're just going to throw spanners into the works?
No, he just asked about how can I scientifically prove that two objects can move around each other.
Dude, you're not going to be doing that with a hypothetical where eventually you're going to shoot yourself in the back of the head with a cannon. If you shoot it hard enough, it will curve around the surface of the Earth and hit you in the back of the head. You're not going to prove it with satellites either. These are like hypothetical conceptions at the moment.
No,
you're not.
But cannons, they have air resistance. They will fall eventually.
They will fall eventually. Yeah, on a horizontal plane. The mass that will be associated with it will be on a horizontal plane, and it's curved across it, depending on power.
But at the height where satellites fly, above 100 kilometers.
That's a claim.
Hey, Jedi didn't make it. He didn't make it, Jedi.
Yeah.
Also, you said about why don't we feel acceleration when we rotate around the sun? Because look, one rotation takes 365 days. Okay, it's not about days.
We don't rotate around.
Yeah, but if you calculate the same way you calculate the let's make it relative. A force that we have to the ground, the gravitational acceleration, and the acceleration towards the sun, they're very different. I think to the sun, we do have acceleration. It's 0.006 meters per second squared. Meanwhile, the gravitational acceleration towards the Earth, 90 degrees towards center mass, is 9.81. So it's
who measured the 0.006 meters per second squared?
You measured from that from the so what if you know the distance toward the sun, if you know how long it
Okay, who measured the distance to the sun?
I don't know, dudes.
This is what you're defending, man.
No, look, but we know the gravitational pull and acceleration towards the sun.
Who measured those?
So, what's this got to do with what anything?
No, that's to do with all stuff you previously said about why don't we feel the pull from the sun.
No, not why don't we feel the pull from the sun?
What do you mean? What did you say?
I didn't say we don't feel the pull from the sun.
I mean, when you accelerate.
The motion of the Earth, man. That's all we're talking about.
Yeah, and if an object moves in an orbit,
detected it? Who detected it? Who measured it?
Galileo Galilei.
How did he detect it?
I'm just kidding. I'm just having a huge fly or like a bug trying to get inside.
We were all there at one point until we went out and looked for it. And we found out that there was never any evidence to begin with. It was always some scientist somewhere magically agreed with all the other scientists, and that's how we know science. But that's not how science works. Science is testable and repeatable.
Yeah, it is repeatable.
Yeah.
So why don't you go and repeat their experiments?
Because we don't know what their experiments are.
Because there's no scientific experiment that deals with shapes. Science doesn't figure out geometry. Science figure out the shape of an object you observe and you measure it. Observing and measuring isn't the scientific method.
Back in the times, like old times, they already knew that planet was spherical just by putting two columns. I think that they did this experiment in two cities 150 kilometers away from each other, and they knew almost exactly the distance. And
403 miles, the distance between Syene and Alexandria, where they put sticks in the floor, one underneath the sun, one 483 miles away, where the stick that wasn't underneath the light cast a shadow because of its angle to the light. I can do the same thing in my living room. I can stand underneath the light and I won't cast a shadow until I start walking away from underneath.
Wait, do you mind, guys? 30 seconds. I need to use the bathroom.
I bet you do. No worries.
Dang Jedi.
What, man?
How many times have we gone through circular reasoning on this?
I mean, it's constant and it's circular, so all the time.
There's got to be a golden ratio in there somewhere, dude.
Mate, some Fibonacci sequence to all of that. Just keep fucking repeating. Did I hear Matrix in the background? What's up, man? How you doing?
Just pop in for a listen, man, before work.
Good morning,
How'd
dude.
you go with that? How'd you go with that chap last night? Oh, reset button. He's all yours, Goodway.
Did you say Jap?
I'm back, chat.
That's good. Well done. So, look, dude, where do you want to continue from or start afresh from? Been having lots of these conversations. What are you left with at the moment? Do you want to ask us how we know the Earth's flat? What questions have you got? What answers do you need?
No, actually, I think at this point, I just get that you have a similar logical chain that is explainable, but then you have dead ends, which you have.
We don't have dead ends. We have unknowns.
Unknown. Same as a spherical thing. I mean, it has maybe more evidences, I guess, if you can call it.
It has a story.
It has a story, right?
Because astrophysics, all that is it's there are people who have a profession of looking at the sky. They've never been to any of those locations. They just look at the sky and then they create stories to go along with what they see.
Yeah, and I guess the fact that
you want me to tell you a story about the sky?
No, look, we came to the conclusion as a humanity that it is spherical. Not just like one person decided it to be, and then others just followed the story. I mean,
but they did. That's exactly how it was.
No, there's been a lot of people in the history, and you cannot prove everything, and you cannot do everything to everyone.
You know where the idea of a spherical Earth came from? People believed in a perfect creator, and they thought that perfect creator would create the perfect shape, and that perfect shape is a sphere.
But no, there is no perfect creator.
According to the Greeks, there was. So this is where this idealized form comes from, a sphere. We're surrounded by spheres. It's an idealized form.
But if you talk about ancient times, they had those theories about flat Earth standing on, I don't know, 3 elephants and turtle.
Yes.
The ancient times, they thought that the Earth was a sphere. You're talking about a 2,000-year-old ancient archaic concept.
The crux of this issue is, lots of people long ago said lots of fucking crazy shit, but the idea that the Earth was a sphere, it's a religious idea. If we look even into what are not so distant past, like 500 years ago, this flew out of the Catholic Church. Catholic Church funded this, even though they said they were against it. The poor dude Copernicus under what? House arrest?
But wasn't the actual revelation?
Galileo went to house arrest.
In 15th century. Oh, wait. Yeah. No. Oh, yeah. 15th century. When in 1492, Columbus, he. Wasn't he who tried to. He tried to go to India, but then he went the wrong way and then traveled around the globe.
Went in a circle.
That's because he was using a globe. He was using a globe for his navigation. That's why he got lost.
He got lost, dang. Oh.
Yes. They had globes back then. Matter of fact, the first globe was supposedly invented in 1492.
What about there's also, look, astronomers.
You're not going to acknowledge that?
I can acknowledge that, but cannot reach a logical conclusion from that, if you know what I mean.
Look, if the globe was invented in 1492 and Columbus sailed the ocean blue in 1492, then he probably got lost because he thought the Earth was a globe.
Because before that, we couldn't possibly hold that knowledge, prove something more. We couldn't even reach, I don't know, South America or North America. We couldn't reach those lands. And we didn't know it was something.
Why not? It's all you have to do is travel down the coastline on water.
In many cultures,
Vikings did. Vikings had no problem.
There was a believing that
Vikings did that in 1000 AD. Did you know that?
There's a
the Vikings founded America in 1000 AD. Did you know the Greeks were actually writing about America in 69 AD?
I'm prepared. How is traveling around a bit proving anything at the moment? So we travel around. We got Columbus, and you can point to other famous people from history who sailed around a bit, and what they came back again, and that's supposed to prove what, other than they went in a circle.
But there were experiences a long time before that and a lot after that. And,
okay, like what?
Look. The only thing that changed is that we became like globalized. We could exchange information. We could store information. So all the experiment data and knowledge that humanity gained, I mean, different perspectives on knowledge. It's not like there is one factual thing about everything. There were like different perspectives on everything. Even theory of evolution, on religions, everything is like different perspective.
That's awesome. But this isn't a subjective issue, though. You brought religion in.
What I'm trying to say, it's more about like collective knowledge gathered over centuries, thousands of years. It's not about beliefs or like I don't know, propaganda or someone trying to benefit from it. I guess those scientists just moved on.
That's irrelevant.
Like, what's the point trying to prove?
Like, if you picked up a book that somebody else wrote and then you tried to expand on that book, that's fine. But the fact of the matter remains, you still have to have measurable curvature in order to prove that book was even right.
Okay, you can go and do a couple of like experiments, repeat them for yourself, and prove it.
How are we going to go measure for curvature? We talked about that earlier. How are we going to measure for curvature?
With a laser.
Oh yeah, did you hear about this, Jedi?
Yeah, I mean, I've heard about lasers. That's how we survey the world.
Oh, did you hear what we were saying earlier? He asked me. He said, if we set a laser up at 6 foot height and we shot it out, we leveled the laser, shot it out over distance, and then after 3 miles, we noticed that the laser was exponentially getting higher. Would that prove the curve of the Earth? And I said, well, if we do that several times to make sure the conditions are matching, and then we take an average of what's going on, put that on a statistic bell curve and see what's going on, find out if it has a standard deviation, all those things. We have to do thousands of observations, but if we do that, and we notice that statistically it's exponentially getting higher above our head, would that prove the curve of the Earth? And I said, yeah, that would prove the curve of the Earth. That would be a good way of doing that. And I then proceeded to tell him that we have many laser observations that we can look at. And I don't know, do you want to go over that?
I mean, yeah, if he understands the premise, then this is how we survey the land. We send signals from a laser to a receiver, usually a mirror that works on the law of reflection, so we can figure out.
Or, guys, I have another method without lasers, radios, like very old-fashioned method. So you get a string, very long one, maybe 10 miles. I don't know if this one exists, but and you keep it tight, not to break it. You keep it tight, and you go like behind.
Straight and tight over 100 feet.
You go behind horizon, and you keep a couple of boats near the every.
Marion, have you ever tied a string around a pole and then stretched the string out over 100 feet to another pole?
If it's tight enough, it's gonna be straight. No.
No, it's not.
Just make it tight. Just make it.
You'll never hold the string tight enough.
Little bow in the middle. It'll always sag down because of the weight of the string over the.
So if the Earth is curved, yeah, and you have I don't know if it's from the.
How about not if the Earth is curved or if the Earth is flat? Let's just straight line over the surface of the Earth and look for any deviation from the straight line. How about that?
Yeah.
So what would you like to look at? Would you like to look at long distance observations? Would you like to look at laser tests? Or would you like to look at radio wave propagation?
I'm gathering money to build a rocket and fly around Earth.
I think this conversation.
Oh, we need to build a rocket.
Can you send me $5 each, and I'll build a rocket and fly around the Earth?
This is the moment when my mood changes. All right. Now you've listened to both of us take our time and our patience to help you understand things. Now you're raising money to build fucking rockets. We should probably stop the conversation because you're not here in good faith. It's unfortunate.
I'm just going to step in between Jedi. Just to save us some grace on this, Marion. I think you need to mute your own microphone and go do some more research, and then come back and talk to us when you're not so worn out from the conversation. I think it's pretty much over. I think we need to move on and talk to somebody else.
Okay, I'm very grateful.
Everything that we talked about.
I thought we already settled a lot of things down and discussed many topics. So
I thought we did too, but you just completely just.
No, I thought it was.
We all need to send you $5 so you can build a rocket.
No, I thought it was the right time for humor.
I did. If it was a joke,
I don't think it was, man. Like we spent how long, Jedi? Probably at least 4 hours with you.
Yeah, I mean it's fine.
That's a long time.
Yeah, it's fine. If it was just a joke at the end of the day, man, then sorry, we didn't necessarily take it as a. That's the way that you intended it. It's been a good conversation up until now, man. I wouldn't want it spoiled, so I'll give you that benefit of doubt.
Yeah. Thank you. You too. Specifically, I mean, you talked the most. I think not. Oh, Sasha always joined us in conversation, and someone else. Thank you to you all.
Yeah, no worries, man.
That's what we're here. We're trying to be helpful. We give people a chance to practice their English while also discussing a very interesting topic that has a lot of specific details that need to be discussed in order to have a conversation. So there's plenty of English to be practiced in this conversation.
Yeah, to be fair. And this vocabulary is very niche. I mean, debating vocabulary, but also curvature, elevation, those type of words.
Yeah, you are correct. And
not really a debate.
Yeah, we must remember that being as English isn't most people's first language in the server, then some of the terms that we use, you are correct, are niche itself being a niche term. I'm glad you understand that word. But yeah, you are correct. It's hard to follow along all the time.
Are you guys native speakers? Because you sound like.
I'm American and Jedi is British. Can I say British Jedi? That's over-encompassing.
I love his English accent.
I'm British too. You can tell by my accent.
You sound like
the owners of the language are told that they have an accent. That's the funniest thing. I always say that to people who are from the British area. I'm like, oh, I love your accent, and it's like, bro, I own the language. You're borrowing it from me.
The only person that never really had an accent was Stephen Hawking.
Yeah, that's true.
How do you do that voice in an American accent?
I don't know, buddy. You just do it.
That's a good try.
But if there's anything to take away, Marion, I just want you to think about geometry. If there's anything to take away from this, I want you to think about geometry. There's a reason why they separated your math class from your science class when you were in school, because they're two different things.
Sure thing. That was bloody interesting. What?
Why do you always sound like you've just fallen out of a child's dick and you tried to do an English accent? Like, we've moved on since the 80s.
No, I'm just practicing.
I know. I'm joking, dude. I'm fine. It's a bottle of water. There is a tea in it.
There is a tea in it.
Quite a lot of ingredients are quite
Water.
Yeah, that's it. The Aussie version. Water.
Not that Aussies get to see much of it.
Oh, that was a Scottish accent? Or...
There will be some.
Yeah, he's an upside down Scot.
Cycling company, but he's refined.
Can understand.
Doesn't have that typical, he doesn't have that rustic Scottish accent, does he?
No, he doesn't sound angry all the time. Yeah.
Wait, isn't a Scottish accent just... It sometimes goes with different letters. So when you usually say A, like A, they say O. I don't really remember examples, but...
Maybe. They're funny, the Scottish. Who knows what they bloody say half the time?
It's funny how you have different accents within, like, your little country.
Yeah. Lots of multicultural influences. They say some of our accents are even developed to be food or the industry that a particular area. So some accents are more nasally than other accents because of certain environmental factors.
But your accent, it's posh.
That's fucking not. Oh, sorry. I do apologise for swearing. No, it's not. My accent.
No, just from the way you speak, you speak money.
Middle class.
upper middle class.
Yeah, definitely not. Definitely.
Doesn't sound like this, old chap. What do you mean?
Is it London accent or like somewhere?
So it's around London. My accent south-ish.
The rain in Spain falls mainly on the plain.
Let me guess. T-Dub, you are from... Okay, not Scotland.
Have a guess, mate. Where do you think I'm from?
Not Southwest. Not Wales. Not East London.
You'll get it eventually. Just have a listen. Have a listen to the way I talk.
Is it your real accent?
G'day, mate. How's it going? I've seen you for years.
What do you mean, is it his real accent? What, you think he does that for practice?
You sound so German. Even though I know it's...
No.
Wait, what?
Das ist gut, yeah?
Why do Scottish people sound so German?
After all this time, I didn't know that you guys were actually German. Amazing.
Was ist das?
Wow. Is there a large Nazi population around Australia? I forget.
So much so that the Prime Minister stopped us doing the salute.
They're nothing but criminals out there. Australia is where like all the Brits sent their criminals.
Yeah. Great Britain's like a prison island at the moment. But anyway, I digress.
I actually love Britain. Whether it's great or little great.
It was pouring down with rain not 20 minutes ago, and it stopped, and now the sky is completely clear. The weather changes really quickly in this country. It's funny.
What's the matter? There is no problem with that, I guess. You can get used to it.
Yeah, it's fine. Right. Does anybody else or yourself in question to the subject matter of this lovely, the shape of the Earth? Is the Earth, like we've been told, a sphere in motion around a star in the sky? Or is it how we observe and as we experience? Is it a flat, horizontal, stationary plane where the sun, moon, and stars move above us, not around us?
Actually, Jedi, if I get to research a little bit for like maybe potential next time discussing or debating on this topic, should I do the research based on counter what's the word I'm looking for, counter argument?
Straightening out.
According to the sound effects that are going on and everything like that, he creates this this visual acting piece. He did a pretty good job. Not too bad for a kiddo. If y'all ever come across it, you'll laugh. What's up, Tia? You back?
Come on. I know you're out there. I challenge you to find the curvature that's claimed to exist in the form of 8 inches per mile squared, or a geometric horizon 1.225 miles times the square root of the observer's height in feet. Yeah, go ahead and clip that and say that I'm just parroting.
Test your might.
Sorry, what?
I said test your might.
Yes, test your might and your mic. Yeah, test your mic.
Test your might.
Horizontality. If your ionosphere with a radius value of 3,959 miles, your line of sight will be a tangent line to a point on that sphere. We used to get told that's the horizon. And anything that goes beyond that is going to get blocked from view. And that's why you can't see any more of the surface at that distance too. Because that line, that has a distance. And the amount of surface between your line of sight, well, your eyes, and the horizon has a distance. That's what we used to get told.
Oh my God, Tito.
But nobody's... Yeah. Sorry.
No, you just, like, spawned a thought into my mind. But go ahead and finish what you're going to say, because I don't want to ruin it.
No, that's about it, really. Like, that's what we were told. Nobody's been able to present that to us, you know.
So, you're going to laugh. I wish Jedi was here. Is Jedi here? Did he pop in just yet? Okay, and we got John S. here. But just real quick, I want to say this because you're going to laugh so hard. So, when you're making a celestial observation, you're drawing on a globe, right? You're supposed to be drawing a tangent line to your horizon and extending it beyond the horizon. That's what they say, right? Right, T-Dub?
Yeah, continue. Yeah.
So if that's the case, and when you look at the horizon is being refracted. So really you're looking around the curve. So even your tangent line is curved.
That's correct. They do say that, that for that to occur, your line of sight must be curved. Exactly.
Oh man, I can't wait to throw that into an argument now. That's gonna be my new argument. Oh, you're drawing a tangent line. You mean the thing that's curving around the curve? What's up, John S?
I hope you have peace of mind in your lifetime.
What was that?
I don't know, but I don't know why people have to use deception like that. Okay. The art of war is deception, right? So if you're trying to deceive people, you're essentially declaring war. Super weird. Anyway. So yeah, man. So when they invoke a tangent line over a curved surface, you say, is that tangent line to the horizon? Yes. And the horizon is much further because of refraction. Yes. So now you're saying your tangent line is curved because your tangent line's to the horizon. What do you think the response will be?
I'm not sure about that.
That's kind of funny,
it's
right?
come up before. I think it has come up before, and I can't remember the response.
Has it really? I bet it was a Nathan Oakley argument. I've never heard of it before. This was new. Like, you tell me about a tangent line. Is there a tangent line in mind?
Well, I guess you just straighten it mathematically, right?
Your eyes. What's the equation for that?
I'm not sure. I don't know.
Oh my goodness.
Does it really matter what the equation is? The answer is no. Why? But it doesn't matter what the equation is because if if it doesn't fit the equation, they'll just say, "Oh, it must be an extreme example." Right?
Yeah,
that's their
pretty
excuse
much.
every time.
Did you hear my following of the logic on that AI, the whole thing? So Glovers, when they say celestial navigation is based on a tangent line to the horizon, and then you draw your triangle that way, right? They're not necessarily worried about the GP, but they always make the argument that your eyes draw a tangent line to the horizon. That's your baseline. Then you make your elevation angle based off of that tangent at the horizon. So if you're looking at the horizon and the horizon's 10 miles away instead of 1 mile away, you're back to having a curved tangent.
No, it doesn't matter. The distance to the horizon is irrelevant. The only thing that matters is the drop angle to the horizon. The horizon is essentially a quaternion line in infinite free space in your visual space. Like, you have no way of knowing how far away the horizon. The only thing that you can determine is if there's demarcations between you and the horizon. But the horizon drop angle is what's important. The distance to it's irrelevant.
Right, and with celestial navigation, the refraction issue is with the displacement, the apparent location of the object in the vertical, not the displacement of the horizon.
Right.
But wouldn't the drop, like, so? But the drop that would alter, wouldn't it? If they didn't have a specific distance to the horizon, wouldn't it? Because if it was closer, it'd be a different angle.
Not necessarily. It's occupying a region of space that is so compressed in the amount of available angles that it's functionally like 1 mile versus 10 miles. It's going to be functionally the same angle, plus or minus any error bars. Yeah. I mean, think about it. When you look out at the horizon, is one day it's like 75% of your view, and the next day it's like 30% of your view? No, it's like almost always approximately 50% of your view, right?
Right. Okay. Yeah.
Unless you gain dramatic amounts of altitude, only then is it going to have any significant drop angle. Now that right there, by the way, is actually a boon on the flat Earth side, because if the horizon gets further and further and further away, yet it doesn't have any change in drop angle, that's telling you that it's not curving down and away from you. Right? Right?
Good point.
And that is where they have to then claim that their horizon is being uncurved. It's straightening out. Like, and I don't mean the horizon itself, but like the distance from you to the horizon. That z-axis curve going away from you, that curve is straightening out.
Yeah, I've always said that, like, on high altitude observations, even the z-axis looks straight. There's no deformity. As like, even if the lens is curving the horizon,
it looks like you're seeing more of a flat distance too.
Yeah, that's all.
You guys remember?
Silly, because, like, go ahead.
You guys remember Mr. Sensible and his high altitude balloon, where he claimed that the lens doesn't have any distortion? Remember that?
I do.
Anyone? All right. So, first off, his lens would have some distortive effects because the compression of the ambient air within the lens is going to be different than external. Like high altitude footage has to be done with pressure controlled lenses. Like the lens and the photos, like where the photo is being taken, those two areas have to be pressure differentiated. Otherwise, you don't get the same like optical trueness or whatever you want to call it. However, the lens he claimed had no distortion because it was rectilinear, so he says. Now, if you just do a stupid AI search or a stupid baseline Google search, they'll tell you that, oh, rectilinear lenses don't have distortion, but that's not true. You go to actual real photograph sites or real photograph literature, and you'll find that rectilinear lenses do have distortion. In fact, the type of distortion that they have is that on the horizontal axis, which is the x-axis, let's call it, as you get away from the center, the y-axis values increase in being stretched across the horizontal plane. So in other words, if you had two colors, right? Let's just say the top, the bottom, well, the top, let's say the top is black and the bottom is blue. Just imagine an image where it's just two colors, top black, top black, bottom blue. So as you get away from the center, values increase. So that means that the blue would be stretched and the black would be stretched. So you'd have, 1 pixel, 2 pixel, 3 pixel, 4 pixel. Now, if you're imagining that going towards the edges, at the very edge of the image, the blue would look like it's descended and the black would look like it's, you could tell, the black would look like it's ascended. And that would look like a curve to you, wouldn't it? Hopefully you followed that.
Maybe the last part again, you kind of cut out.
I'm just saying that if that was the case, then the edges would look like they were curving down, wouldn't they? Because of the nature of the color fields and the way that the lens distorts, it would make it look like the edges are curved down. So in other words, the very lens that he used has a particular type of distortion that when it has two parallel color fields, as they go further away from the center, they're going to get further away from each other and essentially look like a curve. So that type of lens can't be trusted to just be like, oh, I see the edges of the image curving down, therefore I'm looking at a physical curve, which is not necessarily true. And then they say, oh, we're high up now. Now the horizon has more of a drop angle than it did when I was on the ground, which is basically arguing the ground below me is below me. And it's like, no, duh, of course the ground is below you. Of course you're going to be looking down at the ground. It's below you. Duh. Go ahead.
Yeah, just everything I've ever seen with rectilinear lens images or pictures, whatever you want to call them. Like from low altitude, you don't really notice a difference just because it's like it's so minuscule. It's like you'd have to count pixels, and there would probably be a difference just in counting pixels if you did. But at like higher altitudes, it's straight all the way across, except at the very, very edge. There's like a slight tick, and it'll go down or up depending on which.
Yes, that's a very distortion that they have, the exact type of distortion that those lenses have, and it's pronounced when you have two parallel color fields, right?
Parallel vertically or horizontally?
Doesn't matter.
Okay.
They could be diagonal. Now the point is that if you're looking at if you're looking at
what you're talking about.
Yeah, if you're looking at a horizontal, it's exactly what you just said, dude. Like what you just said.
Okay.
If you take what you just said, turn it vertically, same thing. Turn it diagonal, same thing. Make sense?
Oh, okay, you're talking about turning the camera vertically and diagonally.
Or the subject. I mean, the camera could be horizontal and the subject diagonal. It's the same. It's the two color fields, crossing the plane of the center of the camera, which the horizon would do pretty much, plus or minus the amount of degrees of declination that you'd have for your altitude.
Okay.
So the fact that the horizon is going to occupy almost the midline of your view, very close to the center of the frame, right? Or if you actually can manipulate the camera and put it at the center of the frame, which a lot of them do for these observations, the very nature of the camera and the very nature of the two distinct color fields, being the blue of the earth and the black of the air, waning off to be a very, minimal atmosphere. Those two color fields with a stark contrast are going to display exactly what you said, where the edges seem to be curved down. Now, the black is actually curving up away from the axis, the x-axis, and the blue is curving down away from the x-axis equally. But you can't really tell because there's nothing to look at in the black. So all you see is a stark difference between the blue and the black, appearing to be that the blue curves down. And then you mistakenly attribute that to Earth curvature rather than the camera effect, because you, being the ignoramus that you are, when you sent this up into the air, thought that you bought a camera with zero distortion because you're dumb. I rest my case.
I got you now. You're saying that this is an actual feature in the lens itself that specifically adheres to these specific colors.
No.
Okay, then I misunderstood. I misunderstood that part when you brought in the colors. I just know when I look at the horizon.
It could be any color. Look, here's the fact, bro. If what you're looking at is all black, you're not going to notice any of the distortion. But if what you're looking at is half black and half blue, you're going to notice it. If it's half red and half green, you're going to notice it.
Right.
Two distinct color fields. That's all that matters. That are crossing the plane, like the axis that passes through the center of the optic, or close to the center. If those two parallel fields create a line across, the way in which that lens distorts is going to make the edges look like they're curved. It's that simple.
Gotcha.
Now, if you did any research, and I'm not speaking to you, I'm speaking to the people who think that they had a point when they did this, like Mr. Sensible and his other acolytes. Like, if they actually did any research into the lens, they'd know that that's the exact type of distortion that lens produces. And they all claim they have a distortion-free lens because they're retards.
Yeah, I don't think you can have a distortion-free lens.
As far as I know, all lenses that have an angular field of view have distortion, and the only ones that are allegedly distortion-free are non-angular field of view. But they can only take photos of something the exact size of the lens. So if you have a 3-inch lens, your photo can only represent 3 inches of reality. So if a bust is 500 feet away from you, you're only going to get 3 inches of the one letter. If it's right in front of you, you're only going to get 3 inches of the one letter. It's not going to have perspective effect or anything like that. But the only way to do that is to, you have to collimate the light, have it come in at a certain angle. And even then, they're not perfect. They're mostly used for manufacturing and machining and stuff, where they're taking pictures of parts because they want to have accurate measurements, stuff like that. But other than that, they're really not employed because most people need to see a lot. So your camera is tiny, but you want to take a picture of the entire football stadium. How can you take a picture of a football stadium with a 1 centimeter lens? If you had a non-angular field of view, it'd be impossible. So you have to have an angular field of view. Once you get into an angular field of view, then you have the physical problems that result from that.
That's actually how your lens of your eye works. The muscles in it stretch it and constrict it to create your angular field of view.
Well, that just alters the amount of light and the amount of available packet angles that come in. But the nature of having an angular field of view is just the base of how your eye functions. Like the muscles don't create it; they'll alter it. But if you had a fixed diameter in your eye, it would still have an angular field of view.
Right. No, that's what your iris does. Is it fixes the diameter. But what I'm saying is like the lens itself, there's little tiny muscles that are attached to it, and they stretch and constrict it even just a little bit. But that little bit changes so much, and it has such a benefit of how your vision sees.
Yeah, it helps you focus and all that type of stuff, which is why you're supposed to do eye exercises when you have bad eyes, not just get glasses after new prescription after new prescription. But they stopped doing that. When I was a kid, they used to put the kids onto the eye exercises and corrective lenses, but now it's just like a whole big conspiracy where they just want kids to get worse prescriptions every year and just keep buying glasses and stuff. There's actually listen, if you're ever bored, there's a whole documentary about that. The conspiracy to make kids and adults' eyes get worse and worse every year so that they can keep buying eye products, because this one Italian corporation bought the majority of the eye care stuff in the United States, called Luxottica. That's the company. If you're ever bored, look that a documentary up. It's hilarious.
Wild.
Yeah, simple things like these dudes are like, oh, you have to believe in conspiracies. Like, dude, did you know that the majority of people having to wear glasses and get worse prescriptions every year is a conspiracy? Oh no, that's stupid. But yeah, the whole documentary all about it. Makes perfect sense, though. It's like, why give you the cure when I can make you pay for the symptom relief every year?
You gonna get me started, man.
I actually just picked up my new pair of glasses with a slightly increased prescription just the other day. But luckily, I got my contact lenses with the same prescription. And I tried to get those guys to not change my prescription too much because I know the scam.
Yeah, supposedly they're supposed to like re-examine you every year, or like it's highly encouraged or whatever. Like they push it.
Heck, dude,
medical side.
Dude, the reason, dude, I could literally wear the same contacts for the next 10 years if I wanted to. So they want you to go every year so that they have a contact point to get more money out of you. Right?
Yep.
All right, so now that we know that pretty much everything has some kind of deception, conspiracy, or monetary or deceptive intent behind it, it's not such a far stretch to think that they would lie about the shape of the earth to control the minds of the populace for their worldview. So, I mean, when people ask me why would they lie, I ask them, why do you have zero imagination?
That was one of the things that came back once I started realizing the Earth was flat. I'm like, oh my gosh, space is imaginary, and then my imagination starts running wild all over again.
Yeah, it's crazy when you think about all the possibilities. And look, let's be clear. It is not the case that the mainstream heliocentric paradigm has a lock on sensibility and rationale. Many of those dudes that believe in that, like upper-level physicists and stuff, they have crazy ideas about the nature of reality. So it's not the case that the flat earthers are the crazy ones and the heliocentrists are the most sane, rational, scientific, data-driven ones. It's not the case. Plenty of them are cuckoo brains.
Yeah, I'm pretty sure that when they get to that level, they probably sit down and work out the math of what it would take to have a planet full of like completely covered in uranium and raining diamonds. You know.
No, it's worse than that, dude. That's like level 2. When you get up to the higher level, you're talking about how reality itself works on a fundamental level. So they'll be talking like there's a single particle. Not that there's a single particle with many copies that make up reality, but just one. One particle makes up everything. And it has to be in multiple places simultaneously and be retroactive in time and proactive in time. So it has to zip around and render your finger, and then zip around and render somebody else's butt, and then zip around and render somebody else's button on their phone. And it has to do this all like in a super temporal state. You know, almost like a transcendent, omnipresent deity. It's like, these dudes are nuts, bro.
You know what? Because you said that, now it makes sense. In the night at the Roxbury, when that club owner said, "Did you touch my butt?" That's probably what happened.
Yeah, exactly. These dudes are like, and they believe this stuff, dude. And they say it at physics lectures. And everybody in the audience is like, wow, you're so wise. But if a flat earther says something like, oh, you're retarded. All right, so that's my limit of the R word for the day. So in protest, I'm going to stick my fingers in my ears. No, I'm just kidding. I gotta go. So I'll check back in. Peace.
Be safe. But yeah, T-Dub, does that make sense? I know AI kind of like had some things to get off his chest. But did my thing make sense about the curved tangent line?
Yeah, it just depends in what the context is, because like if they're not using it for distance, then it doesn't matter. But I guess, well, hang on, yeah.
I mean, if you walk them down the logic of we see too far, then they're going to invoke refraction, is why we see too far, right? And then eventually you have to steer the conversation into celestial navigation and taking angled measurements to the star. And then they're going to say, oh, well, yeah, you have to draw a tangent from your to make your baseline. Oh, okay. Well, are we drawing a tangent to the horizon? Yeah.
Well, it can't be a tangent if it's curved. Yeah, that's right. Oh, I think.
Yeah, that's what I'm saying.
I don't think you can use curved tangents, can you? Well, you can't get angles from curved lines. So.
That's why it's so funny. That's why, like, I seriously, like, I hope we get somebody in here or in politics where they walk down that road and I'm like, okay, so we're using a tangent to the horizon, right? And they're like, yeah. And that horizon's refracted, right? Yeah. So we're doing a curved tangent now? Because it's refracted, it's bending around the curve.
Right, because if that point, because if they're going to use that point of the sphere's surface as a tangent point, if you draw a straight line from the observer's eyes to that point, it's going to cut through the curvature of the Earth, isn't it? Hang on, wouldn't it? It would have to.
Well, yeah, like if you had a horizon, if you're 6 foot height, you had a horizon 20 miles away, right? A known horizon of at least 20 miles because you're looking at an object that's like 18 miles away, right? Let's just say. You know, at 6 feet, your horizon's supposed to be 3 miles away. So now you got to find something 3 miles away and you got to look down at that, and that's your tangent. You know what I mean? can't look at the thing 20 miles away. I don't know. I'll work on it, and I'll circle a glober in it, and I'll let you know how it works out. Maybe it'll be recorded. What's up, Mush King?
Who's that talking?
Sheepdog.
Oh, what's up, sheepdog?
Not much, man. Just finishing up work here.
Protecting the flock?
I guess so, man. I'm just doing what the Lord wants me to do.
Has Matthew Learns been in here today?
Not that I'm aware of.
I'm gonna get back into my research mode. I'm gonna make a presentation to show to Matthew Learns about NASA and the moon landing. I feel like he's so reasonable and he's smart. I feel like I might be able to get him to start questioning the moon landing. But I gotta come correct. I gotta
You'll have to do that. You have to do that in politics or somewhere else, not here.
Oh, where? This is English Hub?
Yeah, he's not here anymore.
Oh, what happened?
There was a vote.
Yeah, he voted Matthew Learns out.
Yep.
Too much appeal to emotion.
I've never heard Matthew Learns appeal to emotion before. Usually he kind of sticks to.
Well, he's a teacher, and a lot of people here are learning English, so he's going to appeal to that authoritative side. And he's going to make himself sound very, very friendly, and he's going to make you feel comfortable. And he's going to pull the rug out from under you.
Yeah, he's a formidable glober if there is one. But yeah, I'll do it in politics.
I got him to admit something.
Oh yeah? What's that?
He said, hold on, I was talking to him one time, one-on-one. It was like late, like 10, 11 o'clock at night. And I was winding down and said, is there nothing in the world that would convince you that the earth is flat? No, it's just too much evidence for the earth being a ball. I was like, okay, let's just go into hypothetical, because this is what we always end up having to do anyway. Because, the flat earth always presents reality, but, occasionally I will dive in hypothetical just to see where people's brains are at.
Yeah.
So hypothetically, if NASA came out today and said, breaking news, NASA has been lying and stealing money from the government for however many years, and the truth is that the Earth is flat and stationary. Here's all the evidence. Here's the paperwork. Here's the reports. Here's the video. Here's the audio. Here's the photos. And then what would you then say to that? And he would say, well, I would think they're lying then. And I'm just like, I was like, what makes you so sure? Satellites and sunsets. And that's it. He sticks to satellites and sunsets. He won't change his mind.
Yeah, the sunsets really do it for him. I've heard him say that before when people kind of push him on, like, what's your, like, best, evidence? And I think I've heard him say sunsets before.
Which is odd because, like, I argue for refraction, monotraction for a setting sun, and and it just to me it still sticks by it. Like, there's no exclusive evidence of the globe. Everything has a kinematic equivalence. The only difference is water always measures flat. Except for small areas where there's surface tension.
You're roboting a little bit there. Could you repeat that?
I said we can demonstrate bottom-up obstruction on a flat surface using refraction.
Yeah, true.
And so there's no exclusive evidence for the globe. Everything has a kinematic explanation for it. Regardless, if we don't have an answer now, doesn't mean that there's not a kinematic equivalence to it. And I know it's an appeal to future-proof, but at the same time, the difference between the ball Earth and the flat Earth is you just coming down to the measurement. Like, you just got to get down to something. You got to find something that has a standard level of level, right? And that's water, like sea level, bubble level, like everything that is also
roboting.
Yeah, I think I understand what you're saying, Sheepdog, and I kind of started coming to the same conclusion with the optics and light and how that works, and it's like the refraction argument and all that stuff. It doesn't really move me because light doesn't always travel in straight lines. It refracts, it bends, so it's not really going to move me one way or the other. That's why I try to stick to other things in physics, but there's not enough reliable evidence or enough reliable testing that's been done. It seems like there would be more verifiable evidence, so that's fishy. So, there's something's up. I think something's up. Something's going on.
Oh yeah, for sure.
Matthew will tell you that he observed the sunset, and the better explanation is because globe. That's the better explanation, therefore. And doesn't matter how many explanations anybody can give him. He says the better explanation is the globe explanation. That's it.
Yeah. Yeah, he says that the globe is the best explanation for the phenomena that we perceive. That's his stance.
But isn't that skipping a bunch of steps? Because if you think about it, before you go to that conclusion, if you put all the pieces of the puzzle together, the globe doesn't have many of the pieces. It doesn't pass the level test, the water test. It doesn't pass the motion test. It doesn't pass the smell test with the gas pressure. But he skips all of those things and he says sunset, an explanation. But skipping water, the lack of motion, the lack of curvature, and the lack of container for the gas pressure in the globe idea. So he skips all the important things and just says explanation of this, and that's it. That's what brings him to the conclusion. An explanation by someone.
Yeah, I really want to. I'm gonna make a presentation and show it to him about the moon because I feel like he will actually like take the points, like listen to it, and give a reasoned argument back. And I feel like I could really put something together that can make him question if we went to the moon. Now that I'm not saying that would make him question the globe, but I think I could at least crack him open to questioning the validity of the moon landings and maybe the validity of NASA itself.
Matthew's more like a guardian of a big deception, and he's gonna be like one of those scammers that will lie to you even if you know it's a scam. They'll just tell you, no, this is not a scam, it's true. It doesn't matter what you say.
Yeah, maybe.
A gatekeeper.
That's for sure. Him and Jesse Path of Light are like on the same level.
I've looked into moon shade temperature versus moonlight. I have a little, just a regular mercury thermometer, and I perceived a difference. Like I set it out in the moonlight and I set it in the shade, and I perceived it to go down just a hair. Now that's not scientific at all, but I've also looked up, Googled it to see if anybody else had done anything. And there's this guy Peter Lean. He does all kinds of weird little experiments, but he did one with moonlight. But I don't think he ever actually came to a conclusion on that one. So I haven't found good evidence on the moonlight phenomenon. Because people say the moonlight's colder. It makes things colder, which is weird. Which would be weird if that was proven to be true. And then you got the Elias effect that supposedly this Frenchman did a pendulum test and it started going the opposite direction. I think it was during the eclipse, a lunar eclipse. And then Foucault was French too, so I don't know. There's a lot of French guys and their pendulums doing stuff over there. And he came up with another, like a different kind of pendulum. It's called a paraconical pendulum. That was invented by Frenchmen. I don't know, the French and France has a lot of things with pendulums going on.
And to that, I would say, don't worry, dude. We don't all swim.
There's a pendulum frenzy.
No, not funny. Aw.
I was looking into the spacesuits that they give the astronauts on the moon, and apparently it gets like, if you're in the sunlight, it gets up to like 200 something degrees Fahrenheit, but then on the backside, in the shade, it's like freezing temperatures. And they did a stress test of the suits, and the guy that was out there in the desert where they were stress testing it passed out inside the suit, and there's no more evidence of them testing the suits. And then the oxygen tank, that's another thing, because I think in the sixth or the fifth mission, they were out on the moon for, I think it was up to 20 hours, but their suits, they had these like little canisters of oxygen, but they're compressed oxygen. Man, if you look at the like big giant tanks like the divers use, they can only be under there for an hour or so. So they got these little canisters of compressed oxygen. How did they stay out there so long? Those little canisters. And then the suits don't seem like they were really developed to withstand this kind of temperatures. And then you look at the hull of the lander and the radiation that they're exposed to, and like, how did it withstand all that radiation? Because there's one document I was reading, and they were saying that the whole ship would need to be encapsulated by like 6 inches of water, just for the trip there for the radiation. Well, I mean, that they didn't use that. I guess they used something else.
What about the gases trying to escape the suit? Wouldn't the suit look like a balloon? How are they bending their arms?
The gas is trying to escape the suit. Yeah, it's a pressurized suit. I think it's pressurized.
Look at what a balloon does in a vacuum. It fills the available space.
Yeah. Well, if you're going by the globe model, then the moon does have an atmosphere. It's got some gravity to it, so it wouldn't be close to a vacuum necessarily.
Yeah, the gases will still try and find equilibrium.
Yep. The shit seems ridiculous. Like, you look at the lander, just it looks like it's made out of tinfoil. The little rover thing looks like it has a freaking lawn chair strapped to it. If you look at like the Indian moon mission, they got video of their little lander. It just looks crazy. It's like, this does not look legit.
I know how retarded you got to be to believe that stuff, man. It's just unreal to me.
Well, you don't got to be retarded. I mean, it makes sense that people would believe it because, I mean, to not believe it, you're saying, well, everybody's, all these people are deceiving me. There's a whole government agency. And most people, they're not going to put the time in to really research those kind of things. So it's not like I think people are retarded who believe in it. I more think of they just haven't really put the effort in to look into it. They got other things I think
that too, yeah. I mean, I don't know. It's if you really look into it, it's ridiculous, dude.
Yeah, I believed it, and then I started looking into it. As soon as you start questioning those things is when you start finding fallacies. Until then, yeah, you're just fooled.
Well, I questioned it in elementary school, right? Like, how do we know what's in the core of the earth? We haven't dug that deep, right? And then my teacher's just like, oh, that's just what they teach you. It's like, okie dokie.
Yeah, how do they know what's in the core? You haven't gone down there to look, right? But they're saying, well, that's where the lava comes from. That's where, the lava's spewing out from the core. It's a molten core. I mean, what tests did they run to figure that out? I don't know.
Yeah, and the whole 92 million miles away for the sun, like, that's another question I asked in elementary school. I'm like, how are they even ascertaining these distances? It just makes no sense. And then the whole evolution thing, 250,000 years ago, we know this. It's like, do you really? 250,000 years ago? Like, cap?
Yeah, so you were a monkey fish frog, and then you came out of that, and you had sex with a squirrel, had butt sex. South Park episode. It's hilarious. Mr. Garrison's teaching the kids evolution.
I never watched that episode as a flat earther. I gotta watch that again.
Oh yeah, it's good. Well, I mean, evolution is readily provable, but not speciation. So, say evolution in the sense that we came from monkeys is not. There's no evidence for that. Now, there is evidence that things do evolve and adapt. But the speciation part, there's no evidence for that.
Yeah, evolution as in to survive, adapt and grow stronger, yeah.
Yeah, like those dolphins that were originally saltwater, and then all of a sudden they adapted to freshwater. But who knows? That could just be a story, right? It could have been freshwater all along. Like, I haven't looked into it deep enough.
Yeah, like giraffes. The reason they have their long necks, it's not because they're stretching their necks over and over and over again, and a generation after generation, their necks are longer. It's the ones that could reach the food survive, and generation those giraffes that have access to the fruit and the high trees keep procreating, and then eventually you got these things with crazy long necks. But what they don't have is going from a horse to a fucking zebra to a this to a that, monkey to a human. There's no evidence that things evolve in that fashion.
Yeah, I gotcha. Sorry, I'm just munching on cookies, bro. They're hitting hard.
Yeah, I'm just more for the strong survive and the weak perish. So, the next generation will have a stronger, gene.
Yeah.
To survive because it's been passed on from the last generation that's survived through the tough days.
Makes sense.
Yeah, it makes more sense than all of a sudden a rhino grew a horn. Like, how did its body know it needs to grow that horn in that, in that area? Survive the next generation. Like, come on. Did it start headbutting things and all of a sudden, I need a horn right there. Head's not hard enough. It's just stupid.
Yeah. Well, the answer to that question would be that nature selects. So the environment, whatever that thing that ended up with a horn, the environment selected for whatever that creature was, that the harder that spot was on its head, that one survived. And thousands and thousands of years go by, and now there's a horn on it.
Well, that does make sense, yeah. But if that area was already hardened to start with, and it's just gotten harder and more affected over time, yeah, that does make sense.
The best explanation they have for humans is this is what they say. They say it's the hand-eye coordination. So once the throwing of things, that's what spurred that. I think the brain growth, unprecedented brain growth. I think it was like over a span of 1 million years, the brain grew so big, and the event that caused that was throwing things. Which I don't think that's a very good explanation. A better explanation, what I heard, this is called the the stoned ape theory. Terence McKenna, he said that as apes moved from the treetop to the grasslands, they started flipping over cow pies and finding these mushrooms, and they would take the mushrooms, and mushrooms at low doses, you have a better peripheral vision, and it's a stimulation for sex. So these monkeys that are eating these mushrooms, they can see predators better because your periphery is enhanced. They're having more sex, and then they eat a whole bunch of them. They're having crazy thing happen in their mind. So I mean, I don't know what kind of effects that has, but I feel like that's a better explanation than throwing things. Monkeys started throwing things, and that hand-eye coordination is just what made brains explode in size.
Yeah, it's definitely out there, but it's better. Can you
give that a what for me, please, still?
Yeah, way better than throwing things. Yeah.
I personally think we were designed. I mean, I think it's kind of obvious. They say, well, you're designed by nature. No, nature's designed. We're designed. It's I think that's way more likely.
Yeah, well, definitely of creation. Everything's too perfect. It can't just be evolved from nothing. There would be mutated things all over the place that didn't make, and there wouldn't be apes still. A lot of it doesn't make sense.
Yeah, I feel like people like that they hide in that. People with like low morals, or they want to do things a certain way, and they kind of hide behind the fact, well, I mean, we're fucking pond scum, nothing matters in the end. They're kind of like, I don't know if you'd call that Satanism, more of just like, maybe it's called more scientism, just like nothingness. It's kind of random mutations. They like that because then they can really do anything, or at least they feel like as if they could do anything, or it justifies your choices because it's all just random anyways. Nothing really matters, happy nihilism is what they call it. That's like the scientific religion, happy nihilism.
Yeah, that's crazy. I'd rather not look into that kind of stuff. It's kind of, I don't like the idea of it, so I don't like to put that stuff in my head.
Yeah. Well, things do have meaning, and it's not all just pointless. But you can't just be spoon-fed it, you know? It's not easy. If it was easy, then it would be pointless, you know? So you can't fault people for questioning things, but it's like, once you've been given the information, you know, then it's on you what you're going to do with it.
Yeah, unfortunately, we have been faulted for questioning things when it's in our nature. It's pretty sad to come to, really. Much rather, you know, be ridiculed for questioning things than to live like a zombie. You look out there and you're like, I'm glad I'm not like that anymore. Or I'm glad I didn't become like that to this day.
Yeah, it takes some cojones to come out there in public and say that, you know, the earth is flat. Because people are just going to say you're fucking retarded. You know, that's what they do. They put it in the, you know, Obama made fun of flat earthers. Fucking, like they bring it up, you know, at their White House dinners. Or, no, the correspondence dinner is what it was. But I mean, to be fair, all that stuff is written for him, so it's not like Obama, you know, but I guess Obama's organization.
Yeah, I do it all the time, just for the reaction. I get quite amused by it.
Yeah, the first time I really heard about flat Earth, I went over to my friend's house. They used to be my roommates, but they had moved out. But we were just hanging out, and I went over there. And the first thing they did, they were like, "Look at this video," and they showed me a video of some guy, and I think it was a lighthouse, and he had his video camera that was across the lake. He's like, "They should be able to see that." It was a flat Earth video, and I was just like, "What the fuck is wrong with you guys?" I was like, how do you know where this dude is, where this lighthouse is? This is just some video on YouTube. You don't know any. He's claiming it's too far to see, but do you really know? And they're like, he just showed me the video, and I was like, no. And I started explaining to them about stuff, because this was when I was in college, so I felt like I was pretty smart. But, yeah, since then, I've learned more about my own, the globe model itself, because really I didn't know much about it until I started arguing with flat Earth people.
Hello, could one of you go in the? Could one of the mods here go in the politics flat Earth channel? There's a few guys saying some pretty crazy things.
What are they saying in there?
I don't want to say what the live stream on.
They're saying like
it's pretty messed up, dude.
Tell them to get out of there.
Yeah, they won't leave, dude. That's why I'm calling the mods.
Did you say it? All right.
Do we have any moderators here? Is you moderator, Mike?
But when they showed me that, the first thing I looked up when I was like looking up stuff was the Eratosthenes. So that proved it for me. I was like, oh, look, here's Carl Sagan, and he shows exactly, you know, he has a little cutout of the Earth, and he bends it and shines the light and shows that the shadows are different. But then I learned that it could still be flat and the shadows could be different. There's a video of Neil deGrasse Tyson saying, well, actually, that would work if the Earth was flat as well. I was like, wait, how? What the fuck? So I had to look into that. And it's true. So I hate it when Globe Earther comes in here and won't admit that. They won't. Once the Flat Earther takes that step and shows them, oh, it actually would work if it was flat as well, they just say, no, it doesn't. And they don't. And it's like, wait, no, here's why. And they're like, no, fuck you. Like, dude, just look at it. Neil deGrasse Tyson says it also works if it was a flat. And then he said there's a better one, though, and it has to do with a well, and there's 4. And he goes off into that, but I didn't. Sometimes he didn't know what the fuck he's talking about anyways. He said the Earth is, you can prove the Earth spinning by a field goal kick. That shit. That shit was dumb.
Yeah, it's too much incredulity, really. They just can't cope. I really didn't have access to all of the content. Like, I watched a bit of Flat Earth Dave stuff, but he was, you know, he's all over the shop, and so I didn't really have anyone, you know, to talk to about it. So I just started doing my own research, and then I watched the stars for a year, and I was like, that's not making sense, you know. We're facing a different direction. I should not be able to see these same stars throughout the whole year. And yeah, nothing about the heliocentric adding up. And it all hit me one day, like all of the information that I've taken in just, you know, zips through my head, one after the other, and then from then on I was a flat earth. Went through all these weird emotions as well. It's quite revealing, you know, of a lifetime of indoctrination. So all of a sudden, you know, to get flat smacks like that, you know, under your own accord, it's pretty profound.
That's surprising to me because the stars, that's usually like the globe Earth to go to because you can explain them on a ball Earth. They make sense. Not saying they couldn't be explainable in flat. They just make sense on a ball. The motion of them.
Far from it. They should be spiraling.
Okay, well, there's 2 poles. There's two poles of rotation. So above us, there's 2 separate poles of rotation that are visible to the naked eye.
Yeah, I can't make sense of that because I don't know how, you know, the celestial bodies work and any of that stuff. Like even our eyes, how we take things in of a distance. So yeah, I'm not really intelligent enough, or you know, got enough info on that topic to explain it. But
if you go on the home server, Shaggy, the 24/7 home server, dude, there's like so much. Let me see here. There's like little hashtags and it has like everything. It's got. Let's see where it starts. Aether, Antarctica, articles and clippings, art, astronauts, references, long distance, celestial navigation, chrometry, Challenger, circumnavigation, like all kinds of shit. It's definitely got stars and polar rotation. I don't know if they mentioned the 2 poles of rotation though, because that's usually when people start arguing about shit. Because it's hard to imagine 2 poles of rotation over a flat plane. Like, what does that look like? But 2 poles of rotation on a ball, that's easy to imagine.
Yeah. Yeah, I'll have a look actually, yeah.
Stars. Yeah, hashtag stars. Let's see what's in here.
Right.
Star trails over a long exposure photo sequence with the ultra-wide angle lens has captured nearly an entire night over the Teide Observatory on the high slopes of Mount Teide, Tenerife, Canary Islands. The Earth rotation appears in form of the rotating sky above us. Well, there you go. Shows the rotation right there. It's kind of weird. I've never seen a picture like that. I don't know. I feel like that might be like a fake picture.
Looks like the one that spatter it.
The one that's what?
The one that's spatter posted.
I'm gonna see if I can post it in here. Save it.
Yeah, it looks crazy. That. I think I know the one you're talking about.
Oh, I can't post stuff in here. I can only post stuff in the politics one.
I think I might have terms.
It's under hashtag stars, and it shows 2 poles. Well, almost the pole, but yeah, 2 poles of rotation.
I think I know.
Scroll up a little bit.
That one there. Still sending. There it goes.
Yeah, that one.
Yeah. Yeah, it's pretty out there.
Like, is that fake?
Looks it, doesn't it?
Yeah, that looks fake.
You got over on the right there, there's like, in the center, there's one that starts halfway through. Couple, actually.
You can tell that there's going to be 2 poles of rotation in this photo, but like, that's got to be fake.
They're so close together.
Maybe not fake, but maybe there's like a distortion in the lens that makes it seem as if there's going to be 2 poles of rotation.
Yeah, how could they capture all that in one image? Extremely wide angle.
But yeah, that's kind of what you would have to imagine, though. With what we see the stars doing, you would have to imagine something not as dramatic as that. but there would be a interference between the two poles at some point, like that.
Yeah. How do you explain that on a globe? Also, that wouldn't work.
Well, it's easy to explain on a globe because on a globe there's two poles, so you would have two apparent poles of rotation because there's two poles on the sphere. So if we were on a 24,000 mile circumference sphere, on the north pole of that sphere, we'd see the stars rotating in one direction or one clockwise orientation, and then on the south pole you would see it in the opposite rotation.
Yeah, but the Earth is also moving in 5 other different directions. You know, we're orbiting around the sun, and then
Well, technically that's but see that is all linear motion because it's not accelerating or decelerating, at least at any kind of appreciable rate, because the orbits are so large that to our senses, it's just linear motion. Just like if you're in a car, you won't perceive if you're just going like 100 miles an hour but not accelerating or decelerating. You don't know that you're going 100 miles an hour. You know, it's that kind of thing.
Yeah, I just thought you'd see it in the celestial bodies.
No, because it's so slow compared to them. But compared to the distances, it just looks stationary because everything's just kind of moving together.
Yeah. That's what I have to put such vast distances between us.
Exactly. Because even if, like, at night, if you're driving a car, let's say you're going fast as shit, but somebody's got a real bright light and you're on a real long road, I mean, that thing doesn't look like it's moving at all until you get up close, you know, and that's only a couple hundred feet. We're talking about thousands of miles. Like, it's not even comparable. Like, the numbers don't even make sense. I could tell you how far it is. There's no way to really imagine that. Like, you don't have any reference to think of distances that far.
Nah, you can't comprehend it. I believe that's another reason for it too, you know. Comprehension. Can't really vision it.
Yeah.
So you just take it in as facts. How long you been a flat earther?
I don't believe I ever claimed that.
What are you? Not sure?
No. I'm definitely globe earth.
Definitely a globe earth. Yeah, could have. How long you been coming to the server?
It's coming up on a year because I remember the first time I found this place was like Halloween, like right after Halloween last year. So
yeah. How are you coming to this server and you still haven't seen how flat it is?
I still haven't seen what?
Seen how flat it is?
No, I've seen how flat it is.
Welcome to Flat Earth.
All right.
I'm not the government, mate. Don't worry. You don't have to submit.
Well, you could not be. Doesn't matter either way. I'm going to interact with the government agent the same way I'm going to interact with the non-government agent. So.
Yeah, I was just joking.
Maybe you are. It's all right. I'm sure the government's monitoring this channel for psychological operations just to see how things are going. That's fine with me. I don't care. I don't mind. Other people might. I don't see why. That would just add to whatever's going on.
I missed a bit of that. The radio, someone on the radio blaring at me. Trying to build a road here. It's good talking to you, man. I'm gonna have some lunch.
All right.
Oh, what's up? Yo. Andrew Chip. I nobody's like that's kind of strange on this channel. Like a lot of people have turned their mic off. Oh, he's fucking speaking. Yo, guys, there's fucking lot of people. Come on, speak, someone. That's fucking crazy.
Change its shape into a circular nature, doesn't it? Although the force is being applied only on a
Yes,
single or two.
a circle is a flat object, like a coin, one of those big lollipops you get from Disneyland. A frisbee, circular.
Mm-hmm.
Yeah, if you spin something fast enough, it's going to look like that. So, I mean, like, I don't know how much wind you're going to be blowing over some clay, but I don't think you blowing wind on some clay is going to make it into a ball, will it?
I mean, if you were to follow the local winds that flow around you to a point that you see and you observe where they're actually coming from, then you would see that you can't actually follow them. They rise and fall inadvertently over different spaces. That wouldn't be the case if it was the flat surface, right? If it was only the circular nature that they are rising and falling according to the interaction that they see with other winds around them.
We can have things rising and falling over a measured flat plane, right? We can have birds rising in elevation, decreasing in elevation over a flat plane, right? Like the clouds are moving above a flat plane. They're going from the ground up and away from gravity into the sky, and they fall back down over a flat plane. That doesn't change the shape of the floor, right? Like if I fly
Are
a
you
kite.
asking me? I thought, is that a
Yeah.
rhetorical question, or are you genuinely asking me?
No, yeah, I'm asking you. Like if you do something over a surface, it doesn't change the shape of the floor, right? Like if you fly a kite in your neighborhood, does it make your neighborhood a ball? Because a kite goes up and down.
Well, the winds are not just gliding over the surface, they're also interacting with the surface, as you see in the shape of, when dust gets blown up into the sky. It is that winds have caused the action of interaction that's why there is dust up in the sky. So it's not just that it's flowing over the surface, it's also interacting with it.
Okay, so if I open my front door to my house and dust blows in my house, does it make my house a ball?
Wait, I'm trying to catch the argument. I understood it, but that's not the question that I was.
You said that dust blowing up, right? You're inferring that can only happen on a ball. So I'm asking you that if I open the front door or back door or window to my house and the dust is blowing in and up around my house, does it make my house a ball?
How long have you kept the door open for?
I'll keep it open for 1,000 years, 10,000 years.
Okay. And how long has the wind been blowing?
10,000 years.
How strong is the... Have you done any repairs in the meantime? Has there been any person who has been, restraining or keeping the wind from interacting with your house?
No, it's just open to nature.
Yeah, I guess then in that case it would inadvertently become something of a size of a ball or spherical. It would reduce to be a size of a sphere, I guess.
Okay, so we've had winds.
Or it would at least show signs of some kind of curvature appearing around it.
Okay, so we've had these mountains supposedly on Earth for, I don't know what type of, model you ascribe to, but for billions and the billions of years. Why are the mountains not spherical? When winds have been blasting these mountains for billions of years in your paradigm. We've had trees alive for hundreds of years with winds blowing and blasting them. Why are they not
square
balls?
either, are they? And they're not square either. I mean, the mountains, being the shape that they are a reflection of how much, you can add to the top before things start flowing down. I mean, I don't know if you have tried attempting at building a salt hill or a sugar hill, but if you keep adding things from the top, they seem to,
well, they're not being
distribute themselves equally on the bottom, and then as
mountains aren't being, created from the top down, right? So it's not really analogous in the first place. But even if that was the case, right, you would never see something like that form into a ball because of wind. Like if I have like a little mound of sand and I blow some wind on it, is it going to make a ball?
I'm sorry, could you question that again, please?
Yeah, like if I okay, let's get some salt, right, and I pour it on my table. It's going to make like a little cone shape, yeah? If I blow some wind on it, is it going to make a ball?
Well, first you will have to, have the adhesion between the salt particles be more cohesive in nature, so that they can actually hold on to each other in ways that can support the spherical nature that you're trying to attempt to create.
Okay, so
if you add some water, molecules of water, or some glycerin, or some other holding agent, then possibly yes.
Yes, I will take a little hill of salt and I'll put some honey on there. Some extra nice viscous liquid for you. If I then turn on the fan will it form a ball?
I don't think so, unless you isolate it in vacuum or something around, because the adhesion to the floor might hold it more.
Yes, we could do that in a vacuum chamber as well. We can have a vacuum chamber. We can even take like some marshmallow fluff, okay? That's like super thick liquid, right? Or like some peanut butter, right? Put some salt on it, put it in a vacuum chamber. Is it now is it going to turn into a ball?
Don't forget the jelly. Peanut butter and jelly.
Yeah, we can mix jelly in there too, yes.
A little bit of honey too, please.
Yes, we can put all the good stuff in there.
Yeah, all of this discussion is making me feel hungry. I'll probably go and have something to eat, and then I'll come up with a better argument.
Okay, yeah. I mean, for sure, man. But I mean, if you ever want to talk about the whole wind thing again, I got you. Okay.
I don't think that I can actually answer that question. I mean, I can't replicate vacuum around me, but I need to. I don't think I can actually honestly answer that question that you're asking.
You know what? Okay, man. Fair enough. All right, man. Well, if you ever want to talk about wind and balls again, I got you, dude.
I mean, I'm not talking about balls, but I'm talking about the spherical nature of the Earth that we see around us.
Well, yeah, I was just trying
to. It is possibly more spherical than the flat one, and I believe that the spherical nature of the Earth is.
Yeah, that's perfectly fine. You are more than welcome to believe whatever you want. You are a grown adult
for human living and understanding.
I was just curious how you got to, ball from wind. That's all.
I didn't say it was a ball. I said that it was spherical in nature.
Well, yeah, balls are spherical, yeah.
Right. It's more of a geoid, as I've come to understand of late.
Sure.
Because there are abrasions. You won't see the abrasions of the mountains and the plateaus on a spherical surface, would you? Or
I'm just
activities like.
Well, we don't see the ball
different seismic activity
anywhere, so we're just kind of going along with it.
Here around us.
Well, I mean, even according to Neil deGrasse Tyson, if you were to shrink the Earth to the size of a cue ball, it would be smoother than any cue ball ever machined. So it's pretty spherical. It's like the most spherical sphere you could ever sphere. According to Neil, of course.
Well, have you done the exercise of following the wind?
Oh yeah, you're gonna follow the wind over a measured flat plane. The wind doesn't change the shape of the floor, right?
What do you mean a measured flat plane?
Well, yeah, the Earth is measured flat for everybody. So if we have wind over a surface of an object, it's not going to change the shape of the object, right? Unless you want to provide a scientific experiment demonstrating this, right? Like if I was to hold up a piece of cake in my hand and I blow some wind on it, is it going to change the shape of the cake? Or if I hold up like a kitchen knife in my hand and I hold it in front of some wind, is it going to change the shape of the kitchen knife? Like, is there any shape you could think of that's going to change because of some wind?
Well, first of all, the fan that you're using is not generating wind. It's generating a flow of air. And a flow of air is not the same as a wind because wind carries itself with different properties,
Wait,
like
so what is
different temperatures and pressures and such as that.
Okay, so we can
I'm
have
sorry, what?
different temperatures from the fan, right? Like we can have a heated fan, we can have a cooling one as well. Like I can blow on it with my mouth.
And
like
they're
whatever type
interacting
of
with each other together. Yeah, that.
yeah.
Mhm.
Okay, so including all of those variables, like if I was to set an alarm clock in front of that, like all those different temperatures of air or wind, whatever you want to call it, is it going to change the shape of the alarm clock?
The shape of the.
I mean, it's like the same with the mountains, right? Like they go through all sorts of different temperature variations throughout the day, the year, decades, millennia, billions of years according to your paradigm. You know, they don't look any more spherical than a safety cone.
I think his response was perfect. Shit. That's the correct answer.
Right.
I mean,
So,
if you need
so
help,
you're
brother,
questioning me that the wind would actually change an object into something of that sort, and most
Yes.
definitely it would, given the time period that you're referring to. But I haven't tested it yet. Testing it myself, so I wouldn't say that it would. In your case.
Oh, okay. Can you find any kind of citations or anything to support this idea that wind turns things into balls?
Why would you question it in the first place that the wind... I'm not saying that the wind turned the object that was flat at one time,
It's measured
but
flat.
if
You're giving
if it
us
was
a
flat
story
at
of how
one
wind
point, then
can turn something into a ball, right?
No, you're right.
You're telling us how wind proves that the Earth is a ball because it turns objects into balls. That's what you've been telling us.
No, yeah,
or
right.
like even if that's not the case, or like if that's not what you were telling us, if you're saying that wind can only blow over the surface of a curved object, right? I can take any object in my house right now and have some wind blow over it. So we know that's not the case, right? Like, can you at least agree on that? That wind can blow over any object?
Well, the circular nature, but you have revealed of the envelope of Earth. I gave that as an argument before, that the circular nature of the wind would reveal the envelope of the sky, and if anything is being enveloped by any external thing, then it should, by its nature, be on the top and the bottom. So if it is a flat surface, then there should be a flat surface on the bottom as well, revealing a circular nature. So it most
the bottom is
definitely might
flat.
be a disk and not a flat surface that has
the
like
Earth
two
is
sides
flat.
and also an edge or horizon.
So why would it have to have an edge to have wind?
Because if you have seen a circular disk of any sort, then you might have seen that there are just not two surfaces, but there is one on the circular edge as well. So
okay, so you've seen a tornado before? Or a hurricane?
I have seen some sort of a wind circulation in the air that resembled a tornado, but it wasn't a well-formed one as otherwise. So I've seen some kind of weather pattern resembling it, but not completely.
So was that phenomena that you observed contained?
What do you mean by contained?
Yeah, like you said, it had to be a disk, right? But if you observe this phenomena happening in the middle of the street, does that make your street a disk?
Oh, you're asking about those local winds that appear as a tornado, but they're very smaller and then they disappear.
Yes, we can have circular wind, right? Like you stated.
Mm-hmm.
Yeah, and we can observe that happening. It doesn't make the floor a disk or the floor spherical. Like, can we at least agree on that, or?
Okay, so you're attempting at, disproving my assertion that the wind can reveal the envelope of the Earth by stating that wind in a delocalized manner does not reveal the surface phenomena or the envelope one.
Correct. Yeah, wind will not tell us. Wind will not tell us what the surface is. You have to measure the surface to know what the surface is, right?
I mean, the flowing of the wind can reveal different things depending upon what we are engaging with it in. I mean,
yeah, it can reveal things like temperature, pressure, right? Those things are fine. You can have those things on a flat or curving, zigzaggedy surface, a swirling surface, right? That doesn't mean that it's happening over a spherical one.
You also do know that you haven't actually presented an argument yet, like saying that there's a relationship between your the air going in circles and some imagined envelope of the air is not actually proof of it. That's just a claim.
I'm sorry, Grace, what did you say?
Yeah. If you tell us that the air going in circles somehow relates to your imagined sky envelope, and that sky envelope somehow proves the Earth is a sphere, you're making a bunch of logical leaps, and you have not yet established that. You're just claiming it.
Yeah, we're like looking for a word like because ...
I'm sorry, Grace, can you go at it again? I still am having trouble catching
Okay, so yeah, like if you say something
with that statement.
Yeah, if you say something happens because of something, that is because blank. We're looking for that because word.
Okay, yeah. I mean, you asked for a proof that for the globe, and I gave you that the refraction through that I see in the air of the sky envelope gives me the idea that it is a circular, it is a spherical shape, because you can it helps you reveal the circular the dome-shaped apparatus that seems to hang around on the top of our heads. And
okay, so it sounds like you've measured something above the ground.
Mm-hmm.
Right, so what about the ground? How does the ground measure?
Yeah, I mean, okay, I have not measured the ground per se, but that is more of a deduction that I have derived. But
okay, so
if I were to say that going up on the top of a mountain to see the flatness or the curving nature of the surface around the fifth view, that could provide possibly the
Here, I'm going to give you a
idea
simple. I'm going to give you a simple analogy. Okay, so let's say you, me, Drace go on top of a mountain, right? You go on top of the mountain. You say, "Oh, look, I see curve." Drace says that it looks flat, and then I say it looks zigzaggedy, right? How are we going to know who's right?
Well, we're gonna spend some time in a tent there, possibly, and then the next day we are gonna make the same observation and see if the curvature changes in any form. I mean, or the other. Maybe the next observation that we make, we may have like 3 different observations again. Somebody might say that it's a helical structure appearing where the ground appears to be on top. It could.
And then let's say the next day I see curve, you see the zigzaggedy, and then Drace sees a swirling horizon. So how do we know who's right? How do we know what's actually happening on the surface of the earth?
Well, then, are you attempting to say that the surface of the Earth is immeasurable because of the refraction, or the refraction of the medium is so invariably not a trustworthy source? So questioning
I never said that at all.
assertion of the wind.
I'm just saying that we should measure the floor, right?
Mm-hmm. And how do you propose that to take place?
We can do all sorts of measurements, right? Like we can do laser tests over water, right? That's a really good one. You can do that yourself. Cheap.
Oh, right. Yes. That is a good one.
You can bring the tent too and to the beach and and measure after you take a nap in the tent.
Well, I'm gonna have my own tent. Yeah.
Slumber party.
I was just reading about the experiment as conducted by someone called by the name of let me see what I wrote the name as. I think his name was Wallace, who made the.
Why don't you mention what he's trying to refute?
His name was Alfred Russel Wallace. Yeah.
Yeah. Why don't you mention why he did that? Because by doing what he did, he was trying to refute someone and something that someone did at the same place where he did his test. So why don't you mention the first thing and then mention his?
Okay, I mean, I think the test of using a laser over water was something that leads me to believe that was something that he attempted. I'm sorry, I didn't quite understand what. Are you saying that
so you're talking about the Bedford level, quote unquote experiment. Right, yeah. It's not an experiment, but okay, we'll call it that. All right, someone else went there first, right, and got down to about 8 inches above the water with a telescope and had his friend sail a boat down that canal, right, for 6 miles. Now, over 6 miles, I think there's estimated to be, would be around about 30, is it? 30 or 40 feet of curvature. So, and the boat was only about 6 feet tall or something like that, right? 8 feet tall, like the mast, to the top of the mast. It would have been well hidden behind the curvature of the Earth at that distance, all right, after 6 miles. And the man called Rowbotham kept his friend in the boat in full view in his telescope the whole way. Okay, the globe, proponents of the time didn't like it. They didn't like someone suggesting that the Earth's flat and not a big spinning ball, right? So Alfred Wallace developed his own test to refute that at that same location, but didn't perform the same test as Rowbotham. He got a theodolite and then lined up a pole and then had a bridge marking, right? Marking on the bridge. That was how many miles away was that, guys? I can't remember. Okay, it's further down the canal. And then he tried to line them up to see if they'd line up level with the theodolite, right? And he claims he had to tilt the theodolite down to get the marker on the bridge to be level with his theodolite, right? With the crosshairs in his theodolite, leaving a pole that he'd placed in between, protruding up above the crosshairs, right? Claiming that indicates there's a curve to the Earth. Yeah, that's the story.
Now you have to consider that theodolite helps you not just measure the distance, but also vary in the vertical and the horizontal angle adjustments that there may be that need to be done.
That is the issue, because when they try to reify the globe into existence, they do not account for perspective or things actually dropping in height with distance. And so they call that Earth curve when we can show that happening over engineered flat surfaces. I heard you mention the horizon earlier, and that's a common misconception with the globe belief, because they originally started by assuming the globe in ancient past and then trying to reify it by looking at shadows on the moon, looking at the shadows from the sun, trying to look at the horizon dipping when they go up a mountain, and they looked at all sorts of different things. However, most of those things did not account for refraction. Most of those things did not account for perspective at all. They just reified and assumed the ball. And when we do go and test for these things, turns out all of the assumptions that you need to hold to believe the globe is true, for instance, all the light is bending around the globe to allow you to see further. So whenever you see further, you must assume all the light is bending or refracting. However, when we test for that refraction during those times, it's not refracting. And you can do that very easily using visible light cameras and infrared cameras, because infrared light refracts far less than visible light. And so when you have both of those cameras looking at the horizon at the same time, you should see the horizon appear closer in the infrared when you can see too far in the visible. However, what actually happens is you see even further in the infrared, which is the complete opposite of what would be required if the Earth was a ball.
Right. Could you give me that argument again, please?
It's very simple. Different wavelengths of light refract at different rates. This causes prisms to cast rainbows. Do you understand this point?
I mean, I can understand that, and that you're trying to say that there is some kind of a different refractiveness of the medium that causes the bending of the light.
No. I'm teaching you how actual refraction works. Different wavelengths of light refract at different rates when they enter the same medium. So you could take white light and you cast it at an angle to a surface conducive to refraction. And so out the other side, you'd get a colored band of light, because the white light has now split into different wavelengths, because each wavelength refracts at different rates. And so we found infrared by doing this, because infrared is not visible light, and it's below the spectrum of visible light. And so we know it refracts even less than visible light. So now we can take visible light and infrared and compare reality to check for this refraction that is assumed to hide the globe from all measurements. But when we test for the refraction, the assumed refraction isn't there.
Right. I mean, but by the way, the infrared was not discovered just by the prism, but also by the thermometer, which measured the diffraction of the.
Yeah, that's Herschel's experiment. They discovered it because of the prism, and when they put their hand underneath the light, they found that it was hot, and so they got a thermometer and they proved it with Herschel's experiment.
No, he discovered it by accident, as I was to believe, as I remember, that the thermometer was measuring.
Could have been he just happened to have a thermometer with its little mercury bubble end sitting right at that very place.
The story goes when they first split it, they put their hand in the beam and found that it was hot underneath the rainbow, and so that's the human was the first thermometer in that. But then when it was used to show other people how it was and teach other people, it was formulated in Herschel's experiment using a thermometer.
Right. Could be. I'm not arguing on that.
Okay, so you do understand that different wavelengths refract at different rates. This is how the military creates its targeting systems. They use tri-beam laser targeting systems so that the three lasers of the different wavelengths, if they start deviating from one another, they can actually calculate how much refraction is the target is off from where they're aiming, so they can hit their targets. Like, this isn't refraction isn't some magical woo-woo that you can claim to save your religion. It's actually quantifiable, and there would be evidence of the refraction, and we'd be able to measure it on those days when we're supposed to have this refraction to hide the globe. However, it just measures flat, and there is no globe.
Yeah. See.
Wait,
people are pointing lasers.
Taken away. Mm-hmm. Yeah, please.
People are pointing lasers at targets and missing and going, well, light deviated, changed direction, right? And then, like Drace was pointing out, and then some people are going out and pointing lasers at targets and hitting the targets, and then the globers come along and say, well, that was too far for it to be like, for the Earth's not flat, so that was too far of a distance, right? You would have missed if the Earth was curved, so therefore the light must have bent. So people hitting their targets are getting told that the light refracted. It hit the target because the light changed direction and just happened to follow the curve of the Earth perfectly.
Well, but the intensity of the laser that you are pointing and the direction that you're going to point it in is going to definitely affect your results. And if you are to use it, I mean, if you're to use another instrument in conjunction with the laser light in order to, make it more reliable.
You're assuming it's not
providing more accurate.
You're assuming the methodology is flawed, but you don't know anything about it.
I mean, I was speaking like pointing a laser through a medium of water to see the refractive intensity.
Yeah, no one is pointing lasers into water to. That's not what we're doing here. follow along.
But why not? I mean, below the 8 inches above the surface of the Earth,
we're not doing that because the law of refraction is well studied. We're not trying to relearn what refraction is and how Snell's law works. We understand that. You do not.
No, I think the question was about the medium of the air around the surface of the Earth, right? So the surface of the Earth, if you point the laser over a surface that is inadvertently heated continuously by a heat source such as the sun, then it is going to form vapors, and that vapors are going to form the movement of the laser pointed at it in the way that it reveals refraction.
Yeah, no, it's based on the optical density of the medium, and we can measure that. Dumbass.
I mean, since we're using lasers as our instrument and not just measuring it with the eye,
I started
we
by
have
telling
moved
you about
way ahead
cameras,
into the modern
by the way.
age.
Yeah, I started by telling you about cameras, by the way, because it's easier and we have thousands of examples. All world record long-distance photographs were taken in infrared. We have hundreds of laser tests, yes, and we have tests over frozen lakes, we have tests all over the place. And many of those tests, we have measurements of the humidity, the temperature. We have, for instance, FE Core, a bunch of engineers came together, created a leveling device, and then leveled the laser across the lake by shooting it across the lake, hitting different targets. We have done this from so many different angles, and there's no ad hoc excuse or I imagine the air is curved, therefore the laser would bend down. That's retarded. You haven't proven the air is curved. You haven't proven the Earth is curved. You didn't even prove the laser light bent.
I mean, nobody ever mentions
assumptions.
Right. Nobody ever mentions scattering, and absorption and scattering and reflection. It's all just like refraction.
Yeah, because I initially mentioned refraction because that was so easily visible with the eye. Scattering would require me to observe it in a different sphere, like as suggested by Drace in the room with the prism.
The problem
or
is you're not actually observing any refraction. You're assuming refraction because you see too far. That is not observing refraction. That is assuming it.
Right. So are you suggesting that people don't look up into the sky?
Say that again.
I'm not saying, I'm asking you. Are you suggesting that people don't look up into the sky?
No. Are you suggesting that you're retarded?
The reason that I came to that conclusion upon your suggestion was that you're saying that if you look up too far ahead into the sky, you're going to form a defect in your eye related to the refractive.
No, I never said that. You are hallucinating, sir. Go take your meds. We have this all recorded. So I don't know who you think you're fooling, but you're not fooling anyone here. At best, you're fooling yourself. And at that point, I just have to say, you sound really dumb.
It takes so long to respond.
I'll just take a
like
break.
It's an AI or something.
Yeah, AI is
even
far more
if I'm an
intelligent than this
AI,
guy.
I'm a bit of a
I
traditional
have
guy.
not talked to an AI model that is as dumb as him, so yeah, I don't think it's possible that he's an LLM. I mean, I don't think any LLM would tell us that air moving around a tree proves the Earth is curved. But that's what we got from this guy.
Yeah, it doesn't make sense, but at least it's something new. Right?
Yeah, it was hilarious, but I mean, come on. Who does he think he's fool? Like, he honestly thinks we're so dumb that we don't see through his stupid stuff, or he's actually so stupid he believes it.
I think maybe he's just going out on a limb.
Watch out for that wind on that limb.
He's branching out, you know?
Hey, T-Dub, would that be the heretic, what's it called? The heretic...
Heretic's razor?
Yeah, that's it. It's heretic's razor.
Is he going to resort to ridiculous claims because there's just no possible way he could be dumber than a flat earther?
I was listening to your new music before, Drace. It's like come a really long way, man. That was really good.
Yeah, it's going well.
Is that with the same program, or it sounds a lot more real?
Yeah, basically they've been updating the models, and the latest one is really good.
Like almost indiscernible. Almost.
Yeah, at times it's indiscernible. At other times you're like, hey, I got you.
Yeah. Yeah, you can hear it. Yeah. And the lyrics are awesome.
Tell you what, AI is better at reproducing music, right? Simulating music than it is imagery. There's just something about AI imagery that, like, when it attempts to make it look real,
like videos,
Yeah, there's something about it. It's creepy.
Yeah, it's crackly or something. It's
I know
like fluffy or something. Yeah.
One of the things that you can use to identify it, it's very subtle, and it's one of the things that's wrong with almost all image models and video models is that they don't follow perspective laws, and so they're completely globers. It's just all over the place. Like, the perspective lines don't actually reach a vanishing point.
Yeah, I noticed that. Like, I was watching this one, and like it was two people walking along talking to each other, and they've both got their heads turned in each other's direction, but it doesn't look like they're looking at each other. Looks like one's like looking past the other. They're both looking past each other. But it just didn't look right. And there's just something about it too. It's just like, I think they're getting better at it, but it's just this. I don't know. It's creepy. Like, it's almost like, I don't know, demonic. I don't know. It's weird. I can't describe it.
Like I can't watch it. As soon as I see it, I go, I have to flick off it.
I
don't even care what it's about.
I love finding the little issues. Like the more you know about different aspects, the more easier it is to spot the issues in the new generations. Like there was this one generation which was showing behind the scenes Marvel, and if you know anything about like cameras or how the green screens and these things are set up, you can notice the small issues, like the knobs are not right, the different mechanisms just aren't right, and if you zoom in, you can oftentimes see faces in the background which are just demonic.
Have you seen that Flat Earth one where he goes up in a balloon? He goes through the fucking sky into the water. You haven't seen it?
Is that an AI one?
It's an AI.
I remember they made one like that for when they were doing a documentary about Auguste Picard, I think it was called.
Oh, there was a whiskey ad that did it too. It was a whiskey or something. Yeah.
Wasn't it like a guy and his dog whenever they went through the...
Yeah, is that in a hot air balloon or something?
Yeah, it was with his dog. I think I've seen that.
Yeah, like a capsule or something.
Yeah.
No, yeah, this is another one, Drace. Like a recent one. And it's when they get better and they start making, videos that you can't tell the difference. That's it. It's all over.
Mr. Kumar is letting his feelings be heard in text.
Oh, you got a sore vagina, mate.
Tell us your feelings. It's okay.
Who else is in here?
Yeah, Mrs. showed me one where a rat runs through a kitchen and dives into the hot oil vat, right? and the guy working there, like, it's like I reckon it's AI because he's grabbed this, like, the bin that's got the chips in it, and he's rattling it like he's like wrestling it.
He's hooking it.
He didn't even go for the rat or anything. He's like just had this reaction that was like he was hallucinating or something, like. And I'm thinking that's AI. It's because it hasn't got the human reaction down pat or something. Like
maybe it's real, and then they add the rat in as well. Like, so they got to try and act in the right order as well. You know what I mean?
Maybe, yeah.
Because there's some like that, but the full AI ones, like, you seen the ad with the guy doing Tai Chi? He goes, I'm 50 years old, and I don't do any weights. I just do Tai Chi. And it's this, like, Asian guy with long grey hair. He's got this ripped body, and it's just, everything just sounds metallic,
It looks like India's profile picture.
Yeah. Without the beard.
Right.
Looks like a buff version of that Asian cosmologist or whatever. You know the one.
Oh, Michio Kaku.
Yeah, he looks like buff Michio Kaku. I do Tai Chi. I don't even lift any weights. It's now I've told you about it, you'll start seeing it. Maybe it's on Facebook or something.
Yeah.
And the reels.
I'll probably end up seeing.
All right, Lukey Coolhand. Are you there?
Yeah, man.
G'day.
Good day.
Oh, yeah.
Didn't catch that.
How are you?
I don't know what you're saying. I can't hear you, man.
He said, "How are you?"
Oh, I'm good, man. How are you?
I'm just looking at your profile. You look like you are a flat earther.
Yeah, man. Yeah, I was over in 24/7 wondering where everyone was at. Keep seeing this posted over there.
Oh, okay. Cool. How long you been a member?
I don't know, dude. Honestly, I don't know, 2 or 3 years or something. Maybe more, maybe less. Something like that.
Okay. Did you have a different name?
I used to go under Welshie, but I kind of jumped between Lukey and Welshie, so I don't really talk to too many people over. I like kind of lark over there, so I'm actually surprised anyone even spoke to me over here.
Well, I just kind of picked you out because I didn't recognise you.
Yeah,
I've been away. I've been away for a few months, so wouldn't be surprising that I wouldn't, recognise any new people or anything like that. But
you're not the dude that used to go over T Woozle, are you?
No, he's in here too, though. He's next to me, T-Dub. Todd wasn't. Todd wasn't.
Yeah. I think I used to talk to him like when I first joined, and he was a cool dude.
Was he still in?
Hey, how's it going? Yeah. Did I check you in or something? Probably checked you in the VC or something.
Yeah, we talked like 2 or 3 times. I think maybe he might have got me enrolled in Flat Earth. But yeah, man, it's been a few years.
T-Dub the recruiter.
Yeah.
Oh, welcome. Chime in whenever you want. Any questions?
Yeah, I'm just gonna chill out, listen a little bit. Thanks for welcoming me. Appreciate it.
No worries. Grumman. Are you there? Lunar Module 5. Grumman.
He's got the Omni tag. Look out.
Well, what's Omni? Oh, is that Omnivore?
Yeah, he's probably from Omnivore server, yeah.
That's all right, mate. If you don't know how to push the button, that's fine. We can teach you. Oh, he's been in here for a while. He's gone. Oh, no. He's been sitting there for a few hours, yeah? Dibs, are you there?
Yeah, I'm always here.
How you going? I don't think we've met before.
Yeah, I've seen you in here a couple times.
When did you join?
Like a year ago.
Okay, on the main server?
Yeah, but I haven't been active. I've been active last couple months.
Okay, cool. Nice to meet you, man.
Yeah, nice to meet you. Is that your kangaroo in your profile picture?
No, he's a famous kangaroo, actually. I'm trying to remember his name. Big boy. I think he died of a heart attack or something. It was this massive thing. It was like 7 foot tall, something like that.
He does look massive. It's like he looks like he's been bench pressing.
Yeah. Everyone's saying he looks like a camel.
Yeah, he does. Buff camel.
But they do that. That's him crouching over. So when they stand up on their tails, that one there is like 7 foot tall.
So you're from Australia?
Yeah, Melbourne. Down the bottom.
You ever have kangaroo meat?
Yeah, man. Yep.
How is it?
So it's very lean. So you either have to slice it thin and just either side, or stew it. So slow cook it, and then it goes all nice and tender.
Is it like similar to like bison meat? What? Buffalo?
I never had bison, but if really gamey, maybe like a mix between beef and goat without the fat. Have you ever goat?
Oh yeah, yeah, goats.
So what? The Aboriginals just had really good teeth, did they?
No, what they used to do was they dig a hole. They put coals in a hole, and they dig like a 6 foot deep hole, and then they put some coals at the bottom, and they put the kangaroo in upright with its head sticking out, and then it would slowly cook through the body over like 24 hours, and then when the smoke started coming out through the mouth, they knew the kangaroo was ready, and then they'd pull it out, rip the skin off.
Really?
And all the meat was yeah. So they only eat maybe one type of kangaroo. I think it's greys.
Right. What was it, like a honey?
Yeah, exactly, but deeper.
With the head sticking out.
Yeah, with the head sticking out. Yeah.
Holy shit! I didn't know.
And then when all the smoke started coming out, so they'd bury it back in the dirt. And then when the smoke started coming out through the mouth and the ears and stuff like that, then they knew it was cooked. We had it.
They basically slow cooked it.
Yeah, I had it in the desert in New South Wales. I went to Lake Mungo National Park.
No, I don't think so. I don't think I've been that one.
Like directly north of Swan Hill, like up through there. We had some up there.
Right. Nice. Huh.
There's no lake there. Like it's an Australian lake. Sand.
Yeah, desert. Yeah.
Yeah. It used to be a lake, apparently. Oh yeah.
Timba, is it true that you guys don't have Heinz ketchup down there in Australia?
Of course we have Heinz. That's the only one I buy.
Yeah, dude. I talk to people that like used to travel and visit Australia, and they said Heinz isn't available. It's like ketchup.
Heinz is the best ketchup going around.
Hands down.
Even the mustard's good.
Yeah, I think we got like 1, 2, 3, 4, 5, 5. I got 5 bottles of Heinz ketchup. Well, it's a mixture of ketchup and their barbecue sauce.
Yeah, it's the only one to get. It's not as sweet, All right. Who else we got here? Kingsley. I know Kingsley.
What's up?
How are you, man? Johnny Law. Hello.
Howdy doody.
How are you, man?
Yeah, I haven't heard you in a while, man. Where you been?
I took a few months off.
Right on. Good for you.
Yep. Draws me back.
It's good.
Always draws me back.
It always does.
Yeah. Sometimes
it's good.
Sometimes you get a little bit sick of the conversation, and then you have a break, and then you go, "Nah, I want more."
Yep, I hear you on that.
I think I was getting a bit sick of the politics server, maybe.
Yeah, it's been a nice change to, when we flip-flop, go from here to there and back to the home server. You get a different variety of people on each server, so.
Yeah. I think maybe the guys from politics. There's a lot more traffic that goes through politics, but I think the people there are, I don't know, pretty arrogant.
Yeah, I think you get more honest questions or honest conversations here somewhat from, versus politics.
Yeah. KC, I recognise KC. Sorry, mate. What were you going to say, Johnny?
Oh, I was just going to say good to hear you and hope to see you around.
Thanks, man. You too. We go. Hello.
What's up, mate?
How are ya?
It's good, you?
Yeah, good to see you, man. Hope all is well.
It's been a while.
Yeah.
How are you doing?
Yeah, good, man. I've still been, I've been around. I've been listening on YouTube, so I feel like I've still been kind of involved in the conversation. I did miss a lot, though. Apparently, I heard. Miggy was getting me up to speed on a few issues, if you know what I mean.
Yeah. Dramas and that.
Yeah.
We needed some.
It was pretty funny, man, when I heard about it. I was like, what?
Yep.
Yeah. And then they're having dramas between themselves, right.
Today it was like a big one.
Yeah. Well, hope it all works out for them.
Yeah, we're still looking for that curvature. So
good luck with that. Keep on asking the question, it's not there. Does anyone know anything about what happened with there was like a YouTube video that I saw that had that doctor, it's like an Indian guy, maybe an American, not American Indian, but Indian American. What's that?
I think his name was Dr. Shiva.
Yeah, Dr. Shiva, because I remember him from during the C word, right? During those times. Those ones. And he was quite good to listen to during that time, And then when I heard him talking about flat Earth, I go, you don't know what the fuck you're talking about. He was talking about experiments because he's a doctor, you know. The experiment, the experiment is you look in the sky. Like, what the fuck? What's this guy on? Does anyone have that video or know what channel it was on?
I watch on his channel actually, some of it.
Dr. Shiva's channel?
Yeah, Dr. Shiva Ayudi or something like that. If you put Dr. Shiva, it will come once.
Yeah.
Are you talking about the one where he was with Flat Earth Dave?
No, after that.
No. Yeah.
He's doing things like that, and he has all these globers around him, and he wants to make an experiment. Why the flat earthers are not coming, and I don't know, drama.
They kept talking about the scientific method.
Yeah.
And all that bullshit.
It wasn't even there. They weren't even using it.
And actually, when he explained to Dave, because he asked, "Do you know what is the scientific method?" and Dave said, "Duh, tell me." So he tried to explain, and he was wrong. So he's like, and in one of his videos, he said, "Oh, they don't even know what is a scientific method." And I left a comment. I said, "You couldn't explain it. Now you are putting on Dave."
What's he a doctor of? He's a medical doctor, isn't he?
I think engineer or something like that.
He was like calling out the COVID vaccine bullshit.
Yeah. Yeah.
Yeah,
That was his generational run.
Apparently, he created the emails and things like that, and blah blah blah.
And like he was getting angry too. Okay, now they've given you a perfect example of what you can do to finally tell if the Earth is curved. Here it is. Radio waves. I went, what? What the fuck? Is this guy serious? From a radio waves from a lighthouse. That was it. Angles to the sun. Okay, and the guy's going, what's the experiment? And he goes, you look at the sun.
That's called sun gazing.
You know what? You guys get yourself a tub. Get yourself a circular tub and put a lot of water in it, and you'll find
have a bath.
No, just point a laser in it, and then you'll find the answer to the curvature of the Earth in there.
What can you explain? Can you please explain that for me? Go ahead.
You fill the tub with water, you get in the tub, and then you take a toaster and you drop it in the tub with you.
No. You stay outside of the tub. You don't have to get inside of the tornado, do you?
Okay, go explain it. Step by step. Go ahead. Explain now.
Nothing, just get a tub and point a laser in it, and before you point the laser in it, be sure that you have added enough water to see the reflection or the effect of refraction in it.
Okay, so the laser goes through air, and then through the glass, and then through water. Yeah, that's refraction. Yeah.
Be sure that the tub is a circular one and not a flat one or a rectangular one.
Yeah, but what are you gaining from that? Are you proving that there is refraction?
No, the reference point is different. I mean,
the reference point of
tank. What? If you would use a tank to do the experiment, it would produce a different result than a spherical one, given that there is moving water in it. I mean, because there is a spherical, I suggested a spherical tub, you can actually move the water using your hand or a spoon or a ladle in a circular fashion to create the effect of a circular moving wind system, and then you can point the laser to see how the refraction affects the interaction.
Have you done this?
Yes, I have. Using a glass.
And what did you? And what did you? What was your outcome?
It helped me understand. Somebody said about hallucination and drinks and such. So it helped me understand that hallucination can only be produced by the interaction of refraction thereof.
What? That was your outcome. What were you trying to prove? That
No, I wasn't trying to prove anything. The proof was already out there. I was just trying to understand it.
sorry, mate. I don't know what you're talking about. You're being very vague and scattery and indirect. I don't know what you're saying.
What's shining the laser into the water going to do?
Scattering. It's gonna show you dispersion, scattering, and refraction together. If you move the water inside to create some
we
of
know about
turbulence
that.
in it.
Everyone knows about that. Light.
Did you notice how the water in the tub is level?
I mean, there is a level, but you create the turbulence thereby by moving the water in a circular fashion in order to understand how winds might be moving to turbulence in the air as well. Just to feel the weight of it.
Feel the weight of the water like the winds?
It's like doing a cryptic crossword. Can never finish them. I think I've ever finished one cryptic crossword. That's what this guy reminds me of.
Tell me more what I remind you of.
You ever done a cryptic crossword?
Yeah.
They give you these really weird clues. And then when you get the answer, you go, oh my God. That's so weird. So do you believe the Earth is a sphere? Sound like you do.
I mean, there's actually more proof that I see around me for it to be a sphere than it to be otherwise.
What? Can you start with your best? What? Yeah, give us your best one first. Put your best foot forward first. You must be really excited about it, judging by the reaction. Hello.
I'm there. Hello. Yes.
Yeah. So give us your best proof or evidence first. Go ahead.
Of what? I'm sorry, I didn't quite catch on
You
what
just said
evidence.
the evidence the evidence mostly shows you that the Earth is a sphere. Yeah?
Right, yes.
Oh my God, I can't talk to this guy. It's like fucking talking to a toddler and them telling you that they
literally been
didn't
asking
put
him
the
to try
fucking
to
sand
supply
on the
us with
ground.
this evidence or this proof for a while now, and he has not been able to present anything other than incoherent leaps of logic.
Fucking hell, I'm like pulling teeth.
Okay.
Bring your best evidence of your globe belief, or you don't have anything.
Yeah. Nada.
Okay. I'll be back. In
I'll be back.
sometime. I'll work up something in the middle. The proof needs some time to
We'll be here looking forward to it.
develop.
Go take a bath in the tub. Let us know what you find.
With a toaster. I mean a laser. Sorry.
A laser.
Some weird characters.
Okay.
Oh. Still here. I thought you were going.
It's always the way, isn't it? You ask for proof and they'll go. What's it?
Yeah. Ain't got any proof? Oh, I gotta go. I'll be back.
You got any proof? Well, the sky envelope and the wind moving around the trees, you know.
Yeah, it creates turbulence, and light bends around turbulence, therefore creating a globe.
Yeah, that's how that works.
Can you prove me wrong?
Sky and wind, turbulence.
Who's that? Where is he? That is Jesus Christ. How are you, mate?
Good, you?
Good.
Hey,
how long
hey, bro, when are you coming back?
I don't know.
Sorry.
Yeah, I keep on hearing about it, but
Yeah, the world kind of
I'm
needs you
waiting.
right now.
Sure does.
Why do they think they're on a globe?
No, because it's full of debauchery. That's the problem. But that too. But I don't think that's the worst thing about it.
Yeah, they're lost.
Yeah.
Lost in space.
Very, very lost. I'm driving through Fitzroy. I'm just looking around. Everyone's got nose piercings everywhere, and they're all wearing gothic outfits. People drinking on the street.
Yeah.
3 o'clock in the afternoon. You know, like druggies walking around. I think Jesus needs to stop in Fitzroy first. Oh, but we're all going to see him at once, aren't we?
Imagine people screaming out, "Is that Jesus coming over the curve of the earth? I can see him rising up over the horizon."
Yeah. But wait a minute, we were all supposed to see him at once. How are the people on the other side of the earth seeing him?
Well, they're not counting Australia. Like, who cares? Like, you know how the sun can be, you know, like they've got the sun for, was it 99% of the population?
Yeah.
For once a year, one time. Yeah, it's going to be like that. Screw Australia. Who cares? They don't count. We don't count. But
You guys always don't get it. Jesus is going to cause super refraction around the world, so you'll be able to see China.
You've got a refractive rate of 1.
We'll be able to see vagina? What?
Oh, fucking hell.
It's going to be like look, you know, like a GoPro lens 360.
The halo. When did you join? I feel weird calling you Jesus Christ. I'm going to call you. I'm going to call you Jesus. All right?
Let's call him JC.
Yeah, that's what I was going to call him.
But we've already got a JC.
Oh, we do?
Jesus is alright too.
Oh, sorry, Casey. Oh, so I fucked up.
Oh, yeah.
JC, so a couple of years, main server, politics, whereabouts?
That's it. I've been around.
Been around. Alright, cool. In our servers? Any of our servers?
Yeah, I was in politics.
Yeah. Cool, man. Obviously, you're a flat earther.
Yep. That's gonna be funny, like when Jesus is going around the earth.
Well, I'm going to sleep soon. I do have 2 extra songs that you guys haven't heard yet.
Go for it, man.
They say a shadow in the city and a well with none at noon is all you need to measure Earth. A perfect little proof. But every step is built on something hiding in the back. A quiet set of premises that no one ever tracks. Parallel rays from a sun unmeasured, 2 towns drawn on a perfect line. Distances guessed, not truly captured, but the story's told like it's divine. Shadows and assumptions stacked beneath the claim. Inference on inference, treated as the same. Only what's observed is solid on the page, but the leap from sight to certainty is where the errors reign. Shadows and assumptions, that's the hidden cage. The angles there you can measure it. The data isn't wrong. The data isn't destiny. The chain can still go wrong. Multiple models fit the scene, yet only one's declared. The underdetermination's there, but it goes unrepaired. Local sun or distant giant, curved or flat, the math can bend. If the premises stay silent, you choose the answer at the end. Shadows and assumptions stacked beneath the claim. Inference on inference, treated as the same. Only what's observed is solid on the page, but the leap from sight to certainty is where the errors reign. Shadows and assumptions, that's the hidden cage. Appearance is an ontology, a lesson easy to forget. Logic needs transparency, not stories we present. Shadows and assumptions, listen to the signs. Test the hidden premises, follow every line. Truth is never threatened when we question every stage. It's reasoning that strengthens when we learn to turn the page. Shadows and assumptions, step outside the cage.
I love that one. As you might guess, that's Shadows and Assumptions. And because I'm just about to go to sleep, I'm going to play one more and then I'm going to go to sleep. That's called Empirical Eye.
To the scholars on the globe side, I'm addressing you direct, not to challenge your conclusions, but to tighten the respect. In the field of observation, every model must align, not with faith in old assumptions, but the data we can find. This is not about conversion, not a battle to be won, but a method of inquiry grounded in what light has done. Before we set up any late test, let the evidence decide. Walk with me through optics, let the wavelengths be our guide. Before you trust a model, take a moment, take a view. Let the cameras and the spectra tell you what the air can do. Infrared against the visible, two paths through the same sky. Show the bending and divergence, no equation can deny. Look at all the world-read images the internet has stored. Analyze the color drift before any test is scored. This is not about believing what another voice implies. This is just a simple call to open up your empirical eye. Every long-distance photo, every skyline, every shore carries signatures of optics you might not have seen before. When the air is shifting density, when the ducts and layers rise, white light isn't uniform, it fractures subtle in disguise. Infrared may mark a boundary, visible may reach beyond, but the difference in their horizon shows the medium they respond. If a distance breaks the limits of the geometric sphere, check the wavelength separation, see what physics makes appear. Before you trust a model, take a moment, take a view. Let the cameras and the spectra tell you what the air can do. infrared against the visible. To pass through the same sky, show the bending and divergence. No equation can deny. Look at all the world-read images the internet has stored. Analyze the color drift before any test is scored. This is not about believing what another voice implies. This is just a simple call to open up your empirical eye. You don't need to change positions, don't need theories in advance. Only treat the data fairly, give the evidence a chance. Study how the lower edges shift their contour with the heat. How the waterline distorts when refractive gradients meet. This isn't globe or flat, it's the discipline of sight. Letting spectra write the narrative in the presence of the light. So before we build the setup, before we measure lake and sky, start with what already's captured, let the photographs reply. I'm not asking you for trust, I'm not asking you to bend, only asking you to question how the wavelengths comprehend. Let the optics speak their language, let the evidence extend. This is just the first foundation.
I also have a bunch of other ones, but those are the ones I just loaded in here. And it's late, so I really have to go to sleep.
Trace, thanks for that.
It's my pleasure. You can find all these songs on the FE radio on our home server, and they will be uploaded on my YouTube soon.
It reminds me of that there's an Icelandic band, starts with C. Kaleo? Maybe it starts with a K. Kaleo or something like that. Do you remember them?
No, we have a lot of Icelandic bands. If they were really famous, maybe, but Kaleo? I don't know. I have no idea what that is.
Right.
Also just be,
Thanks, Trace.
The pronunciation is different. So like.
Oh yeah, mine's Aussie pronunciation. Yeah, great. I'm sure it's genuine.
Yeah, but have a good one.
All right, who's in the chat? Any newbies? No.
It's me.
Hey! How are you, mate?
Good, how are you?
Good. How'd the move go, man?
Yeah, it's a big job.
Yeah. You sound like you're fucked. No.
I am actually.
Having a breakdown.
Yeah, so like ended up doing 3 trips, but the last trip I did up, I got 2 mates that own businesses. One of them, he owns concrete pumps, and the other one, he owns just a massive group of businesses. So he owns 2 supermarkets, a shopping centre. He owns, I don't know, chicken shops, roast shops, cafes. We've got 2 coffee shops. We've got burger shops. We've got restaurants and a heap of commercial property as well. So he had a facilities management company to look after it, but they've had no manager and everything's just in this huge mess. So the day I arrived in town, that night I got here, I think I got here at about 4 o'clock in the afternoon. At midnight, I was pumping concrete with my mate, helping him out till 9 in the morning. And then I was into the facilities management job at like 9:30 when I finished with him. And it's just been...
no rest, mate.
Nah, this other facilities job, and it's not just facilities, man. That's a heap of shit. Like managing construction projects, all sorts of different stuff. I've been doing like 14, 15 hours a day, nearly every day, and working weekends as well. So I've just...
Where'd you move to? Townsville, yeah?
Yeah, mate, yeah.
Yeah. Move up there for a holiday and end up working harder.
Yeah, I have. I wasn't going to work at all, but...
I was in Cairns 2 weeks ago. Went on a fishing trip.
I was in Cairns about 3 weeks ago, actually, because I did a fit out on a new store for a place called Get a Better Burger. So...
Oh, yeah? Okay.
They're over at the DFO outlets there. So, yeah, I went up there and did the defit of it was an old Taco Bell. So we had to pull all their cook line out and then patch all the walls. And... plus a bit of other shit, painting and cleaning, whatever. And then we've just done a store fit in there and put a new production line in, new cook line in, moved a canopy over and new ducting, etc.
Sounds right up my alley, mate.
Hey, you should come here and work with me.
Come and join you. Mate, I love it.
I got an office building 3 stories with 18 tenancies that we just bought. And that basically has to be gutted and start from scratch. So all new mall area, new.
Is that what they call back to basics? Yeah.
Yeah, but we sort of got to do it in stages. I've got to move tenants around because it's tenanted. So there's a few tenants. So I've got to move the tenants off the top floor and the second floor down to the ground floor first, so that I can get the top floors done, and then we'll move those guys back up and do the ground floor. But I've got to remove escalators. I've got to remove lifts. I'm not arranging that. I'm removing the lifts. Yeah. We've got an old air conditioning chilled water system from like the late 60s. So
up on the roof.
Yeah, you got the water up on the roof. So that's got to be, but the chiller's down in the basement, and then there's air handlers on each level. These air handlers are the size of a bloody car. So we've got to remove all the walls around these air handlers, get all this shut down, get a package unit in there, and then I've got to rip out all this, all these air handlers, the chilled water on the ground floor. I've got to do the cooling tower on the roof, so that'll come out. I'll do that at the same time as when I remove the lift motor off the top, because the new lifts don't have
motors. Big job, man.
Man, it's huge. Unbelievable. Amongst all the other crap that I've got going on every day, to keep these other stores running. I get like 10 fridges a day broken, lights, ice machines, ovens, you name it. It's just all day, just jobs coming in. It's crazy.
You know what we've been doing recently is quoting to do normal drains underneath. And then adding in a quote for just pumps with no drains underneath. So you can keep all the plumbing on one floor. Sorry, excuse me. Otherwise, you've got to go into the tenancies below. And you've got to do night works and shit like that. So we just quote pumps as well. And then a lot of the time they just go, oh, okay, pumps, do macerators and stuff like that. But most of the time it's only running kitchens, yeah? Kitchen sinks, things like that. Maybe a kitchenette in these offices. Of course, the bathroom plumbing's not going to be on pumps, but that would be a disaster.
Yeah, they got one bathroom on the ground floor, and then they got 2 on the top floor. But the top floor one will be commissioned anyway, because that's going to be one.
But they're mostly
office. Yeah,
they're mostly next to the lift. The lift and the stairwells anyway,
yeah? Sort of. Close, not really. This building's a bit, I don't know, man, it's weird. So they've got all their sumps are above the ceiling and the downpipes run through the building. And there's these big concrete beams on each floor, so the downpipes kink around these beams. And
lowers the ceiling height too, yeah.
No.
It's not too bad. You got plenty of height.
The problem is they don't have big enough droppers in there. So yes, you should probably lower the ceiling height. But this whole building's just weird. Like it's not built well. So no, the toilets, one set are very close to a set of fire stairs.
Yeah.
But the plumbing's not through the fire stairs. They've got all the plumbing for all the toilets, the showers, the sinks in all of the tenancies and the kitchenettes. Everything's core drilled through the slabs, including the downpipes. They're internal. They core drill the slab. They kink them around all the beams. So, and we've got massive issues because the box gutters aren't big enough. They are absolutely, whoever did this did a horrible job. They're tiny box gutters. The sumps are only about 15 centimetres deep. And the only overflow that they do have off one end of the building is higher than the roof line. So we keep getting water back in through that top floor underneath the roof sheets. So
coming back over the back of the box gutter.
Yeah, and then also yesterday, one of those downpipes, whoever put them in, they didn't seal around the back. They're up against the brick wall or the concrete wall.
Yeah.
So the back's not sealed. So yesterday we had so much rain and I was in there, and all these downpipes are next to, one of the downpipes is next to all the electrical distribution boards. So I get there, there's no power. I open up the electrical distribution board and I have like a waterfall come gushing out of the board at me. And then that shut down all the BMS system. And then, I had to try and turn on wet switchboards and deal with the BMS and then pull these downpipes out of it. So I just smashed all the ceilings, all the walls, pulled all these downpipes out in each section, resealed all the backs. Yesterday was a mission. And then I fell out of the ceiling. So I was up there doing shit.
I heard you say that. I was doing the lawns and I heard you say something like that. But there's all new regs on box gutters. So I think you can get it. You're in Queensland now. QBA on the website. I think they have to be 300 millimetres wide and 200 millimetres deep. And then the sump's got to be 300 millimetres wide and 600 millimetres long. And then it needs two overflows. So it might be different. It might be even bigger in Queensland because you guys get more rain.
Well,
you guys get more storms.
It also depends on the roof size, yeah. And then next to us, we've got another high-rise building that's about 20 fucking stories. So the water that's going to run off the side of that building is probably, there's going to be more from that than probably our roof, yeah?
It's linked. It's joined together.
Yeah, mate, yeah.
Oh, yeah. Oh, okay. Oh. And that wall goes straight into the boxy as well?
Yeah.
Or there's like a capping?
No, there's a gutter at the top. It's like so it hits the top gutter first, and then it's got a downpipe at the end that flows it into the box gutter. But then the box gutter's only got a fucking 50 mil downpipe on it anyway.
So it's got nowhere to go.
No.
Fucking hell.
Hang on a second, I just got to look at something quickly. So.
No, you're all right, man. All right, we have Bebes. Hey, Bebes. Do you have Bebes? Are you flat or globe? Hello.
He was neither flat or globe. He was a runner.
It's just dibs again.
We have Bay. Bay, welcome to the channel. Bay. No one wants to talk to me, AJ. That's good, man. At least plenty to do.
Yeah, I got plenty on, man.
Guys, Townsville from Cairns.
4 hours.
Still a fair way, yeah? Was it 4 hours?
Yeah.
North. Oh,
south.
Cairns is north. Yeah. Cairns is north of Townsville, right? Yeah.
Correct, yeah.
Yeah. It was so beautiful up there, man. It's the first time I've been up there. Before that, the furthest I'd been up was Noosa. And I absolutely loved it. I was just looking back into the mountains.
Yeah.
Just going, I'd fucking drive up there and, get another rooftop tent so I can stay away from the crocodiles. But
did you go up and do the tablelands and up in the rainforest there?
Nah, we were only there for the weekend. So we went on a fishing charter out to the reef. I caught a pretty big GT. So we took it back to the restaurant and we got coral trout, giant trevally. And we took it back to the restaurant and they cut it up and made all these different dishes for us. It was awesome.
Yeah, nice.
That GT, they made sashimi out of the GT. It was so good, man. Oof.
Yeah.
I caught that day and then on the Saturday and then we ate it on the Sunday. And with the coral trout, they made a Thai red curry with the coral trout. It was delicious.
Yeah, I love the kingfish ceviche. If I can, kingfish sashimi, we've got to do a ceviche with it.
Yeah. Yeah, I didn't get any kings. But fuck, it was good, man. So good. What's that?
Oh, my son, I'll send a photo.
You got Crocs in Townsville, yeah?
Oh, yeah.
Yeah.
That's all right, man. It doesn't bother you. It's not drama.
Yeah, you can go swim in the ocean as long as there's no rivers around, right?
Yeah, they do patrol the ocean sometimes. There's one that patrols up and down a beach here called Kangala. I probably wouldn't send my dog in to swim there, but like if you just be washing off or doing some fishing or...
But Townsville's on a river?
Man. Hey, yeah, we got Ross River and Ross River goes into Ross Creek. And then we've got heaps of creeks around us, like tons.
Yeah, mangroves and stuff, yeah?
Yeah, heaps of mangroves.
Yeah, I wouldn't be going anywhere near that fucking thing.
Yeah, it's my son. He caught that. Oh, he's caught about 4 of these actually, over 80 centimetres. Big barra.
Oh, in the river?
That's in the salt, but it's just below the fresh. Like it's the first section of salt before it off one of the weirs.
Hey, did you see that kid that got bit on the stomach the other day? Did you see that? They were fishing up near Cairns in the river, but they were fucking waist deep in one of the rivers, fishing for barra. And he goes, oh, there's a croc right in front of me. And it was a 1.5 metre or something. It jumped up and nipped his stomach. What the hell are they doing standing waist deep in the fucking river fishing? But they were laughing and everything. I was like, what the hell? Crazy, mate.
Yeah, that's
because you can't see through the water. All murky and stuff.
That's what I mean. Like if you're just fishing, doing normal shit, you don't go swimming in there, obviously. Like you don't go wading around in waist deep water to get your crab pots. You just make sure you sort of stay in the boat. You're pretty safe, yeah.
Yeah. Fish, go cast at the bank and then step back from the bank and fish, 5 metres away from the edge.
Yeah.
Be fine. But just got to have your wits about you. Keep your dog tied up.
Yeah, I mean, I've lived here my whole life and I've seen a lot of crocs, but I've never really had an issue as such.
Yeah, see, I would probably be extra careful because, I'm not used to it. So I'd be like, I'm not going near that water.
And tiger sharks and bull sharks, bull
sharks.
He caught 6 of these that night.
Oh, what? In the river? In the estuary?
No, that's on the ocean. That's
Yeah.
So that one there was down at Kungalla where that croc hangs out. But
Yeah.
and then he caught about 6 around the same size that night.
Did you buy a boat?
No, I haven't yet. I've fucking working.
Stop working, mate. Go and enjoy yourself.
Oh, I got to sort this shit out for me, mate. It's a mess.
So I was after I came back, I started looking at like tracks up there. It's fucking so good, man. Like I could just leg it from here up to Goldie. It would take me 25 hours to Gold Coast, but after that, I'd just go, I'd do it for like a month and then just cruise up the coast from Gold Coast all the way up to Cooktown or something like that, Maybe
you can
adventure
do the
a little bit.
off Cairns because the crab track's pretty popular. You can't do it in the wet. You'll get fucked up in the wet. But
I'd probably go in the winter anyway. Like, otherwise it's too fucking hot for me.
Then you can do the old Tally track up to the tip. You can get out across to Cooktown and all these other places. Like, it's pretty cool.
Yeah, and I'd just go by myself. I mean,
if
I want any wind.
Any wind on an adventure.
Yeah, for sure, mate. Don't want any whinging kids or whinging wives. Wives. Now I'm a Muslim. And it just looked like when I was landing, like 500 meters, a kilometer back from the beach, there's just 4-wheel drive tracks everywhere.
Yeah, you can full drive on all the beaches. Most of them you can just drive straight down onto the beach if you're a little bit out of town.
Just cruise along the beach?
Yeah, yep. Well, that's where he caught that shark. It's about a probably 15-minute drive along the beach, so you just cruise.
Ah, you were surf fishing.
Yeah, so it's just out at... it's about 15 minutes.
I'll have a look at a map. What was it? Kungalla?
Yeah, Kungalla. It's just off town. So it's about 15 minutes, and there's like a little fishing village there. So you can drive out past the boat ramp and you just drive down onto the beach, and then you can drive all the way back up to the mouth of the, what's the creek? Salmon Creek, it's called.
Yeah. Get some nutrients coming out of there. All the fish feeding.
All the sandflies.
Did you keep the 79 or the Dodge? Which one did you keep?
I got the 79.
Both. Yeah.
No, I sold the Dodge. Too many issues, man.
Yeah. That's what I keep hearing.
Well, they're not even really a Dodge anymore. They're just a Ram. Ram's its own brand now. It's not Dodge Ram anymore.
Oh, really?
Yeah. But they still use all the Jeep parts in them, yeah? Like my wife's got the Jeep Trackhawk, and it's got the same stereo head unit, all the controls, everything's the same as what was in my Ram.
What? Got that 6-litre thing?
Hers is 6.7 supercharged.
Yeah.
But, Hellcat engine in it, whatever that is.
Off its head.
Yeah, she won't drive a normal car after owning that thing.
Nah, mate. How can you go, I'll get a hybrid? Give me a bigger one. I want an 8-litre now.
Yeah.
6.2s in the Hellcats.
Yeah, so it must be the 6.2. Oh, no, it's 700.
Hemi, yeah?
Or something.
Hemi,
yeah.
Hemi motor.
Yeah. That's her number plate, 707 Hawk. And she wants to race everyone.
You wouldn't even need to try. As soon as you put your foot down, it goes. Go. That's it.
doesn't it make like a whining sound? It's not a supercharger.
Yeah, whine, but you can hear the exhaust, but in the car, yeah, you hear the whine as well, pretty loud. I don't know. I don't really drive it. I stay away from it. I'll have 0 license if I.
Yeah, I was going to say
every day.
Is there speed cameras in Australia?
Fucking at every corner.
Oh man, that sucks.
And we have mobile phone cameras over the road so that they can take a photo of your lap in the car to see if you got your seatbelt or your mobile phone on you. And at our traffic lights, we have speed cameras.
We don't have them yet.
Traffic lights, we get speed cameras and red light cameras. So if you speed up
double whammy.
And that's in Queensland?
That's everywhere.
Oh, that's all over Australia, that is. Yeah.
Damn.
You've got to be so careful. You can't speed.
Has it improved accidents or anything?
No, it's actually the worst you've ever had for road toll.
Yeah, highest immigration from China and India. Yeah.
I think that's Canada.
So the roads got worse. I'm only joking, guys. Take a joke. But yeah, every rule that they can make, they make it.
Oh, yeah.
And add money to it.
Yeah.
Oh, you've got too many lights on your car. There'll be a $247.50 charge.
Oh, your mud flaps aren't long enough. There's $50 odd.
Seriously? Mud flaps?
For a whole inspection.
Freaks.
Oh, yeah.
Going to give you this non-compliance certificate. You've got to take it to Vic Roads. This list.
Yep.
And get everything done. Get roadworthy again. Especially they pick on 4-wheel drives a lot.
Yeah, mine's pretty legal. I've done all right. So
yeah, I kept mine. I got a 2-inch lift and that was it. Okay. I went up to maximum size tyres as well and that's it. I'm not going anymore.
Wait, so you can't
35s, but
you can't lift your vehicles and put bigger tires in Australia?
Yeah, you can, but only 2 inches. So.
Oh my god.
2 inches the legal lift, and then.
Yes.
Have y'all seen the vehicles in America?
It's a combination of tyres, suspension, and body lift. I think you can go a maximum of 2 inches, or 75 mil, something like that.
Yeah, and then 2 tyre sizes bigger.
Yeah,
and that's it. Yeah.
Can you delete diesel trucks out there, or do you have to have those exhausts on them? Yeah,
I've got mine deleted, but if I get caught, it's a huge fine for that one because it's a what do you call it? Emissions fucking bullshit.
Yeah.
Yeah, it collects everything until you get on the freeway. And then as soon as you get up over 100 for 5 minutes, it spits everything out the back. Oh, yeah, it's good. That works for me. It doesn't make any sense. Most of the cars are diesel over here. So. Oh, actually, they're going back to petrol, aren't they?
No, they're going to electric. Fuck.
Get that. Big sales drop off here with electrics.
Good.
Yep.
Can't stand them.
We've got a hybrid. We've got the X-Trail hybrid, the new one. Mrs. car. Fuck grouse. Rocket. But you don't have to plug the thing in. That's the reason we got it. Right?
Yep.
Just that she drives to the city and back every day. Fills up once every 2 weeks. So.
I don't do too bad in the cruiser. It's probably what I do about $200 a week in fuel, so a tank a week.
Yeah, what do you get out? How many k's out of that? Like 800 or something?
About
600
600 around town.
Yeah. Yeah.
Does it seem like there's a lot of flat earthers in Australia?
Nah.
Yeah, not really, man. Everyone's too fucking busy. Stressed out.
Paying traffic fines, speeding tickets.
Rego. Tax.
Worried about
this. Tax on this. Tax on that.
Worried about what's on TV.
No, I spend more time trying to find illegal cigarettes around town because I'm not paying $50 a packet, but they've just put new laws in and they all got shut down again the other day.
Oh, you'll have to come to Melbourne. We've got them everywhere.
And they shut them all down yesterday because the Queensland Premier put new laws in place. And then they just went and did big raids the following day. No.
Yeah. Not my tax-free ciggies. I got a Japanese.
For the cigarettes and pay fucking $50 for the tax.
I got a Japanese dude. He's got the Japanese imports, and what he did was he's got the smoke shop at the front. He's got a kebab place at the back. So when he puts through the smokes, puts it through as a kebab.
Yeah.
I thought that was quite smart.
Yeah. I got a pool guy here. Hang on.
Oh, I'm going into the supermarket anyway. Speak to you later.
Yeah, no worries, man.
You're back. What do you think the Earth is? A globe?
Yeah,
Or
it's
flat?
it's an oblate spheroid. So it's a globe.
What are you doing here?
Do you think that the globe is in a glass cage as well?
No. It's not.
Why not?
I mean, it's not really something that you need in a model. Don't need like glass or anything.
Well, then, if there is a globe and there is air all around us, what is keeping that air from flowing outside of the surface?
Well, it's the same thing that's keeping the air from flowing directly into where an airplane flies. It's lower pressure. Not a zone of...
Which is... That he didn't tell him much.
So like a container or something?
I mean, you would have the air as the container at that point.
Well, that's new. I haven't heard that one.
I mean, you can demonstrate it. The more dense... It's the same reason that if you take propane and put it in, or something like propane, and put it in a glass that's open, it stays there.
It doesn't go anywhere else. All of it stays in the glass?
Yeah. Because it's heavier than the air.
Nice.
So the more air you have, the more weight that you have above, which it's the same reason that there's more pressure at the bottom of a pool compared to the top of a pool. Or the ocean, for example. Hydrostatic pressure. Got nothing to do with the container.
So would it be electrostatic pressure in the air then?
No.
Oh.
It's the same principle as hydrostatic pressure. Because air is a fluid, like water. Basically, the lower you get, the more dense the air is. So, there's more air above pushing down, and that keeps it there. And as you get higher and higher, it gets thinner and thinner and thinner and thinner until it's essentially nothing.
Well, that's less air pushing down. What the heck are you talking about?
As you get higher and higher, there's less and less air pushing down on the air that you're in, so it's thinner. When you're lower to the surface, there's more air above where you are, so it's thicker.
But gas isn't pushing down, it's moving in all directions.
Gas has weight. There's
an equal pressure on any point within a body of fluid. A body of gas. In all directions, at any point, the pressure is equal in all directions.
That's not how the atmosphere works.
Yeah, that's the behavior of gas, right? You can't say that, that's how it works in a vacuum chamber or something, when that's literally still on the Earth, right?
I think he's assuming that gravity
would be the same anywhere, bro. It would be the same anywhere, bro.
I think
weight doesn't just disappear because it's in a box, right? So if it's got weight in the air, it's got weight in a box.
Yes, that's the same reason that propane will stay in a glass even though it is open. Because it is more dense than the air around it. So it is pulled more.
So why can't I just go buy propane in a glass then instead of in a metal propane tank?
Because it will diffuse over time.
It will diffuse anyway.
You need a pressure.
So it's not staying in the cup, is it?
For for all intents and purposes, yes. It takes like a
It
day
eventually
or
does
more.
Does it eventually dissipate?
Over a day or more, yeah.
Right, so it didn't get held down and didn't get prevented from doing what entropy dictates it should do. Right, so nothing holding it down then.
Entropy says it diffuses.
So its weight didn't keep it there then, right?
Again, for more than a day, it was still in that glass.
Yeah. Its weight didn't keep it there, though, did it?
Weight is not the right word to use.
And also, our atmosphere is now filled with propane. I mean, that's just propane. Let's talk about the air around us, like what's holding that in.
You breathe in air, it's not pure oxygen. There's nitrogen,
Yeah, I know.
carbon dioxide. It diffuses into the mixture around you.
Yeah, it diffuses into the mix.
It's irrelevant to buoyancy question.
Yeah, you realize there's a point in the atmosphere where there's only the lightest elements, hydrogen and helium.
Yeah. The tippy top.
And how much atmospheric pressure is there at that altitude?
I don't know exactly which altitude we're discussing, but I would imagine around 2%.
No, by that point, you're like, that's like International Space Station, slightly
So
below there.
177 miles or something.
Not
Isn't it like
really.
400 miles?
International Space Station is 250. Actually, I think it's actually just beyond the Kármán line, not the space station. That point is just beyond the Kármán line, which is 62 miles. And at that point, the air pressure...
Well, 62 miles is way short of where you're saying.
Yeah, I know. That's why I'm correcting myself.
Have you got a reading of this pressure?
Yeah, you can do it yourself as well.
I can go up to 60 miles, can I?
Yeah, if you get a balloon that can take that pressure differential.
So how do you know? How do you know that pressure's that up there?
Because people have sent balloons up there.
What do you recommend I make that balloon out of?
60 miles? Fuck, on, bro. You got a dream. You're dreaming.
What should I fill that balloon with?
Hydrogen. How fast you want it to go up?
Specifications.
You want it to be helium.
Just fill it with dreams.
I think hot helium might get you higher than cold helium, right? But it gets a little dangerous. Hot helium. Ooh.
99.9 repeating 99.9 repeating 7 of the atmosphere's mass lies below the Kármán line. So it's incredibly thin.
Well, the Kármán line is an arbitrary designation that is meant to determine. Correct me if I'm wrong, but this is
an international line.
Yeah. Correct me if I'm wrong, but it's a line where, it's the atmosphere up until here, and then we arbitrarily say that that's not in the atmosphere, even though there is atmospheric pressure a little bit up there.
Yeah, it's so thin that
so there's still atmosphere, right?
Yeah, but for all intents and purposes, there isn't
outside the
because it's so thin.
Right. So, at least you're logically consistent.
For all intents and purposes, by 62 miles, there is no atmosphere.
Did you just learn that?
There is by your own statement 10 seconds ago.
I said for all intents.
Not enough
I
to
said
be
for all intents and purposes.
Not all.
Did you just learn that? Did you just learn that phrase today?
No, I didn't.
Because you've used it like 4 times already.
It's clearly not all intents and purposes if I'm enumerating multiple purposes in which it's not valid. And you're agreeing with me.
I'm agreeing with you that there is atmosphere. It's not
beyond
useful.
the atmosphere. Beyond
It's
the
not
atmosphere.
useful.
Hold on. Let's be very clear. You agree that there's atmosphere beyond the atmosphere.
Who has claimed that the Kármán line is? Who has no? The Kármán line is the border between here and space. No one has ever said that that's where the atmosphere
It's an imaginary border. Do you have me muted?
It's not something people said.
It's an imaginary border. As was
simply
said
not something that
Iron Bear.
Yeah.
It's an Iron Bear told you it was an imaginary border.
Yeah, it's 62 miles. It's an arbitrary line, but it is nationally recognized.
Round about 62 miles, because you can never tell how high you are.
That's what
you can only
radar
surmise it on pressure sensors. And
no, that's what radar altimeters are for, and GPS altimeters.
And that,
they go up to 60 miles today.
Come from?
Yeah,
this modern technology, is that where all these 1940s and 50s troposphere, stratosphere pressures at this height and that height? That was all
done with barometric altimeters.
Right, so it has nothing
barometers.
to do with the lasers you were talking about, right?
Back then, no, but nowadays, that's how you measure your altitude.
Back then is how they established what we're working off of today. And unless you have something to supplant or replace it today, then I'm pretty sure we're just working off of what they last told us. Does that make sense?
That atmospheric pressure is measured, and that altitude is measured, and that altitude is measured in a different way than the atmospheric pressure.
You're making a lot of claims here, and you haven't shown us anything.
Okay, why would I need to show you that GPS altimeters work?
No, just show me a pressure reading at 60 miles.
Okay.
Yeah, you need to show something, because you've been making a lot of claims here.
It sounds like a robot, too. It's fucking weird.
Who's got the Hellcat as their icon?
Yeah, that'd be me.
Is that missing its tail and aileron?
No, shouldn't be.
Oh, it's just clipped. The image is clipped on the circle. Sorry.
Get the reading.
Yeah, still waiting for proof there, buddy.
There are readings from close to that altitude. There's ones from...
There are zero readings. Zero readings.
Post it in the chat when you find it.
Yeah,
even if you did have readings from a certain altitude, it's only a altitude that you assume you're at based upon your readings. There's no literal measurement. It's based on pressure.
Exactly.
Do you know what GPS altimeters are?
Yeah, bullshit.
I use them basically monthly.
Hey, okay, put the reading in the fucking chat. Hurry up.
Yeah. Show us your little GPS altimeter and show it you at 1,200 feet above sea level or wherever the fuck you are.
And then show us how you confirmed that you were actually at that height too.
Yeah. Air pressure is the only way you could possibly do that, and weather constantly changes that shit. So you can't be 100% accurate. That's why things that are meant to fly through the air crash into the ground often. It's because their instruments fail.
Airplanes use GPS altimeters.
All of them?
Okay. Put your pressure reading in.
Commercial airplanes do.
Hurry up. Put your pressure reading.
Mountaineers use GPS altimeters.
You're just another one of those. just one of those parrots that just says stuff and you don't actually know anything. Just hurry up and put your fucking
Can you
pressure
shut the
readings
fuck
in the
up?
chat.
Like, actually
Okay.
shut the fuck up, dude.
Don't
Right,
get
put your-
spicy with him because you don't know what you're talking about. Come on now.
Yeah. Just put your pressure reading in the chat. You're getting angry because you don't have a pressure reading that you claimed you did.
Show me the chart
Not
that you
getting angry as I
verify
don't
the
have the
pressure
pressure rating.
reading.
You are
to
getting angry. I know. Guys like you with big fat vaginas get angry when
No, I'm
they get
asking you
caught
to
out.
shut the actual fuck up and stop asking me the same thing over and over again when I'm
He
trying to
wouldn't
do
do
something.
if you would
Holy
answer
shit.
it one time. If you
I'm
answer
gonna
it one
say-
time, I promise you he won't ask again.
Yeah, he's triggered.
I won't shut the fuck up.
He's triggered, guys. He's really triggered because he knows he's cornered.
He said nothing.
Oh. Do I have
to
the
move
ability
on
to
to
post images? No, I
GPS
don't.
altimeters
But I
and
can
stuff
DM
like
you
that.
the image.
I don't want it. You
We
put
all
it in the
wanna
chat.
see it. Yeah, he's asking for all of us.
Unless that
Yeah, I
image
can't post
shows
images
the
in the
fucking curvature of the globe, I don't give a shit. It's bullshit.
The only thing he'll have is some 1969 guesstimate calculation from some bullshit computer animation.
I
I want
bet
to see an actual reading.
I bet he
Okay,
just
Jimbo.
takes a picture from Google Images of some fucking GPS altimeter component that's in a junkyard someplace and be like, yeah, this proves it. No, it doesn't.
Really? According to my one, I'd be leaving early.
So many Globers believe that they can prove the globe by disproving flat Earth or one debunking thing. That does not prove the globe. You found some person who had a really like batshit, carefully or clunkily constructed argument for the flat Earth, and you say, this person doesn't know that, therefore it's wrong, and you think the whole thing's wrong. You didn't
Literally
prove
what
the
you've been
globe.
doing this entire conversation.
You didn't prove
Great work,
anything.
dude.
You just may, at the best,
irony is astounding.
have proved one fucking example.
Here's a mountaineer wearing a GPS altimeter. This is an altimeter that I've worn on my wrist when I go hiking.
I wasn't asking for that.
Dude, there's $7 on Amazon. There's $7 on Amazon.
Yeah,
nobody was asking for I was asking for a pressure rating at 60 miles up, is what you claimed.
Is Mount Rainier? I thought Mount Rainier was.
You
That's
can't
not
do
Mount
60
Rainier.
miles. You can't do 60 miles with the GPS altimeter.
Who says that
Has
you
a
can't?
fancy little watch that means more truth to him than his own eyes, his own senses, or everybody around him. Like, well, my watch says I'm dead, so I must be dead.
Also, if you go high enough, you can see the curve of the Earth. It's
No, you
not
can't.
difficult to do.
Dude, stop lying to us.
Holy shit!
This guy's funny.
There's nowhere on Earth that you
Oh,
can stand
you want to
on the
explain
ground
that
and see
photo?
the curvature. No.
I'm gonna send it to you as well, Timbo.
Nobody who's serious believes
seeing them, but I'm driving, so.
So if I climb up to the top of Mount Everest, I can see the curve.
Not what I said.
So do I have to climb higher?
Yeah, the photo that I sent you is a airplane HUD view from 43,000. So.
You sent me.
What kind of window are they looking out of to see that curve?
The cockpit window.
I like to see the specifications of how that window is built.
Oh, that's got to be a tiny Earth, man. It's got to be a super tiny Earth.
Yeah, he's living on it's like a 500-mile radius Earth.
Here's the thing about
If you
cockpit
turn
windows.
around-
Here's the thing about cockpit windows. They can't have distortion.
nice having a
That's
discussion.
federal law.
So if you
there's no
turned around, would you?
It was nice having a
If you
discussion.
turned around,
with
would
you
you
guys,
see this?
but I gotta bounce out of this room.
If nobody
So if
told
you
you
turn-
about
Kind words,
the globe,
Adrian, and everyone.
on Mount Everest, and you would look out there and say, "Oh my God, we're on a globe." No, you would not. If It violates natural law and your senses.
No, it doesn't.
Yeah, you would
No,
not
it doesn't.
stand up
First
there on
off,
the top of Mount
second off,
Everest
we
and look
figured out the
around
Earth was a sphere
and say,
classical Greece.
holy shit.
You
Was
never
that
figured
way?
out anything. You never figured out anything, dude.
Do you know what we means? We as in humanity,
Yes.
excluding you guys.
Royal we.
But we is the royal we, which is humanity.
No, you didn't do shit.
You're not included in humanity.
Why wouldn't I be?
Trying to teach humanity something that humanity knows instinctively as to be false, and you're trying to convince them otherwise. So you're obviously on the outside of that
Classical
group.
Greeks knew the Earth was a sphere.
No, that's a lie.
False.
Okay, prove it.
You prove it.
Yeah, you still improve the air pressure thing.
Came in so far.
How would they know it's a sphere?
Even is charged up with a battery.
You guys hear me?
How would they know it's a? How would the ancient Greeks know it's a sphere? What could they actually do?
They didn't believe it was a sphere.
Stellar navigation was one thing.
Oh, they navigated the stars?
Okay, so that doesn't tell them that the Earth's a sphere. Try again.
He thinks Greeks had
The
spaceships.
sunrise and sunset, and the
That
phases
doesn't
of the
tell
moon.
the Earth is a sphere either. So try again.
I have yet to see someone explain.
You haven't named
how
anything
phases
about
of
the
moon
Earth. You
work on a
said
flat
something
Earth.
about the sun. You said something about the stars. You said something about everything but the Earth. I said, how do they know the Earth is a sphere?
That is how.
Oh, so they don't know.
There are,
Congratulations.
Yes, they do, because there are.
No,
things
because
that
what you're
we
talking
observe
about,
that
you
only
listen,
work if Earth is a sphere.
look, bro. No, you claiming that, but that's not true.
And you explain lunar
I don't need to
phases
explain
on a flat
anything.
Earth.
You need
Yes,
to
do.
demonstrate.
You
You
are
need to
making a
demonstrate
claim
that it's
lunar phases work on a flat Earth.
Okay,
Can you
so
explain
again,
how?
once again, the moon. We're not talking about the moon. We're talking about the Earth. You said they know that the Earth is a globe. Okay? Everything you're talking about would be an inference, and inferences aren't knowledge. So I can look around my neighborhood and see all brick houses and infer that my house may also be made of brick. But that doesn't, I don't know my house is
Seeing
made of brick
the
until I look
moon
at my,
go through
shut up,
phases and
shut
saying,
up,
"This
dude, let me
doesn't work
finish
on
the
flat
fucking
Earth," isn't
sentence,
the same
dude.
as going all the
dude, just go on fucking mute, bro. Really simple. Let me finish my fucking sentence. Okay? You can look at all your goddamn neighbor's house and they're made of brick, but you don't know if your house is made of brick until you look at it. So, how do they know the Earth is a sphere?
By observing things that are impossible on a flat Earth, as
Okay,
I've
you
said.
don't know if they're impossible on a flat Earth. You haven't demonstrated they're impossible on a flat Earth. You just believe that.
They have been demonstrated as being impossible on the flat Earth.
By who?
Okay, show
Name a
us.
scientific experiment. Please.
Demonstrate that they are. That's the thing
No,
I'm
that's not how it works, dude.
There's a
So
burden
there's
of
things
proof
like
that
called exclusionary. There's called exclusionary proofs, right? So Fermat's principle, Fermat's last theorem. A squared plus B squared equals C squared. It is a limit. So hold on, dude. No,
making a claim that it is possible on a flat Earth. That is your indirect claim.
That is my indirect
You'd be
claim.
smarter if you listened to people when they were educating you.
Yeah, he can't. He's fucking locked in. The fact remains is the Greeks didn't know fucking anything. And nothing they can observe about the heavens will tell them what the shape of the Earth is, because it's inferential.
Okay, so
This is just a matter of logic, dude.
How do you know? How do you know the Earth is flat other than it looks flat?
Okay, measurement.
This is how you sound. Can I have a minute?
Such as what
measurement? Measure. Oddly enough, you can measure the surface of the Earth with a laser.
Indio, can I have a...
Hold on. He asked the question. So you shoot a laser, and if the Earth is a globe and the surface of the Earth is curving, that means as you go along the laser, the surface of the Earth should get farther and farther away from the laser as an exponential function. So such as 40 kilometers, the laser should be 420 feet. Or 400... Who's interrupting me?
Yeah, the Earth is...
Yeah, I don't think so, dude. So, The laser at 40 kilometers away should be 400 or should be 127 meters off the surface of the Earth. And when we do this test, that's not the case. It's 1.5 meters off the surface of the Earth, the same height it started as. That means the laser and the surface of the Earth are in parallel. This is measuring the Earth. And this is just one of many, many measurements of the surface of the Earth.
I get to get
ahead,
the whole
Iron.
argument of light doesn't bend here when I explain to you how
doesn't bend. Look, bro, this is off by the prediction by 2 orders of magnitude. You can't get light to bend that much. Okay, unless you have like a fucking 170-degree temperature gradient, which is unphysical.
You probably have like a 10 to 12 degree gradient on the surface of water that you're shining a laser across. You might get some refraction or diffraction, or
well, if you apply standard refraction at this distance, you'll move the laser down 5 meters. But you need to move it down another 100. Hold on, you need to move it down another 122 meters. So where are you getting that from?
A difference of like 10% maximum.
No, that's not how it goes, dude.
No, for atmospheric.
It's not a linear relationship.
No, I'm saying if I were to do this experiment myself, I would expect a 6 to 10% degree of variability based on atmospheric conditions, or the temperature of the water versus the air right above the water versus the temperature of the air 10 feet above the water. There could be some shit to there. I wouldn't expect it to be exact, but I would expect it to be within one.
How are you going to measure that?
Well, it's all fantastic because the results here are 1,000% off.
Right, my point exactly.
2 orders of magnitude.
Ascribe that to atmospheric refraction or anything like that. It has to be because it's so far off that it cannot be, oh, the wind blew.
Well, I mean, it would be very odd that not only because they actually did these tests 3 weeks apart, so it would be very, very fucking odd. And they had meteorological stations that not only did they not measure the frickin' weather condition with 2 meteorological stations at the endpoints 3 weeks apart, and they had the identical magical weather conditions 3 weeks apart that let them frickin' see a globe. Yeah, I'll post in the chat.
I'm on your side.
Well, I mean, it'd be very fucking odd they did it again 3 weeks later.
I think the ideal version would be if the temperature of the water and the temperature of the air were the same magically on one day. That's the day you take the measurement. That's most clear. So you don't have that distortion of the temperature difference above the surface of the water across a lake or something like that. I think that's the ideal.
That's just one of many. I mean, we got Salt Lake one. We got frickin' Salt Lake on the land, on the water. Like every way you can frickin' slice it, it's been done.
I agree, but some people still can't see it.
They don't want to see it.
They want to argue with you.
The Salt Lake one that DJ shows all the time is pretty cuckoo. You can see 21 miles to the other shoreline, and at that night they went and they shot the laser across the same distance, 21 kilometers. And not only do you see the laser, you see the reflection of the laser off the water, which
oh shit,
that's impossible.
Indio is bouncing the laser back to the original observer. Is that the way to prove it even more? Nobody saw the
check it out. If the laser is supposed to be behind the curve, right, on the other side of the curve, how could you ever see the reflection of the laser off the water?
They're always trying to hit a target across.
Think about it. Hold on, dude. Think about what I'm saying for a second.
Man.
You got a hump, a hill. How can you see the reflection of the laser when the only place the laser can bounce off is the other side of the hill?
You can't.
Yeah, you can't. But we do.
So one of those lasers.
would it be a good proof if you shined a laser across the lake and had it bounce back across the same lake to you?
I mean, that's been, they did a triple mirror flash at the Salton Sea, where they made basically a giant frickin' triangle, right? So one mirror operator could see two other mirrors at the same time, and each point of that triangle, each person could see the other two mirrors, which are also see like 128 feet under the curve of the Earth.
So
that reminds me of the Michelson-Morley experiment a little bit.
Just wondering, did they have multiple vertical arrays recording temperature along the entire path of the laser?
Why would they need to do that, dude?
What do you mean, why would they need to do that?
Yeah, I'm asking why you're asking. Because that's a red herring.
So I guess the military can't use line of sight anymore.
No, it's
you
not,
understand
because
that you need to move the laser.
This big area has this refraction.
Yeah,
it
but
changes
you need to. Yeah, that's a cool story, but no one's ever demonstrated that this type of refraction actually exists. Okay.
Hypothetically, if there was...
because I already told you that the drop was supposed to be 127 meters. Now, if you use standard refraction calculation, that only moves the laser down 5 meters. So now you have 122 meters to make up. So you would need some crazy, abnormal day, not only just once, and not at just one distance, at 7 different distances, with 3 tests done 1 week, and 2 more tests done 3 weeks later. In the same crazy refractive condition, a 20 times deflection refraction condition that makes the Earth looks like it has a radius of 65,000 miles, that would have to exist.
Yeah, he'll
by random, 2 weeks apart, and it didn't show up on their meteorological station somehow.
He will cherry pick an example that says, "Oh, look, the math matches up for me right now."
No, I'm not cherry picking. It's people that know what the hell they're doing.
You can't just say the magic word refraction. You need to justify how it even applies. You need to actually justify using
refraction applies to everything that you do in the atmosphere.
Yeah, that's your claim, dude. That's not a justification.
So refraction applies.
If I drop a bowling ball off a cliff, and I say, "Hey, dude, that's fell at 10 meters per second squared," and you say refraction, and I go, "Dude, you need to justify why refraction affects a bowling ball," and you're like, "Refraction applies to everything."
Refraction applies to light, not solid objects.
So you understand now why you're
Why does it apply to light in this case?
Because you're over water.
Oh, okay. So water causes refraction?
Yeah, there's a higher refractive index over water.
Okay.
Why?
It's not how it works. You don't know what you're talking about.
Nothing to do with temperature variations.
Yeah.
Yeah, that's what it is. It's the variation. Because the water is there.
Because the water's there, that makes
so.
Yeah,
so let's get this straight.
There's a difference in
Grumman,
temperature
slow down. You're going to fry your brain. Grumman,
yeah, we know they measured.
Oh.
So let me get this straight. When we go to the salt flats, there's 0 miraging effects because there's 0 water.
No, I said
so it's not water of this cause and effect relationship.
Boom.
I said there is a more.
Look, brother.
By what difference?
You would need the water in the air to have a 70-degree temperature difference.
What do you think that the temperature difference between the air in the atmosphere and water that's like
hold up
in the Gulf of Mexico?
That's what causes in
the atmosphere? Time out.
All right, you cocked or something, dude? You drinking, brother?
The temperature difference between the air and the atmosphere? Really?
Between the water and the air will cause a temperature gradient, right? And that temperature gradient, which causes the refractive index gradient, which in turn would cause the bending of light. Now, to bend light, the amount you need it to bend, you would need a 70-degree temperature difference in 1 meter, which is unphysical and has never been seen on the fucking Earth.
Yeah, and I'm not saying that that's what it is.
Meter above
But
sea
that's what it would
level.
have to be.
Oh my god.
Not what I'm saying it is.
But that's what it would have to be to get this result.
As you've said, the temperature gradient changes per meter.
Yeah, great. Like 1
so you
degree,
would
a half
need
a degree.
Yeah, that's why I'm saying that you need something to measure the temperature across the entire track of the laser.
No,
that
we
half
don't.
A degree yes, because that half of a degree matters.
There goes line of sight for the military again.
Yeah. So, hey, Grumman, check it out. If you were to shoot the laser and then you were to walk along it, you and me, we've set the laser up horizontal, and then we go down to 21.8 miles, and we're standing either side of the laser. Where's your refraction?
See the video that I sent?
Where's the refraction? You're standing next to the laser. Where's the refraction? You're not looking along it. You've walked along it to make sure that it's making its way, that there's nothing in the blocking its way. Where's the refraction when you get 21.8 miles down the other end?
You can see the fucking cannon looking at you. It's gonna kill you.
No, hold on.
Refraction.
He's got the laser. We've set it up horizontal.
Crazy.
We've gone down the other end, 21.8 miles.
Horizon's not physical, dude.
Okay, so
where's your
that's the
refraction?
claim.
Yeah, that's easy to prove. If the horizon was physical, could it move around?
Nope.
Does it move around?
Yes.
No.
Oh, no? You sure about
it
that?
Doesn't.
The horizon is depending on the observer.
This dude just said the horizon don't move around. That's crazy, bro.
I heard that. That's going to be a good one.
The horizon moves.
Wow, dude.
Well, I mean, that sucks, dude, because we live on a ball of 315,000 mile radius.
Dude, the horizon doesn't rise to your eye level. That's proven by
I said moved around, dude.
No one said it does. No one said it does. Only you said
You have like
it does.
2015 arguments, man.
In what way do you mean the horizon moves?
It'll appear at one distance one day and another distance the other day. In fact, it'll appear at different distances within hours.
During the same day, yeah. A couple different times.
Visibility.
So in the...
Yeah, that's called refraction. That's
so it's not
something
physical.
that we've brought up. No,
So you've just claimed,
the light from
you've just shot yourself down, Grumman. The horizon is not physical, it is now refracted. So you've just sold away any opportunity you thought you had of proving Earth curvature.
The horizon will not move.
The horizon is non-existent if you beg for refraction, you knuckle dragger.
And now you're contradicting NASA because NASA says the higher you get in altitude, the less defined the horizon becomes.
NASA's
No, the more defined the curve becomes.
Yeah, where'd you read about that?
Wow, he just says anything, doesn't he?
Dude, you're just a freaking...
Where did you read about that? No, dude, it's stuff that I've seen.
It's a published national paper,
I've been
by the
in
way.
airplanes before.
You can see the curve of the Earth from an airplane? You can tell us that now?
That's what he said. He said, yeah. He said out the cockpit window, you can just see this big curve. And so that means we live on like a 500-mile radius Earth.
No,
that's crazy because in the chat I was supposed to 315,000 mile radius Earth.
Yeah, I've never heard anybody say 500.
No, that curve is exactly what's expected to be seen if you run it through.
There's no curve from an airplane.
Yes,
no
there
curve.
is.
No,
Yes,
there isn't.
Yes, there is.
No, there is.
Okay, so you disagree not only with geometry, but every other frickin' person that's ever talked about it. Every other scientist, every other optical scientist, every other fucking person.
Who?
Hundreds of thousands of pilots?
You realize the Earth is supposed to have a diameter of 8,000 miles, and you're saying being 10 miles above it, you can see the curvature of the Earth. 10 miles above an 8,000 mile diameter ball.
Yes.
Think about what you're saying. You're 1/800th above the surface.
Yes,
Indio.
there are people
Isn't
that
the
can
radius
break.
3,900?
There are people?
There are
Indio.
If you had a ball. Oh, okay.
3,000
dude, you're
people
fucking
have
cocked or
spoken.
something.
Yeah.
You're just saying random shit, man. So, Grumman, if you had a ball that was 6 feet tall, an airplane would be 1/100th of an inch above it. Okay, you don't know what you're talking about. You're talking out your ass.
I've seen it from an aircraft.
No, you haven't.
So, yes, I
dude.
have.
Well, then you're a tiny earther, dude.
You're a liar, dude.
Yeah, you are a liar. Dude, not even 128,000 feet. Not even 250 miles, dude.
Felix Baumgartner said that he saw the curvature of the Earth.
Yeah,
So you're
and
gonna pull that argument
Neil
out.
deGrasse
And how you going to back that up?
in Neil deGrasse Tyson, right?
Is wrong.
He's wrong.
Yes.
Okay, so tell me, in the images he posted, right? The GoPro. So what is that? Planet Mexico?
No, that's a
You
fish
can't even see the border of New Mexico. How can that be the horizon? How can that be the Earth?
Called a wide-angle lens.
Oh, so that's not the curve of the Earth. He didn't see the curve of the Earth from his fucking balloon.
Felix Baumgartner did.
No, he didn't, dude. No, he didn't.
Oh, his eyes.
Hey, check it out. He also saw the curvature of the Earth from ground level. Look inside chat. 34 past the hour. Not even off the ground yet. That's him getting into the little shuttle thing.
Do you not understand the difference between human eyes and a camera?
Oh,
What's that got to do with your claim?
Was he looking for a visor?
And
The
sometimes
visor
people
that distorts jack all because that's.
Oh, doesn't it? How do you know? Have you worn it? Have you worn it?
Yes, I have worn it.
What about the shot from inside the pod?
Holy
What about the
fuck.
shot from inside the pod? What about the shot from inside the pod?
Where you're looking through this tiny thing? Yeah, of course it's not going to show fucking curvature.
So it doesn't look like it's curving. So it doesn't look like it's curving.
Even defished images. People that have defished.
Is that a word? Answer that either, bro.
Yeah, that's something that you can do.
So look in the chat. Which one of these circles of the circle the horizon for Felix Baumgartner? Which one?
Play the wider one.
Which of these circles? It's the fucking yellow one, dude. The yellow one. In the center. The yellow one is the complete, if you could see 360 degrees, his horizon. The biggest circle would be the ISS horizon. The ISS would only see 3% of the Earth. Now, you're trying to tell us that seeing 1,000th of the fucking Earth, you can see the curve. Get the fuck out of here, bro. 1,000th of the Earth, dude.
Why don't you
It's
ask
probably less
Felix
than
Baumgartner
1,000.
yourself? Oh wait, you can't because he's fucking dead.
Yeah.
So what are you trying to push his claims for him then? Because he's fucking dead. Hello, McFly?
Anyway, I'm gonna send you a photo here.
I thought he wasn't dead. I thought we've determined he wasn't.
No, he died in a paraglider, I think, is what it was.
Maybe he told somebody, "Hey, I really think it was flat," and then they were like, "Shut up," and they killed him.
Gando, I sent you a couple of photos because I can't send images in this.
So if you could see the whole circle of the horizon, it would be 0.094% of the surface of the Earth. So that's a 10,000th, okay? And that's just assuming you could see the entire circle, which you can't because you only have a certain field of view, and your actual focal field of view, what you can actually focus on, is only 5% or 5 degrees. So he can see 1/100th of the surface of the Earth and see the curve. You're a retard, bro.
Here, I ran a photo through a Earth curve calculator. And that's the expected curvature at that height. and it matches with what the photo is showing.
You mean Disney's Earth curve calculator? With the sliders? So you can just slide them around until it matches any image that you post?
If you know the refractive index, that's what you're getting. And that's also, first off,
if you know the
before you go stroking yourself over about the refractive index,
without refraction.
Yeah, Grumman, before you go stroking yourself about this refractive index, how about you...
The normal.
How about you supply us
assuming
an
no
image?
refraction.
How about you shut up for 5 seconds and stop talking through people, you rude little turd? How about you, instead of stroking your ego about this refractive index, supply us with an image, right? And all I want is the known refractive index. I wouldn't do that again if I was that person. So how about supply us with an image that you know what the refractive index is, and then we'll run it through Bislin's little slider fun factory and see if it matches up.
Already supplied Indo with one.
It's Indio, not Indo.
Way, supplied him with one. If he wants to send it.
So you supplied the refractive index.
Yeah, I see it. Hold on.
If he's laughing, this is going to be good.
Yeah.
Then there's Horizon out at eye level at Rainier.
Yeah, but you got Horizon at eye level at Baumgartner. How's that possible? And the Horizon should never be at eye level unless your face is on the ground. The level of your eye.
I'm looking at photos here with a Theodolite app that show in an airplane the horizon is not at eye level.
Planes fly tilted up, nitwit.
Out the side? They fly tilted, banked over?
Well, I don't know if it was banked in that instance.
Well, because the photo that I'm looking at is out the side window.
Yeah, that's fantastic.
So if you want to try the excuse of it's tilted, you would.
It is tilted. Go get the negative degrees, dude. You know how one of this freaking thing works? Do you know how a plane works?
They're pitched up. Pitch and roll are different. They're pitched.
Yeah, I know. It's -3 degrees on one side and -0.3 degrees on one side and -0.5 on the other. Do you see it? Think you measure the fucking dude? You gotta be some kind of idiot, dude. You really honestly have to be freaking an idiot. He's this 2017 lameness, dude. So there's your image. You know this one that says -0.3? That means the phone is tilted.
Yeah. And so -0.3 degrees is barely tilt.
And the first, but it is
now he's going to make excuses for how little it's tilted. So it's tilted. You agree with that? Excellent.
First of all, the that doesn't even look like a real fucking photograph, first of all. And that just looks like a shit overlay. This isn't a photograph. Did this come from a video?
No, it didn't.
Where did it come from?
Me.
And why would you expect Mount Rainier?
It's Mount Hood.
Mount Hood, whatever. Why would you expect that? You know he's tilted up, right?
By 0.03 degrees.
Yeah, but he's 5,000. He's at 5,000 feet, and if Mount Hood is higher than he is, he's gonna have to be tilted back. He should have to be tilting down. Because I don't know how far away he is, right? Because
yeah, what's the distance?
How far away is
to the
he?
mountain from that observation?
We can calculate how much he's supposed to be tilted down, because he should be tilted down, but he's tilted up. See how the crosshair is centered on the peak of the mountain? So that peak should be 5,000 feet higher than where he is.
Yeah, and then you take into account distance.
If the Earth was flat.
Take into account distance.
Yeah, then there's a drop. If we only knew the distance. What is the distance? Any clue? And where did he get his altitude from?
GPS altimeters exist. They're
oh my God.
Mountaineering. Something I use when I go hiking.
Okay, he's inside of an airplane, isn't he? Pressurized cabin?
That doesn't look like he's inside of an airplane.
Well, I don't know what this is. It's impossible to evaluate. To be honest, the image looks like it was color corrected, and this looks fucking overlaid. This don't even look right. I don't know if he's in an airplane, but he can't use a GPS altimeter. You know that the GPS's vertical values are the worst known. They can be off by hundreds of meters.
In my experience, they haven't been, because I use them when I go hiking.
Anecdotal evidence isn't.
It's not anecdotal, it's personal.
It is anecdotal. You said, in my experience. As soon as you said that, that makes it anecdotal.
No, it doesn't. It makes it personal experience.
Yeah, anecdotal. Do you not know what that word means?
Not anecdotal. I'm muting this guy. These are apps that you can download on your phone. They're theodolite apps.
Don't mute Indio or you'll be banned.
Not muting Indio. I'm muting the guy.
Anecdotal, not necessarily true or reliable, because based on personal accounts.
If you mute anybody, you're going to get kicked.
Well, I don't know about that. I'm going to unmute you, Iron Bear, dude. Try not to have verbal fucking diarrhea.
I was never trying to diarrhea anybody.
Just he played this game.
It's like you're not following the conversation. You're just interjecting random shit, dude. Try to follow along. What's up, Casey?
How you doing, you alright?
So haven't you noticed, Grumman, that you haven't presented any measurements of the surface of the Earth?
That photo that is a measurement of the surface of the Earth.
Well, how far? No, it doesn't if we don't know how far away the goddamn mountain is. See, if we know how far away the mountain is and we knew his elevation, we could calculate how much he's supposed to dip down because of the curve of the Earth. For some reason, he's tilted up. So if you look at the right-hand side, that's his tilt, okay? And he's tilted up.
Negative is down.
Oh yeah, he's tilted down. So half a degree.
Half a degree over 30 miles
half a degree,
is a long way.
Half a degree would be 0.5. That's 0.05.
Over 30 miles?
So, according to calculations, thanks to ChatGPT, because I'm too lazy to do any of them.
Hey, Hellcat.
Roughly 80.
Why are you on here spewing the same stuff that you've been spewing on Spaces?
Calculations.
thanks to ChatGPT because I'm too late.
Also, I love that Platter posted that photo. I'd love to see a fighter jet go Mach 2 at sea level without ripping its wings off.
Like at sea level, like on the sea level, or like 10 meters above? Or
how much do you think the air
want this
pressure
jet to be
changes?
a boat? You want it to hit the water at sea level?
Photo that he's showing, it's basically skimming the waves.
Are you trying to say that that photo's fake?
No, I'm saying that the premise of at Mach 2 is incorrect. At most, it's going transonic, which is what that cone is. That's a transonic cone.
Supersonic.
No, that's transonic.
So, can you explain to me, because I'm stupid, the difference between transonic and supersonic, real quick?
Transonic is between subsonic and supersonic. It's basically commercial airliners fly at speeds that are in the transonic zone.
So, like, right at that speed that's not quite supersonic, but above sonic? Like, what are you talking about? You sound dumb.
Like 500 to 600 miles an hour.
Yeah, 500 to 600 miles an hour.
Yeah, speed of sound is what, like 780?
Yeah, it's a range called transonic. It doesn't mean that you're above the speed of sound.
Made up shit.
Sonic and supersonic are also completely made up things, as is the speed of sound.
Stupid marketing words, dude, that they made up was that they were developing airplanes. We got a transonic airplane. Oh, I got a supersonic airplane. I got a hypersonic airplane. I'm even better.
Well,
dude, I got a thermometer. I got a thermometer that measures 0 degrees, but it calls it trans zero. It's not below 0 or above 0. It's trans 0.
I'm trans 0.
It's transonic.
I got a
in between
trans PSI pressure gauge, man.
Oh yeah.
How are you tracking anything if you're still
Can you say something interesting so we don't have to listen to buzzwords?
This is
made up bullshit.
This is aerodynamic. This is basic airplane stuff.
Yeah, basic airplane stuff.
Typically between Mach 0.8 and 1.2, or transonic flow, is seen.
Oh, I get it. You're trying to say that a plane can fly subsonic and supersonic, so it can transition between supersonic and subsonic flight? Is that what you're saying?
Transonic is that transition.
Oh, okay, cool story. How is this relevant to anything we're talking about?
Not.
All right, thanks. Then quit picking at it. Yeah, I want to actually hear a conversation that's progressive somewhere.
Any plane that can fly supersonic speeds can also fly at subsonic speeds.
Holy fuck, get muted, dude. Yeah. How about that?
Fucking warned him, dude. Were you in here when I just warned him? I just unmuted him.
Yeah.
Yeah.
Fuck, dude. Dude's on his own shit, man. Dude, go start a guest room. Trans units. You might get a different crowd than what you're expecting, but...
Based off his picture, with his coordinates at the top of it, your mountain from where that was taken, you're looking at 83.32 miles.
Right.
Yeah, buddy. Let's say the horizon is below a perfect level line from the midline of your vision. Let's say that's true. Whoopty frick. The ground is below you. It's supposed to be below you. What's the problem? put this in a logic form so you can understand. All right, the ground below you is below you, therefore it's below you. Follow that? It's very simple.
I can barely understand you with the roboting.
Oh, my bad.
You're not roboting. You're just crackling. Your mic's a little fucking broken up or something.
Oh, man.
I thought we called that roboting when the mic is.
Roboting is when you have a bad internet connection and the packets don't arrive in sequence. He just has a freaking. I think your Bluetooth is dying.
Man. All right. I give up.
You sound good then. Maybe you're just too far away from your device.
All right, that's it.
And
I'm
now.
back. Oh, man.
Dude, I heard a hint of crackle. And sorry, my ears are sensitive to stuff like that. I did orchestra for like 4 years.
That's great, dude. All I need to know is if I'm wasting my time talking.
I wouldn't say you're wasting your time, but you might want to get.
Am I trans crackle?
Yeah, you're crackling on some things, and then you're
transitioning to no crackle.
Yeah.
All right. I'll say this one more time, dude. The horizon is where the sky appears to meet the ground. The ground is below you, in case you didn't know that. So, at all times, the horizon is below you. I mean, I don't understand what the problem is. Like, is there a problem with the horizon being low in your field of view? Is that an issue?
I mean, there's a claim that's made by a lot of flat earthers that is that the horizon always rises to your eye level.
What does that mean?
It means that you're going to see the horizon in the same place in your vision, like directly in the center.
You sure?
In the center of your vision.
Whoa, bro. Rises to and in the center of don't jive. So, for example, if I say I'm going to the store, I've not yet arrived at the store. If I say I'm in the center of the store, I'm in the store. So maybe it's a language problem. Just because flat earthers say that the horizon should be at the midline of your vision, if anybody has, they're wrong. So why would it matter to show people, who aren't the people making that claim, that the horizon is below the midline of your vision? Like, what's the issue? What's the problem?
Because that's something that we expect on a sphere.
Dude, okay, let me help you out, friend. The ground is below you, no matter what, right?
Yeah.
We all agree, right? It's not like when you go up high in the sky, the ground gets taller. Right? So I don't know what aspersions you've been cast by some moronic flat earther that may or may not have told you the horizon should be at the midline of your vision if the earth was flat, but that's stupid.
The point is the horizon drops away from you as you get higher.
Yeah, no duh, dude. The ground is below you. The higher you go, the more it's below you. Holy moly, bro. Duh.
So there's something physical about the horizon.
Holy crap, one more time for the slow kids in the back. The horizon is where the surface of the earth appears to meet the sky. So yeah, there's some part of it that's the ground, and the ground is below you all the time. Unless you're at the base of a mountain, I guess. But if you get higher, then it's going to get lower. What's the issue?
So the horizon is a physical thing.
Holy crap, dude. Painful.
It's been this way for like an hour.
Dude, the horizon's an artifact of the fact that you see everything by acquiring light from the outside world. That's all it is, dude. Because you don't have a a supercomputer plugged into the matrix so you can see all floating points simultaneously in an orthographic and transdimensional representation, dude. Yeah, you have eyes, you have to see. You have an angular field of view. So maybe you're under the misapprehension that if ideal artist perspective exists in reality, which it doesn't, that everything would, if the Earth was flat, go into infinity to a point. Well, that's not even possible, dude. Because in reality, you actually have to use light to see, not ideal lines that you draw on a piece of paper. And light actually has properties. It takes up space, it has wavelengths, right? There's angles involved. There's near field diffraction, far field diffraction. There's all kinds of things going on. There's no such thing as ideal perspective in the real world. Kind of like there's no such thing as platonic shapes. I mean, this would be as stupid as me saying the Earth can't be a globe because it's not a perfect sphere. Would you take me seriously if I said something like that? The answer is no, you wouldn't. Because I'd be arguing from an ideal, which is nonsense. I mean, if you want to say the Earth can't be flat because it's not an ideal form represented in artist perspective, I mean, I don't know what to do here.
Not what I was saying, but okay.
Well, then why does the horizon being lower at the higher you go have any merit to talking about the Earth being a globe or flat then? As if the horizon has to be at the midline of your
that
vision.
has been made that it rises to eye level.
Okay, fair. Okay, so it's a bunk claim. It's a stupid claim. Do we both agree? Yeah, we both agree.
Yes.
Okay, perfect. So now that we know it doesn't prove the Earth's not flat, whoop-de-doo.
Then the photo that does show the Earth curving was just dismissed as, oh, that's fake.
What Earth curving? That photo that you showed where the horizon was lower than the crosshairs that you put?
No, not that one.
Okay, then where's the one we're showing it's curving?
One that had, what's his name, Bislin's calculator overlaid.
What? That's wait a minute, dude. Are you basically go ahead. But are you basically having an image where you can't see the bottom of it, and then you're doing like a blink test, or this bottom is sunk under a horizon line, and you think that because you can't see the bottom that you're looking at curvature? That's not showing curvature.
No, it's because you can see it from side to side.
Side to side. Oh, all right. Yeah, post that, homie.
How much curve are you claiming to see from side to side? Do you have a number?
Not very much.
So it's just like it looks curved, it must be curved, but with no data to go with it.
Yeah, it's a 3-degree dip angle.
I'm pretty sure this is going to be bogus nothing. What? Dude, you just sent me the same image you were talking about earlier.
No, the image that I was talking about earlier was this one.
All right, you must have done it accidentally.
Oh, that's
no, you posted the same thing.
I just posted the same thing. No, that's not what I meant. I forgot to copy the correct image. That's
no worries.
That's the photo.
Holy crap, dude! That's not a photo. Are you telling me this is an overlay on an actual photo?
Yeah, the second one that I posted is an overlay. The first one is a photo taken with an app that does the overlay.
Holy crap. One X iPhone camera? Holy crap. You think an iPhone doesn't have barrel distortion because you just put on fisheye?
What barrel does an iPhone camera have?
Look, dude. All it says is 1X iPhone camera. What does that mean? The first iPhone?
No, it means that it's not zoomed in or distorted or anything.
Yeah, which phone? Which iPhone?
I don't know.
Well, then who cares? You can't even go to the particulars of the lens.
Well, it's an iPhone camera. There's
Okay, how about I post my picture from the side of a plane showing the wing and an upward curved horizon. So I have a picture of an upward curved horizon. You have a picture of a downward curved horizon. Who's correct?
I mean, I also have a photo of a downward curved horizon of my own. Let me see.
So I have a picture of an upward.
Hey, Grumman,
Actually,
are
I
these
think it's on my
pictures you're
other
are these
thing.
pictures you're posting gonna be authentic?
Something that I've used before, and then people are always like, "Why is the wing curving up and stuff?" And it's like, I mean, that's how that airplane's designed.
Oh yeah.
Really interesting, like the 777 or 787.
Bro, dude, there's no way to even validate this is even a photo, dude. So I don't even know what you're doing here. But whatever. I will save it. Let me save it here. $43,000 feet. Okay. Oh, at 43,000 feet, the distance to the horizon is a certain distance, right? Whatever it is, correct? Let's just call it one horizon distance. Okay, makes sense? Now, if you're on a ball and the horizon's a curve, then that means the horizon is the same distance, 360 degrees around you, correct? Not only that, but it's the same angle. From your altitude down, it's the same angle, 360 degrees around. So it's the same angle and the same distance. So where's the curvature information coming from to be rendered in the image? Think about it. In order for that curved line in your image to be the curve of the Earth, then the left and right have to be either a further distance or a shorter distance, or a bigger angle or a lesser angle. So that would mean that what you're looking at is changing distances and changing angles. How's that happening if the Earth's a ball? You know what's interesting about a flat thing is that to the corners is a diagonal distance that's greater than the center distance. You can't get that on a sphere, dude. So we got a problem here. So my question is, in your image, the curve is higher in the center and it's down in the left and the right. So which portion is longer? Like which way? When you look left, is the Earth longer? Or when you look right, is the Earth longer? Or when you look straight ahead, is the Earth longer? Which one?
I would say left or right.
Why? Well, let me ask you this question. It's to ask of a glober, because the glober is claiming that this arc represents you're on a sphere, but it's the same distance and it's the same drop angle. So that curve is the same distance and the same drop angle. And if the z-axis in the distance and the y-axis up and down is compounded on the same axis in a two-dimensional image, which it is, then what's going on? How are you getting a curve at all? Wouldn't it have to be more of an angle to the left and to the right?
Wouldn't images on the left side also be tilted away from the images on the right side if that was Earth curve?
Well, we still got a problem that it's the same drop angle. Same drop angle, same distance. So if you're looking straight ahead and a same drop angle and the same distance causes the quote-unquote alleged curve of the Earth to be rendered high in the image, then why is it not causing the quote-unquote curve of the Earth to be rendered in the same height on the left and the right?
Why?
What's that?
I'm asking why. What's the answer?
Oh, because it's optical curve, not physical curve. That's why.
That's what I was gonna say. I knew it. I knew it. Damn fisheye lens.
I bet the CIA invented the fisheye lens too.
But if you're above the Earth and the horizon is a circle, okay, that circle, the bounds of that circle is the same distance, same radius all the way around you, and the same drop angle. So if a portion of it's coming in at you and it renders at a certain height in your field of view, then the rest should as well, because it's the same. So pick any point on that line. Just look at the image he posted. Wait a minute. Did you guys see the image he posted? Let me post it.
Yeah, we saw it.
This one, then he posted this one here.
Yeah, we saw those. The second one.
So put your finger on any point on that apparent curved line that he's claiming is a curved line. Pick any point.
Mm-hmm.
Put your finger there. Once you got it locked in, tell me what the distance of the drop angle is. Someone already posted the distance. We'll just use 3 degrees for the drop angle. So -3 for the drop angle at 13,000 meters. Okay, you got it? 13,000 meters, 3 degrees drop. Now pick a different point. It's the same, 13,000, 3 degrees drop. Okay, so if you picked a different spot, why is it not rendered in the same position if the values from the one rendered it at a certain point in your field of view? Why are the rest of them not rendered the same? Because all the light's coming in from those points at the same distance and the same angles. You know, there's a thing out there that people think there's distortion-free lenses, and that's not true. Lenses just manage the distortions in different ways. So they preserve one quality at the expense of another, like rectilinear lenses. People say, oh, rectilinear lenses are distortion-free. Well, that's not true. In fact, if you go to an actual camera website, an actual photography website, You know, not somebody's blog or some Wikipedia article. They'll actually explain it to you. Funny enough, the way that the rectilinear lens works on preserving the distortion, if you had a dark, let's just say a green bottom half of a page and a red top half of the page, in the far field, the further you get away from the origin, from the center of the image, the red and the green would separate because the values increase on the y-axis as you get further away from zero. So if you actually did that and looked at it again, it would look like a curve. Kind of weird like that. So in other words, the far left and far right side of the image would look curved. And since that's how they work, and we know that, then you would expect something that's a straight line to look curved. So funnily enough, and this is weird, the globers at this altitude should expect to see a flat horizon, and they should expect that the lens is what's causing the apparent curvature, even if the Earth was a globe. You got to get a lot further away from the surface for those angular relationships to change to where you're going to have discernible curvature information.
I see. Yeah, by the way, Travis was asking me about my name. DJ, do you know my actual name translates to horizon?
Oh yeah, you mentioned that. Yeah.
Yeah, I
Yeah, so
mentioned that.
a horizon's a very real thing. Okay, but
Yeah.
it's got nothing to do with the Earth being a globe.
Mm-hmm.
It's a vanishing point. It's a maximum distance that you can see based on your perspective in relationship with the surrounding medium. Okay, like the weather, the air, the temperatures, the pressure, all that sort of thing.
Yeah, but that's pretty interesting name to name a children, man. You should name your child that.
Horizon.
Yeah.
What does she have her eyes on?
So do you believe that Kepler was a real person or not? Because Kepler have been attributed to discover so many planets, bro.
Really? Kepler that thought the sun was 13 million miles away?
He's a fraud. And he probably killed Tycho.
What do you think
You know,
about
he was-
universe?
He
What
was
do you
nothing.
think about
You know that? Did you know that?
He was nothing?
Okay, go on. Go on.
Yeah, you
Okay.
completed, man. Teed up.
No, there's just some suspicion about Kepler. And
Okay.
There's papers written on it.
I was saying, what do you think about the universe? Do you think that the Earth itself is a universe? We don't have anything beyond the Earth? or you kind of agnostic to the position of universe. You say we don't know.
The Earth is part of it. It's the floor. You know, you're on the basement.
So
pretty much you're
is
on the
anything
bottom floor.
beyond it, according to you?
I don't think the Earth is like in a place. I don't think it's in a universe. I think it's a component of the universe.
Component of the universe. So you believe that there are other things than Earth
Part
in the
of the
universe?
structure of the reality we inhabit, right? It's not like I don't think I'm on a thing that's inside somewhere. I think I'm inside the thing. On the floor of it. Yeah.
The floor, yeah. So you believe the Earth is all it is, right? There's nothing beyond Earth.
Well, look, people have just become accustomed to like terming the floor that we live on, the surface we live on, as the Earth, and then they separate everything else from that, right? As if the Earth is this independent, isolated object, right? But how do you know that's true? You don't. It's not the case. For all intents and purposes, the Earth is your universe. It's the only place you're going to experience with more than one sense.
Yeah. Man, what do you think about scientists or rather astronauts working on the International Space Station?
It's a cool story.
Hey, DJ, what do you think about astronauts?
Some of them seem like they're literally retarded. Like, literally, like Don Pettit. If you listen to Don Pettit talk, it literally sounds like they've hired like the dumbest person that they could possibly find. And they're trolling us, saying that this guy's an astronaut.
That dude,
okay, and then they do like childish little demonstrations to impress children up on
He's the guy the short bus kids reject. Like, seriously, have a listen to his stuff.
You know,
what did you say, man? Can you send some videos of him?
Yeah, we can probably. Oh yeah, we'll play a video. Matrix, do you have anything?
I refuse to keep his stuff because it sounds so childish.
Well, I'm gonna find one.
Sorry.
All right, so hold on. All right, here we go. All right, so this is your pristine astronauts from your International Space Station. Don Pettit.
Hey, Don, you're getting ready to launch to the International Space Station to be part of Expeditions 30 and 31. Give me a summary of what the mission goals are for your time on orbit and what responsibilities and jobs are going to be yours when you're up there.
Well, I'm one of the science guys and I'm one of the repair guys. And fortunately, there's lots of science and lots of repair to do on station, so that will certainly keep us all busy.
So give me a couple of examples, if you would, of some of the human life sciences experiments that you're going to be involved with on this flight.
Not at all. Well, living and working in space go along with doing science experiments in space.
There's only a few simple principles you must bear in mind before attempting to operate a sophisticated piece of machinery like this.
And I see two basic areas of work. There's the scientific research, and then there's what I refer to as engineering research. Well, I'm one of the science guys, and I'm one of the repair guys. And fortunately, there's lots.
Hey, Paradox, I have a question. Do you think that they could trick? Do you think that they could trick people into thinking that they went to space?
No. Especially not this person.
So, do you think maybe that they've tricked people into thinking that they actually went to space, but they didn't actually leave the Earth at all? Do you think that?
Yeah, maybe because this person seems retarded, man. To be honest.
Yeah, legit.
How can I
all
behave this way?
Yep. And they did a reality TV show in 2005, I think it was. Maybe it was 2015. Anyway, I can't remember exactly. So there was a TV show called Space Cadets where they got a group of people and they literally tricked them into thinking that they went to space. And they thought that they were in space looking out a capsule at the Earth. And they were all mind blown. And it turned out to just be all a prank. They never left the Earth. They just set up a capsule, right? They put them through all this fake training. They had fake astronauts and trainers and stuff come in. They told them that they were going to actually go to space. And then they made this big giant capsule and they thought that they were launched up into space on this capsule. And then it had big giant screens outside the windows that showed the globe. And then they thought that they were like looking at the globe from space. And then it turned out to just be a big giant prank. Grim just posted it in the side chat. It's called Space Cadets, the most expensive hoax in television history.
And yeah, so all of the subjects believe in it.
They had a couple of people that were plants, right? So they were planted in there, and they knew that it was fake. And they did interviews with them, and they're like, "Oh my god! As long as these people think that they're hearing information from a scientist, they're going to believe anything." And they were shocked. They were like, "These people will believe anything that the so-called experts tell them." And that's what globe earthers are like in general. Anything they get told by a so-called expert, they just believe it. It's kind of crazy. It's dangerous.
Yeah, even me, man, I believe in these things. Whatever I'm being told by these experts.
Yeah. Experts like Don Pettit. So have a look at this clip. Do you think they use CGI in their video footage on the ISS?
Is this real or edited?
Yeah, this is real. This is you can find the original video for this.
They can't make it too obvious, right?
It's pretty obvious, isn't it? That they're using CGI.
How can they make it so obvious, bro? Like they can't be so dumb, right?
Well, people, it works, doesn't it? Maybe it's a way of them gauging how gullible humanity is. I don't know. There's so many bloopers, right? They get caught in cables. The women are literally wearing hairspray. Obvious hairspray.
I'm back. So.
Yeah. Hot dog, mute your mic for a while. Let us talk.
If you're gonna giggle, hot dog, you gotta mute your mic, bro.
Do you like giggle? Do you don't like?
Giggle, yeah, you're childish giggling.
Why? Is natural. So, yeah, it's it. So,
Oh my god. Get yourself under control, hot dog. Alright, so paradox.
Mhm.
You know what a zero-G flight is?
No, what is it?
You know when they go up and they do a parabolic flight and they have it like simulates weightlessness for about 30 seconds. So they go up
Oh,
in a
yeah,
plane
yeah,
and
yeah, I'm aware of it, yeah.
yeah, so it seems like they have a mock-up of a ISS interior inside a parabolic plane. Okay, and here's footage in the side chat. And this is exactly what it looks like when a parabolic flight ends. Okay, everyone falls down to the floor. So they've turned the camera sideways. And if you put this side by side to the a parabolic flight ending, it looks exactly the same.
I see. Yeah, this seems to be a propaganda as well.
Yeah. Can you see the problem with this image?
Yeah, it is too enlarged, right? The
Yeah.
riverfront is too big. It's the Nile River, right?
I don't know. Probably.
Yeah, it is. It is the Nile River. It's Egypt.
Mm-hmm. Here's another example.
Size matter a lot.
Yeah, I have some good proof actually. You know, this guy's going to explain what they do up on the ISS and how much science is actually being done up there. So just click play and check this video out.
World-class laboratory, floating around doing science all day, every day. We're doing science inside, we're doing science outside. So the space station, for example, when SpaceX 11 came up, it had 6 tons of science, mostly science on, that then we had to bring on board, knock out that science. That's the job of this place, is dedicated to either pure science and those science.
Boring. Well, is photos.
What?
I don't know what this fight is about. It seems like the down one that Google Earth did. That's a big difference between real photo and a Google photo. Earth, they like created, but okay, it doesn't matter. Oh, well, then tell me why, if people in Canada and in, I don't know, Australia, no, maybe, so, Northern Hemisphere and Southern Hemisphere moon is like upside down moon, and at the same time,
okay,
2 countries in the world, if at the same time 2 countries in the world would have an opportunity where they maybe really does this opportunity does have to look on the moon at the one time. One, see the moon by the oceans on the moon are down, and the other country see those ocean down up.
Do you think there's ocean on the moon?
I don't mean it's ocean. I mean like it's called ocean of the reason of like those holes, those big holes. They call it ocean.
Mares. Or seas.
Oh man, I don't know. Whatever.
Okay. All right. So I'm gonna. Okay. So see the diagram in the side chat.
Let me see. Diagram. Well.
Yeah. So if you're looking at something from a different angle, it's gonna look like you're looking at it from a different angle. It's pretty simple.
Let me check. It makes sense.
You're just looking at the moon from a different angle, so it's just going to look like it's because you changed your perspective, right? Just like the 6 and the 9 example above it. It's very simple. Yeah, the globe is not scientific paradox. It's pseudoscience by definition.
What? Oh, give me a second. Give me a second. You have a lot of what do you have? The screenshots, the stuff. You already have. Let me also found something on mine because this isn't fair.
Hey, you said scientific paradox. Can I ask you a quick question? You still there?
Yes.
In your mind, what, as far as you know, what is the definition for the word science?
Science is something which is based on observation, and it is the study of natural phenomena. If I'm not, that's my definition of science.
This is interesting. I think you have some picture to it. The edge of the planet. Why the water is doesn't going down? Why the water is still keeping on the planet? Why it doesn't away? Like if
Okay, so we don't think that the flat Earth is a planet. Okay, so read the meme in the side chat. Read it out loud. Read it for everybody. Read it out loud. Practice your reading.
Okay, so what it is then?
Well, read it. What does it say?
I read it. I just mean
yeah, but read it for everyone. This is the English Hub. This is practice your public speaking.
I don't need it.
Yes, you do.
Okay, hot dog. I will read it.
Okay.
When someone mentioned flat Earth, but due to your indoctrination, you imagine it existing within the heliocentric model.
Yep. So what? Right. So we don't claim that this is the flat Earth. We don't claim the flat Earth is a disk floating in space.
I got it, but okay, then if you tell us a flat, that how do you? I don't know. Imagine it. How do you think it looks like?
I imagine it.
Yeah.
Right.
Well.
Yeah. So I imagine it like a big lake, like a big giant lake. Okay, and you have continents sticking up out of the water. And the water on the surface of the lake is flat. And you can go from continent to continent.
So,
okay, the water is contained. To have a large body of water, you need to have a container. So the low spot in the ground, that would be the container for the water.
Do you sell any big company, kind of NASA, to share your feelings about it. You can say when you can speak, girl.
No, bro.
No, I'm reading you sent me a meme, or it is. I don't know. It's kind of funny. Well,
No, people
From the
believe that the Earth's a globe. People believe it's a globe because people before them told it's a globe.
People for now,
People
even
before
now.
them, yeah, people before them told them it's a globe, and that's the reason that they believe it's a globe.
Now people keep proving it's a globe, and a lot of more people keep proving it. And
No. Okay, so who proved that it's a globe?
a lot of NASA, some scientist people, and
All right.
any other.
So you think that NASA went to the moon?
I don't know, maybe. I'm not sure. I can't be sure. I wasn't there. But the point that you even could buy a ticket to the moon, which has cost a lot of money, I don't think that anyone would. I mean, you could buy a ticket to go into space. There is around $100,000. I don't remember. Also,
How do you know that you can do that?
Huh? What?
Oh, you're talking about Jeff Bezos?
I don't remember who. Also, maybe Jeff Bezos is there. You could buy.
You can't buy a ticket to go to the moon, bro. You said you could buy a ticket to go to the moon. You can't do that. You can get a ticket to go. You can get a ticket to get shot up into the sky to 60 miles height, where it's not even high enough to see the curvature of the Earth. If it was a globe.
No, you could. There is around $600,000. There's a really high price.
It doesn't take you high enough.
It takes you on the moon. I think it's high.
No,
when was the last time?
Bro.
When was the last time someone went to the moon? When was the last time a person was on the moon?
I don't know, but for $1 million, someone will send you to the moon. I think.
No, bro. How old are you? Are you old enough to be on Discord? You're 19?
Yes.
Good lord.
Good lord.
Thank you. I mean,
there's not even such a thing. Okay, so look, NASA faked the moon landings. Okay, the footage looks dumb. Look at the footage in the side chat. Okay,
maybe
nobody could believe that footage.
No, Chinese was on the moon, not personally.
No Chinese person has ever walked on the moon.
Person, no, but technique, yes.
Hey, DJ, this footage looks so fake, bro. This looks like a scene from a movie, 90s movie.
Yeah, bro. Yeah, but that NASA says that that's real footage from space, and Hot Dog believes it.
I didn't even sew in.
Look at it.
I'm so lazy to find out.
Do we have the Chinese footage of it? DJ,
Yes.
are you aware of the Chinese
Yes.
footage? Does it look
I have
real?
it. No, it looks even worse than NASA's footage.
Because, imagine to take a photo and in miles, I don't know, there's a million or a couple thousand, a couple 100,000 miles away from Earth. Away in space.
You don't seem serious, Hot Dog. You're yawning.
Yeah, I'm not really serious, but now I'm kind of kind of want to prove the point.
You can't prove it. We tried to prove it. You can't do that. The more you look into it, the more you'll realize that the Earth's flat. You'll be like Paradox soon, and you'll be doubting the globe.
It's because you
But
nerds
too ashamed to admit it.
No, because you are been spending hours for downloading all these pictures, all these memes to make yourself kind of better. But there's companies, million, trillion companies, which is a better proof.
All right, bro. So recently they interviewed NASA. Okay, and they asked NASA, how come NASA can't go back to the moon?
Who?
Okay, so NASA says that you can't go back to the moon, and NASA said they destroyed the technology to go back to the moon. Okay, so I'm going to play a clip. Okay, so this is NASA astronaut Don Pettit explaining how NASA destroyed the technology to get back to the moon.
This logical observation. You talking about that?
Yeah, but it's okay. So this is the interview.
Let me check. Let me check.
Yeah, no, I'm playing it. So just listen. I'll play it through the bot.
Okay.
Oops. One second.
Okay. We're going into space.
I'd go to the moon in a nanosecond. The problem is we don't have the technology to do that anymore. We used to, but we destroyed that technology, and it's a painful process to build it back again.
There you go.
Let me see.
NASA astronaut Don Pettit.
Let me see the video.
Yeah, check it out.
DJ, this sounds so unprofessional, man. Like, how can did they talk like that?
Destroyed that technology, and it's a painful process.
He looks like an idiot. And NASA asked to tell that. I don't know.
That's what NASA said. That's okay. So nobody has gone back to the moon for over 50 years.
Look at him. He don't look serious. He looks like an idiot.
Yeah, he is an idiot. Okay, and that's NASA's head astronaut, Don Pettit.
Okay, Russia. What about Russia?
Yeah, Russia said that. Okay, so the head of the Russian Space Agency said that NASA faked the moon landings.
Okay.
Yep, and then another astronaut from Russia, he said that if anybody tells you that man has been to space, they're lying to you.
Okay, what about footstep?
What about what?
Footprint on the moon.
You're just seeing a picture. Okay, you could just that's just probably just done in a studio. You can't see. Huh?
You could buy a very good telescope and you could see it.
No. So they say that you can't even zoom in on anything that was left on the moon. Even if because there's no telescope powerful enough.
I've had once a telescope, which is not very good, but quite expensive. There was a $10,000. It's not really expensive. But it was a kind of good one, and I was looking on the moon, and I saw it very good. Yeah, it isn't powerful enough for see the footprint. Hell, sounds ridiculous even.
Okay, so look here. Just look. This is straight from Google. Okay, so I just typed it into Google for you. Okay, can you zoom in and see the things on the moon left by the astronauts? Okay, no. This is the answer. No, you cannot zoom in with any telescope located on Earth or in Earth orbit, even from the Space Hubble telescope. Okay, you can't see any equipment or vehicles left by the Apollo astronauts. And I'll post.
Let me check myself.
You can check yourself. I'm just reading you what the answer is.
The footprint.
The items left behind, such as the lunar rover or the descent stages of the lunar modules are simply too small to be resolved at a distance of 239,000 miles.
The moon is 384 kilometers away. Such a footprint is a few centimeters wide. See that from Earth, you need to telescope. Okay, then, if I would see from the technique on from electric telescope, which is from satellite in space, which is kind of camera in space.
Yeah, so there's no footage that exists of anything that was apparently left on the moon because nobody went to the moon.
Honestly, Blanchard, that's enough footprint is centimeters. This is from the Earth. You need a telescope with a lens hundreds of kilometers wide. That's physically impossible. Even Hubble space. This in a polyline. Oh, really? Okay. So that's how the best lunar kilometers above man, like NASA lunar recognizable orbiter. Compare results track. Right now.
Now that you've read that paradox, are you still going to stand by that you can zoom in on the footprint on the moon with a telescope, or are you going to retract that?
What can be seen from Earth? The moon itself, large craters, and there's shadows at craters edges. What can be seen? Footprints, flags, survivors, any human scale object. If you want, fire laser from Earth. Hits the laser, comes back distance, 30 millimeter accuracy.
Yeah, you can't see it, dude.
Nah, I mean, so Apollo 11, 13, and 15, they were left their retro reflectors on the moon, which is scientists fire laser from Earth. It has a reflector. It comes back. Distance is measured in millimeters. Accuracy is done right by observation around the world, not NASA only.
You know what's funny? They used to do the same thing before they went to the moon, right? They used to say they were bouncing lasers off the moon before anybody went to the moon. So they were already doing that. MIT University.
Wait a minute,
Okay,
they kind of was just hitting the laser in it.
Well, they've been bouncing signals back off the moon before they went to the moon, so that point...
Kind of sounds? Kind of sound?
Can you sound?
I mean, no. I mean, not sound. I mean, like sound. Okay, never mind. Moon rocks, Earth rocks. So, okay, now it's delicious.
They basically they shoot a signal up in the direction of the moon, and then they get like this tiny little result of some signal back. Apparently.
Yeah, I got it. Moon rocks, not equals to Earth rocks. 382 kilograms of lunar rock were brought back. They contain no water, have isotopes from only in a vacuum, are bombarded by solar wind in a way possible on
Okay,
Earth.
all right, pause. Okay, so when they came back from the moon, right? Apparently, okay, so they apparently came back from the moon, and Buzz Aldrin and Neil Armstrong, they went to the Netherlands, okay, and they took one of the moon rocks that they brought back from the moon, and they gifted it to the Netherlands government, okay, and then they put it into a museum, and then they had it tested, and it turned out to be fake. It turned out to be a chunk of petrified wood.
That's true.
Yeah, that's true. You can look up
What is it?
Netherlands fake moon rock or something.
Netherlands fake.
Maybe moon rock, petrified wood. Netherlands.
Debate reignited.
Most of what the Apollo astronauts brought back from the moon is safely stored and studied right here in Houston. So who watches over this priceless product? Well, you're about to meet her. She is NASA's real rock star.
You might assume that the most valuable souvenir from humanity's greatest journey would be safeguarded in a high-security vault, verified by leading scientists and
Well, also, it's like quite dumb on the reason that, as I know, there was a if even like Formula One believe even a little piece of changing could affect on entire entertainment would, I think, also been if they were really got a real rock or couple. I don't remember. I don't know. Maybe it would be effect on the record.
Mm-hmm.
I'm not sure, but maybe.
Yeah, so they wanted to get the moon rock insured. Okay, so they had it tested, and they couldn't get it insured because it was wood, not a moon rock.
Also, I saw a video where guy was so on the street. Someone, I don't remember, someone from Apollo 11 or 13 or 15, and walk up to him and tell him like, "Oh, I know it was fake, blah 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 blah." He was running away. It was
So they offered the astronauts money to be donated to any charity of their choice. I think it was $5,000, and all they had to do was swear on the Bible that they went to the moon. So they just had to put their hand on the Bible and say, "I swear that I went to the moon." And then the guy would have donated $5,000 to any charity of their choice. And none of them agreed to do it. They would not swear on the Bible that they went to the moon. One of them punched the guy in the face. Another one of them threatened to have the CIA put hit on him. Okay, because what happened? He went to their house, and then they got kicked.
What about somebody?
Let me finish. So they went to their house, okay, and he refused to swear on the Bible that they went to the moon, and then they kicked him out of the house, but they accidentally left a camera in the house or a microphone, okay, and it's on recording that he asked the guy's son, the astronaut's son, said, "Do you want me to put out a hit on him? Do you want me to get him whacked or waxed?" Right. Interesting. Anyway, what's your next point?
I repeat, what there's about someone punch and refuse the Bible Someone punch. You tell me. Do you know the guy who it is? Can I find something about it?
It's in the side chat. There it is.
Oh yeah, I saw that one.
Yeah. He drinks a lot of alcohol. Probably drunk.
Wait, is that Buzz Aldrin?
Yeah.
I mean, I know like less of it, but as long as I know that guy was like harassing Buzz Aldrin as fuck.
Well, he just all Buzz Aldrin. He just said that I'll donate $5,000 to a charity of your choice if you just put your hand on the Bible and swear you went to the moon. And
Oh no, before that guy was before pain in the ass to Buzz Aldrin before.
yeah,
long
because
before.
because he was shocked that Buzz Aldrin wouldn't swear on the Bible that he went to the moon. Okay, so he was following him, and then Buzz Aldrin assaulted him.
It's something to do with US laws too, isn't it? That if you're filmed swearing on the Bible, that they can use that later in court.
Why also, why they were really sure that it isn't fake stone, it just as it is should be the moonstone. Like there wasn't no what is kind of stone in the moon, and maybe it's how the moonstones are supposed to be.
Wood.
Maybe, I don't know. Everything is possible.
Do you think there were trees on the moon?
I don't know. Maybe.
Yeah, maybe. Maybe not. Maybe
But
they just...
it wasn't just a tree. It was tree transferred into something as a stone. And I don't know that NASA would use
maybe NASA's lying. Maybe that's the answer.
No, it's also I reject it. I reject it, but I don't think so that they are really that dumb to
Maybe they just never expected anybody to check.
No, I don't.
Just didn't expect.
Maybe also, but I don't think so that they are really that dumb. That million trillion company really that dumb to use a wood as a stone. Why they wouldn't use some kind of very rare from the deep down from Earth stones and do something with this or make it more mistake. I don't know.
You just heard NASA astronaut Don Pettit talking before and agreed that he sounds like a moron.
Stars all around. The stars around are even brighter than they are here. They're not upside down. It's not really comfortable reading. I don't remember seeing any stars. That was saying?
I mean, that picture is stupid, man.
Which one?
No, I mean, they was saying.
Oh, yeah, I'm seeing it. It says that the stars all around are even brighter than they are here, and the other guy says that I don't remember seeing any stars.
Right.
Oh, really?
Yeah.
So they interviewed a whole series. Yeah, but they interviewed.
That was different condition because it's as I repeated in the chat in 24/7 Flat Earth Discord, as I said, it's just like on Earth. In the day, you don't see stars because of light pollution, as we know, and in the night, there's no. I mean, there is a light pollution, but it's less so that you can see stars.
Right. So some of the
astronauts
said that you could see stars during the day, and some said that you couldn't see any stars during the day.
also not a different scenario. Those guys were on the same mission together.
Exactly.
So that's pretty stupid.
Prime Minister 1969. Claiming was moon rock. It is pretty far away. That's the is what you believe true? Or do you just think it's true because someone told you? Do you never look any further?
You can just read it quietly inside your head, please.
You even asked me to read out loud.
Yeah, I know, but you didn't. Like, what are you even reading right now?
I don't know. There was somebody. It's you were. You sent it.
Okay, which one is it?
I don't know. Got dust. Got tracks.
Oh,
Got
okay.
shot.
So yeah, so that's the foot of the lunar lander on the moon. Okay, and it's
Then-
supposed to have landed on the moon with a rocket to slow it down. It doesn't have any dust at all. Like, you don't listen.
I'm listening. Okay. Oh, I could launch YouTube in here. Now, okay. So, do you watch movie Fly Me to the Moon?
No, bro.
No?
No, I didn't watch that movie.
Do you show a trailer, for example?
No.
Do you know about this movie?
Nope.
Well, then see.
It's just a movie, Ben.
Kind of yes, but they shared the point that NASA Apollo 11 was fake.
Yes, very obviously fake.
Yeah, I mean, I think you're gonna like it. Let me find some information.
Yeah, so we tested the surface of the Earth, and there's no curvature. So all of the moon landing footage and claims are all fake because the Earth isn't a globe.
Here we go. Scrolling through the torture that I call Facebook, one of the posts comes up. People are now believing that the Earth will allegedly lose gravity for 7 seconds on August 12, 2026.
Yeah, apparently that's some like baseless claim that someone made. NASA never claimed it.
Anyone who also share my feeling about plane is an Earth?
About what?
About planet is an Earth. Planet isn't flat.
It measures flat. The Earth is flat. We've tested the Earth. You can believe it's a globe if you want, but you experience the Earth as flat.
No, I mean, here's anybody who like me trying to prove that planet.
Are there any globe earthers in here that have any globe evidence? Because Hot Dog needs some help.
No. I'm just interested. I don't need help.
He's beyond help.
No. I don't need help. I'm just interested. Because like a lot of people, it's just like all of you against me, or I'm just.
Oh, we're not against you.
Yeah, really?
Really?
That sucks.
If we're all against you, you wouldn't have a chance to speak. We'd just be one after the other. They'd wreck you.
Shut it. I don't like it. What?
You'd get wrecked if they were all against you, mate.
I don't think so.
Who that the Earth is flat?
Who said that?
Your mother.
Learn English first.
Yeah, so we're not all against you. All we're doing is pointing out flaws in the data that you've found or the information that you've found. That's all they're doing.
Because I never was interested in that.
You never was, but you are now because all of a sudden you're realizing that this has gone from, this is a joke, flat earthers are stupid, to, oh wow, these guys are serious and they're really pointing out some cool stuff.
No, that's cool that you believe in it and that you proven it and that you tell it is true. Same as I don't know, maybe I could find a person who's the same, who are really smart and who had a lot of proofs and everything else stuff about the Earth's globe. It's independent founding.
How do you know they're really smart?
How do you know the Jews are really smart? Same question.
How do you know that they are really smart?
Okay.
Just answer.
Now, as far as during your presentation, how much interaction would you like to have? Because I'm happy to bring people up on stage.
I don't know.
But really,
what?
How do you know these people? How do you know these people are really smart?
I don't know. And I didn't mean that she's smart. I didn't think that she's smart. I didn't believe it.
The people that you're talking about. The people you're talking about. How do you know? You said they're really smart people. How do you know they're really smart?
Smart? I mean that they are searching for a lot of information, that they learn it, they're interested in that they do something with this. That means kind of smart.
How did you gauge their intelligence level?
I didn't mean they really smart for a reason, smart. Same as you. I don't think that she's smart or some kind of that stuff.
Can I ask something about the flat Earth?
Go ahead.
Don't get me wrong, but I'm not discussing. I'm just trying to learn. Okay.
Mm-hmm.
Well,
so in your form of the flat Earth, are the south directions parallel to each other?
Well, since north is a center point, a direction on a compass, and south is the opposite, no, they are not parallel to each other.
Yes, you're right. And like if you go to the Antarctica and pull out a compass, what would it like show?
I don't know. I've never been there to test it. If you ever go, tell us. Video it, bring it back, and tell us so we all know then.
I mean, there already is a lot of videos on YouTube.
Yeah.
I don't know. I've seen videos of compasses not working in Antarctica, so I've heard mixed reports. Yeah, that they don't work there. But then again, you probably can get some compasses that do work there. So, I mean, what is Antarctica? I mean, you're just assuming that it's a continent on the bottom of a ball.
So is like in flat Earth, the Antarctica is a circle, right?
No, Antarctica is something. Antarctica is something that holds a lot of mystery. It's something that we can't go and freely explore because there's something called the Antarctic Treaty. So all you can do when it comes to Antarctica is you can get flown to a designated small section, okay, and you have rules and regulations, and you basically have to go there, follow the rules, and then you leave. So you could get a cruise, you could get a flight that will take you and cruise over the coastline a little bit, or you could go to one of the research stations. You could go on a trip to one of the one of the camps that's there, like people did recently. But you're not really going to freely explore or anything like that. You're getting taken to a little bit of ice, and that's all you know about it.
So, like, I was here before, like 2 months maybe ago, and there was a guy, flat earther, said that Antarctica is a circle and it exists.
Okay, and did you ask him to prove it?
No, because I'm not like coming here to discuss with people. I'm just here to like get a knowledge, like what people thinks, what people talks about.
Yeah, hold up a second, hot dog. Yeah, so some people claim that Antarctica wraps around the Earth.
Flat earther, yeah.
Yeah, but that's
So like even in
so you should have asked him to prove his claim. Yeah, well, yeah. I mean, globe earthers are also divided. Okay, they have different theories and that kind of thing. I mean, we can all agree that there's no curvature. Okay, all flat earthers can agree that there's no curvature, but some people will try to cling to certain types of models and things like that.
I got a problem.
What's the problem?
The problem is I love you guys so much. I don't know what to do with myself, bro.
Okay.
That's not a problem.
Yeah, probably not.
But yeah, you know, if someone tells you that Antarctica is a big ice wall that wraps around the Earth, I mean, they can't prove that. That would be a speculation. We try not to speculate in here.
Well, how in your imagination looks Antarctica and the one which is in the bottom? I don't remember.
Antarctica is claimed to be a small continent that's at the bottom of the globe, or pretty big, actually.
And there is something on the other side.
Oh, by the way, you guys are also don't believe that longitude and latitude, right?
Latitude and longitude are based off the sky. Okay, and it's just a coordinate system based off the way that we view. No, it originated from it's like a way to navigate using a celestial coordinate system, basically. Like, it's a spherical coordinate system that originated from an imaginary celestial sphere.
Okay, but
which is it's like an imaginary way of mapping out the stars, the motion of the stars, and that
so
kind of
in flat Earth there is no longitude or latitude, right?
Well, there is, but it's based off the sky. It's a conceptual way of mapping out the sky
longitude and latitude
onto the surface. Yeah.
They're not grid lines. You're not going to walk outside and trip over a longitude line. They're not grid lines on the ground. They are derived from the sky.
You're.
It doesn't look. It doesn't matter what you believe is under your feet. Those lines are constructed, derived, brought about from the sky. They are then overlaid onto the ground.
Not from the shape.
From the
shape
sky.
of the globe.
No,
Wrong.
it's not.
From the sky.
Yeah.
Okay, guys.
Hold on,
I
hot
gotta
dog.
go.
Hold on, bro. Okay, you gotta go. All right, man. Well, thanks
Yeah.
for coming
Catch ya,
by.
hot dog.
Appreciate you, man. Come back anytime you want.
Yeah, I gotta sleep, so maybe tomorrow.
Okay.
I think I will.
Good night, man.
You too.
Yeah. So latitude, for example. Okay, so if you're standing underneath Polaris,
Yes.
right? It's directly above you. Okay, and then if you so you plot that down on the map. Okay, this is 0 degrees. Okay, and then you start moving away, and then as you see Polaris's angle lowering in the sky, okay, you plot that out. You plot that out, and you plot that out, and you keep going towards the equator. And as you keep going towards the equator, it will drop down lower and lower in the sky. Okay, and you're mapping that out based off the angle that you can see the star in the sky.
It'll be like
Right,
0
so-
on equator.
Yeah, it would be at 0 when you get to the equator. Yep. And then they basically flip that because you can't see Polaris anymore once you get to the equator, so you just flip what you just did in the north and turn it into a spherical coordinate system. It'll make a sphere, but it's just based off the way that we view angles to the stars. So even long before people believed that the Earth was a globe, okay, they had a celestial sphere, which is basically they needed a way to be able to map out the motions of the stars. Okay, so they imagined a big giant sphere in the sky surrounding you. Okay, and it was just imaginary, right? Obviously, the sky is not a big sphere, but if you imagine a sphere in the sky, you can say, okay, at this time, this star is in this particular position. Okay, and you can make a coordinate system based off of that. It's called the celestial sphere. It's just an imaginary way of envisioning the sky, so you can map out the motion of the stars in a way that's convenient. Does that make sense?
Guys, I said I'm not discussing or talking. I'm just asking.
Yeah, I can try to read something out about that if you want. Okay, this is kind of how the globe became a thing in the first place, to be honest. Just a second. All right, so long before the Earth was mathematically defined as a globe, ancient astronomers visualized the heavens as a perfect rotating sphere, with the fixed stars attached to its inner surface. This was purely a geometric and observational construct. It was the model of appearance, not of substance. The Greeks, Egyptians, Babylonians, and early Indian astronomers all described the sky as a dome or sphere revolving around a stationary Earth. The observer was placed at the center of the flat surface, and this is the celestial sphere. Okay, so it's like an imaginary sphere around you so you can map out the stars easier. Okay, so the celestial sphere was an optical projection. Angles and motions of the stars were mapped around the observer, not around the Earth as an object. So the coordinate system was celestial, not terrestrial. Okay, so in that framework, astronomers introduced celestial coordinates to describe star positions, celestial latitude and longitude, later called declination, and right ascension were angular measurements projected on the inner surface of the celestial sphere. The celestial poles and celestial equator were imaginary reference lines created extending the Earth's rotational axis and its equator into the heavens, but originally this was only a geometric analogy, not a physical proof of a spinning ball Earth. The sphere of the heavens was thus the first complete coordinate system built entirely from sky observations, not Earth measurements. Okay, so later on, people took that celestial sphere model, okay, and they transferred it from celestial to terrestrial, right, from sky to the ground. Okay, so later on, philosophers such as Pythagoras, Plato, and Aristotle, for example, took the symmetry of the celestial sphere and imposed it onto the Earth itself. They reasoned that since the heavens appeared spherical, and they considered spheres to be perfect, right? They kind of like worshipped spheres back then, which is kind of weird, right? They said that the Earth beneath must also be spherical, not because of empirical proof, but to maintain philosophical symmetry between the above and the below. And that's still that's still the coordinate system essentially that we're using now. It's called WGS84. It's a spherical coordinate system that originated from an assumed way of looking at the sky, or an imaginary celestial sphere.
Thank you for answering. I want to ask another question, if you don't mind.
Yeah.
So on YouTube, we can see guys putting cameras on, balloons and shit, and sending it to the atmosphere and stuff over the space, and showing that Earth is a globe. Do you think that they're doing the right stuff, or just it's a fallacy what they're doing?
What about the ones that show it not as a globe, as dead flat? There's no need to cherry pick.
I don't remember asking the question to you, sir. I'm sorry.
Well, this is his event, right? The event's called Globe Earth versus the Matrix. But anyway, look, just quickly, they're just using fisheye lenses. They're just using fisheye lenses.
Okay, fisheye lenses.
Yeah, like wide-angle lenses, not necessarily fisheye lenses. But if you have a close look at the footage, you'll see the horizon is curving the wrong way when the camera pans around. Sometimes it'll look like it's a globe. Sometimes it'll look like it's curving the other direction because of the lens distortion.
Yes, sir. Have you tried sending anything over the space?
Yeah, we've sent up. Well, the highest that anyone can send anything up is 120,000 feet. That's the maximum height you can send up a weather balloon.
And you saw that Earth was.
Yeah, if we send it up with a non-fisheye lens, then you see a completely flat horizon. I'll post some footage in the side chat.
So, if you're trying to figure out that if Earth is a globe or a straight, we gotta use the center one on the image. 0 inches per mile squared.
Yeah, the problem is that even if the Earth was a globe, the height that you're sending the camera up to wouldn't be high enough to see the curvature of the Earth. Okay, so it's going to be inconclusive. You're just going to see it flat, a flat horizon.
I mean, is there any video that I can see on YouTube, maybe, or any kind
You
of?
want to see it looking? You want to see it looking flat from 120,000 feet?
I know, anything that you can show me.
Yeah, if you have a look in the side chat, you can see evidence of the fisheye lens being used. Okay, so
I kind of agree that they use it.
Yeah, Yaga Bruno just posted one. There is a good one that pans around 360 degrees. Just trying to find it.
I mean, don't we have to send over 120 feet high to understand if the Earth is a globe?
Well, even okay, so the highest that civilians are allegedly going is up to 350,000 feet, and that would be the Blue Origin height. You know the Blue Origin?
What is it, sir?
Jeff Bezos, Blue Origin.
Oh yeah, I know. Yeah, I know.
Yeah, so
that one,
like,
yes.
Katy Perry.
Mm-hmm.
Yeah, so even people that went up on that said that they were disappointed they didn't see any curvature even at that height. Okay, so there was an astronaut called Wally Funk, a trained astronaut. She said she was disappointed she didn't get to see the curvature of the Earth because they didn't go high enough. And another person that was on there was William Shatner, the actor, and he said he saw no evidence that the Earth's a globe.
What did the fellow Wally Funk, the pilot, said?
Wally Funk was
Yeah.
a trained astronaut that went up on the Blue Origin, and
Yeah, the
she
pilot.
said in an interview with Fox News afterward that she was disappointed that they didn't go high enough. She thought she was going to get to see the curvature of the Earth. Yeah. And also Neil deGrasse Tyson. Do you know who Neil deGrasse Tyson is?
Yes, I have his 3 books.
Right. So he did interviews, and he said he did the calculations, and that's not high enough to see the curvature of the Earth.
Mm-hmm. Yes, sir.
Yeah. So I mean, we're not seeing it from as high as we can get to, and even the height of the ISS space station, that's not even high enough to see the curvature of the Earth mathematically. Okay, from your field of view, you're only high enough to see 2.9% of the surface of the Earth. So people say even from that height that you wouldn't see curvature. I mean, we've got a math professor that comes in here who's a globe earther, and he says that, yeah, you wouldn't see the curvature from the height of the ISS. So yeah, you kind of have to just have faith in the Apollo footage, I guess. I mean, that looks completely fake.
Question, since you talked about the Apollo, do you guys have a good footage of the Apollo moon landing? Like, easy to find whenever you need to show a friend or something like that, of the cable?
Mm-hmm. Yeah, there's a lot of footage in my server. Like, my server's like a big library, and you could probably find it on the home server as well, 24/7 Flat Earth Discord.
Okay, thank you.
Yeah, discord.gg/Flat Earth. That'll take you to the home server, and then you'll be able to find all the information channels, and one of them will be NASA. It'll say NASA. Or you can click on, if you want to join my server as well, you can click on the FE tag that's next to a bunch of people's names in here, and that's also it's like a branch of the 24/7 home server. So that has a ton of footage from NASA, ISS, that kind of thing.
How about the moon? What do you think of the shape of moon?
It looks like a sphere to me, but I don't know. I can't prove exactly what it is. There's a lot of anomalies when it comes to the moon. So I'm not sure what it's made out of or exactly what it is, but I don't know how far away it is, what size it is. But yeah, it looks like half a sphere when I look at it.
Okay.
Yeah. But that doesn't mean the Earth is also a sphere, just because something in the sky looks like a sphere. So we can test, we have tested the surface of the Earth. Now, most of the surface of the Earth is made up of water. Over 70% of the surface of the Earth is said to be water. Okay, and then when we go and test over the surface of the Earth for curvature, let's say we have 20 miles of water. Okay, we can calculate there should be a certain amount of curvature over that distance, and then we can go and test for that. We've done that probably thousands of times now, and there's no curvature, right? Water is flat on the surface. Check out the footage I just posted in the side chat. This is from the Chinese space station.
China's Shenzhou 14 astronauts complete the second spacewalk.
Yeah, so all the main cameras on the Chinese space station show a completely flat horizon, pretty much. Which I think it looks completely fake, personally.
I don't know, but that picture, low key looks like a Photoshop.
Yeah. So this is official China footage. China's. Yeah, it probably is. But it's this video footage, right? I'll post the original video from the Chinese space station. It's got all the footage in it.
Yeah, I found the video on YouTube.
Yeah.
What does it say? On the second perspective, Earth is globe. By the way, on that video, on the
right,
045.
Yeah, but clearly
I also believe that it's not real.
Well, it's
it looks like a 3D AI shit.
Yeah, exactly. And also, if the Earth was a globe, you wouldn't see curvature like that from that height.
Yeah, exactly.
Yeah, it would basically look pretty much flat from that height. So obviously, whatever that footage is also incorrect, and it also contradicts NASA's footage as well. So check out this footage. I got some footage from the Apollo
11.
I forget which one this is. Might be Apollo 17. But check out this footage. I don't know how anyone can believe this footage looks real.
Dude, it's like 2001: A Space Odyssey.
Yeah, exactly. Like, this is actual NASA footage. You can find
by the way,
you can find this clip on the Smithsonian Air and Space Museum.
Yes, sir.
YouTube channel.
On February, NASA said that they were going to send the Artemis thing on the spaceship to the moon. You see it?
Yeah. Mm-hmm.
What do you think about it? The Artemis.
I'm interested to see how good they do with their footage. I wouldn't get too excited. The footage is going to be extremely disappointing.
Artemis 2, February 6th. Only 11 days? I don't know.
I'm putting my money on delays.
And there will be Artemis 3 on 2027, it says.
Yeah,
I wonder what they will show us.
They have been saying stuff like this. Look, a few years ago, okay, this is globe earthers were in here saying, "Did you guys know soon India's going to be going to the moon? What do you think about that, flat earthers?" Okay, and then this is the footage that comes back from India. Like, look in the side chat. Just watch that video. It's just
Chandrayaan 3.
Yeah, so this is India's footage from when they went to the moon in 2024. Right? Just look at that footage. I mean, it's even more laughable than the footage that you just laughed at from NASA.
Oh, that the channel that you send is Turkish channel, TRT World. I'm from Turkey. What a coincidence.
Huh.
I thought. Wait. I thought that wasn't the Indian rover.
Yeah, that's yeah, if you type into YouTube Indian rover landing on the moon, that's the footage.
Mm-hmm.
Yeah. And then the other footage that they show you looks like a CGI Atari game from the 80s.
I mean, they maybe are trying to make a propaganda that they did go to moon.
Yeah, they want
so that
people
they can
to
show
think that
superiority over the astronomy and shit.
exactly. They want people to think that they can do amazing things, just like what NASA did. Okay, maybe they faked it because they wanted to look like the heroes. You know, they could do what no other country could do. We beat the Soviets, blah, blah, blah. We're amazing.
Chinese fake station.
DJ, can you expand on both your opinion and on the community's opinion on the more philosophical side of why would they feel the need to deceive us in this level of deceiveness to make us believe that the Earth is round? What is the incentives? Because that's a question we hear a lot when we try to talk about this to some friends. We say no, but do the calculation, and then
my first question would be, who's lying? You know, I think that most people genuinely believe that the Earth's a globe. I think most people that work at NASA genuinely believe the Earth's a globe. Even the people that might be in on the fakery, which would only have to be a very small amount of people that work at NASA that would actually know if it's real or not, okay? They might also believe that the Earth is still a globe, even though they're faking space travel. They might still think it's a globe. So I think that professors, most scientists, most people that work at the government, NASA, I think that they genuinely believe that the Earth's a globe. I think they're mistaken. I think it's just a belief system that they don't have any empirical evidence for. It's just a model, right? It's a model that they're using. But they still will admit that we experience the Earth as flat and stationary. So I think most people aren't lying about it. Okay, if I mean, surely there would have to be some people in existence that are lying about it. But when you try to put some names on a list and then prove that the names on the list are actively lying about it, that's a very difficult task. So I think most people are just mistaken, and the globe is more like a tradition, and it's like a theoretical mathematical concept that people just take as reality, rather than a big giant deception. That's my opinion. Other people will probably have different opinions.
And what would be the incentive for those who hold this knowledge, for these few people that we don't know exactly who they are, okay? But what is the incentive of lying to us?
Maybe knowledge. Knowledge is power. Maybe money, control. I mean, to control people's minds.
Hey, DJ.
Mm-hmm.
I sent it a YouTube link at the chats. Probably you saw the video. But in the comments, they say that, wait, let me read it again. Imagine getting your flat earth theories deconfirmed by a piece of garlic bread.
Yeah, yeah,
What do you think about it?
exactly. So yeah, this is
I mean,
alright,
it's not
so-
high enough, right? I mean,
yeah, it's not high enough to see any curvature, and then in the actual footage, you'll see that the horizon it actually curves the wrong way. So hold on, let me just scroll through the footage a little bit. Okay, so if you scroll through the footage, you'll see the horizon warping around. Okay, so when it's above the center of the frame, it's going to look like it's convex. When it goes below the center of the frame, it's going to look like it curves the wrong way. Quite often, you'll see it looking flat as well. So it'll look curved 1 second, and it'll look flat the next second. So even if the Earth was a globe, this wouldn't be high enough to see the curvature of the Earth. So
yes, sir.
even
it
even
must
Neil
be at
deGrasse,
least over 300,000 feet.
or even high, it would have to be
Even higher,
over-
yeah. 1
even
million
higher.
or something.
Even higher than that. I think the space station's 1.3 million feet height. And
The ISS?
yeah, yep.
Wait, let me check. It says 435 kilometers.
Yeah, I think that's 1.3 million feet. Something like that.
Let me check. It's 1.4. Yes, 1.4 million.
Yep. So yeah, they say, like, people say that that's not even high enough to see the curvature of the Earth. So obviously this this balloon footage.
Wait, is there anywhere that I can watch ISS live or something?
You can, but you're going to find a lot of inconsistencies as well. I mean, try to find it. Go to YouTube and type in ISS live footage, and then
Wait,
put the link in this
website.
Put the link
yeah,
in the side chat.
Wait, I found this website. It's the first thing when you type it, but it doesn't show anything but the surface of the Earth.
See, I mean, look at this clip from the video. I mean, it doesn't look curved there.
Yeah, because it's not high enough.
Yeah.
Even ISS is not high enough as it is set. 4K camera.
Yeah, yeah. So in this footage here, yeah, we don't see any curvature here.
Wait, I got a Turkish YouTuber. Wait, I have to show them. Would it be a problem?
And just you can put the video in.
This is a Turkish YouTuber. He downloaded a program that shows the exact location of the ISS, and he tried to capture it with a telescope.
Yeah, mine says the uploader has not made this video available in your country.
Oh, what?
Yeah.
Where are you from? Australia?
I'm in Poland at the moment.
Okay.
So he's trying to look through his. He's trying to look through his telescope at the ISS.
Yes. With using the application on. I mean, application that shows the exact location of the ISS.
Yeah, I would agree that there's something up there. Whether there's actually people on it, I don't think so, because there's a lot of obviously fake footage from the ISS. Now, is it the exact distance that they're telling us, and is it going the speed that they're telling us? We can't confirm any of that. We're never going to be able to. Damn, 17.5 million subscribers.
Wait, I have to show you something. I don't know. Okay. And I wonder about the experiment. Maybe you remember it. It was about the light that goes on and on in a straight line. I quite don't remember it. Maybe if you do, can you explain it?
You're talking about when he tried to use a torch and shine a torch through some holes?
Yeah, two holes if I remember, two.
Yeah, it's something like 52 seconds worth of footage. They don't show the setup, and it's okay. So basically, that was like a documentary that was like a hit piece against Flat Earth. Okay, it's called Behind the Curve, and it was aired on Netflix. Okay, and it was a documentary made to make flat earthers look stupid, basically. So they tricked a few flat earthers into going on that, right? One of them's name was Jaren. That's the guy that did the test that you're talking about. Now, they were supposed to use a laser for the test, but they broke the laser, okay? And they said they had a different idea, okay? Because they had it all set up already, they decided that they were going to try to shine a flashlight through some holes, even though it was done in the dark. And then apparently he couldn't see the flashlight through the second hole. Okay, or something like that. And the way that they edited it, they made it look like he lifted up the flashlight and then you could see it. And that proved the Earth was a globe. Okay, apparently that's not the way it happened. Apparently they edited it in a way that made it look deceiving. And then there was a lawsuit afterward because the flat earthers were trying to get the original footage so they can prove that that's not what happened. Even the globe earthers that were there said that that's not the way it happened, and that test was inconclusive. It didn't prove anything. Now, it doesn't show you any of the footage that you would need to see in the documentary. It doesn't show you the setup. It doesn't show you the, it's done at nighttime. It just shows you 52 seconds worth of footage and says, "Oh, flat Earth debunked. Flat Earth debunked." Now we've got similar tests that have been done over huge distances, okay, where we have the whole test in high definition. So I think that test was done over a couple of miles, something like that. We're doing tests over 20 miles, 30 miles, okay, and we can see, we're using proper high-powered laser beams, right? Some people are using $30,000 lasers, and they're able to hit targets 40 kilometers away.
Bob Nodal, was it? The Bob Nodal, I don't know if you know it.
Bob Nodal was in it, but that's not the guy. That's not the guy that was doing the test with the torch.
Oh,
Jaren Campanella is his name. He's a dumbass.
The
Flat Earth
gyroscope
is
thing,
real.
right?
Oh, the gyroscope thing was a different part of the test. Yeah, so they also misrepresented that footage as well. So yeah, there's a video of Bob Nodell explaining what really happened. So basically what they did is at the start they agreed that they were going to hand over all of the original footage, the unedited footage, to the Flat Earthers. Okay, so they weren't going to be deceiving or anything like that. And then after the film was over, they refused to hand over any of the original footage, and they edited the film in a way that made the Flat Earthers look bad, and they misrepresented what really happened by editing it dishonestly. Okay, then there was a lawsuit afterward, and because the Flat Earthers were trying to get the original footage so they can prove that it was misleading footage.
You can tell Flat Earth is real from the reaction you get from the masses. A good follow-up question is like, what conspiracies do you believe in? And they're just so clueless. And then they have the fake nice, and then they, on a computer, they block you after you said it. I was like, thank you for the sound bites. Had a good clip of some Globy talking about it. But then they, boom. Proves to me Flat Earth is real, the reaction you get from the masses.
Oh, it's real painful for some of them, mate.
Yeah, I do that a lot. It's a little bit fun, but you really get to see there's like cameras and the computer and everything, and all the text you can do with Flat Earth, and even in a good way. So, nobody's like, oh, you're doing it wrong. But no, you just like, what conspiracies do you believe in? And wow, I don't know, talking to the masses on the computer, what happened? IQ 80, what do we have, like 110 or something? Most of the masses don't care about space or anything like that anyway, so they're just not interested in that.
So what other wannabe globers have we got in here? Mim, Mr. YM. I don't know how to say your name. I'll probably messed that up multiple times. Who else we got? Arch, Charlie. Going down the list. And what's it? Holyford.
Well, you don't think that deserves a discussion? What snaps the spell from the masses to get interested in stuff? Or not? It just conspiracies is off the table, probably. Any?
Don't know what snaps the spell. It's different for everyone. That's what's interesting about it. Whether it's an accumulation of little things, all of a sudden they just all bubble over, and it's like, oh crap! And they realise, whether it's the full sledgehammer swat and flies approach, I don't know what the trigger is to get people to wake up.
I think you hit the nail on the head, man. It's different for everyone.
The ones that can read the word fluoride be like totally pro fluoride. So maybe that's a thing I've been onto for a while, but I think that's maybe I'm just saying the obvious. I don't mean to be wasting your time on here. Right, some of them can't pronounce it, but the ones that can are totally for it. I don't know. The majority of flat earthers are off the fluoride toothpaste, at least. You know, I don't know.
They're actually considering putting that shit back in the water where I live. Apparently there's been a whole slew of people with really poor teeth, and they're blaming the lack of fluoride for this. Even to the point where a few of the dentists are actually considering putting in a class action against the council because of this, on behalf of the people of the city. Isn't that crazy?
Hey, yes, sir. DJ.
Yo.
Yes, sir.
Oh, I was just linking a video from the two guys that were in the Behind the Curve documentary explaining what happened from their point of view.
Where is it?
Oh, it's in the side chat where I tagged.
Brock Riddick? Is that?
Yeah, it's Jaren and Bob explaining.
I will just add that to my file pile.
I'd like you to do most of your presentation, or if you would like to pause and say, invite people up, like at certain portions or something. Or I can just add people to the stage to eventually let them ask their question. I don't know what you want to do.
I think I'd probably prefer that we start with, I'll start with a section on when I deem that I believe that I've reached the end of a pretty, clear line of a point. Then I'll just take a moment and say, hey, if anyone wants to ask questions on that before we carry on. Simply because this is ultimately going to be in about two sections. One where I'm going over videography, and then the other one where I'd like to go over refraction science and what we've uncovered in that part of the arena.
Sure. Okay. In that case, I will double check, make sure the stream is functioning, and then you can go ahead and start whenever you'd like.
Let me know when you're ready.
Okay. Yeah. It looks like it's free and clear. Go for it.
All right. So
what is it that we're doing?
I think it's really important.
DJ, thank you for information.
Yeah, sorry, that was the wrong stream that I was playing. Yeah, anyway, yeah, no problem, man.
I gotta go, but I mean, I will maybe join this channel again tomorrow or the next week. I don't know.
Yeah, awesome. Yeah, come back anytime.
Yes, sir. I'm trying to, research about if it's globe, if it's flat.
Yeah, man. I sent you a friend request, so if you got any questions, you can always just shoot me a DM.
Yes, sir. Yes, sir. Have a nice day, y'all.
Yeah, you too. Catch you next time, man.
Next time.
Looking into Flat Earth to have two very fundamental understandings that there's two that I went into because when
So I found out that there was going to be a documentary called Behind the Curve. Got a call from the producer, Daniel Clark, and he asked if he could film my upcoming experiment. They were going to be pro-flat Earth, that they weren't going to try and make us look bad, or they weren't going to try and make this movement seem silly. They were on our side. But what ultimately happened was they misrepresented an experiment I did.
Fiber optic gyro experiments that we were doing, Daniel Clark was very interested in, how they were going and what they were dealing with. And so I told him it measured a 15 degree per hour rotation. He automatically assumed that I meant that it meant a 15 degree per hour rotation of the globe. It absolutely was not Earth rotation. We sent it to him. He chose not to use it. And he chose to portray us as if we had detected rotation of the Earth. He betrayed my partner, Jaron.
By basically taking an out-of-sequence part of it, putting it at the end of a film, and it was just completely out of sequence, misrepresented.
But what he made it look like was that they had just measured curvature, and Jaron's going, oh, interesting. Absolutely deceitful, despicable behavior, Daniel. What we did is in Colorado, we went to a place called Pikes Peak. And Pikes Peak is 14,125 feet in elevation. We got that measurement, okay, and then what we did is we went due east down to the plains of Colorado and about a 10,000 foot elevation drop. And we did another measurement. When we did that, we got a more than 1 degree variance on that rotational rate. And that right there puts an end to the debate, the dispute about what we measured.
All these people, and we're listening to replays.
No, we just had a long conversation with someone.
Oh, okay.
Yeah, he bailed. Who else we got in here? Zong, welcome.
Isn't it amazing? You play something, and they come in and start talking. You press stop, and then they take off.
Yeah, it's crazy.
I've seen it so many times. Or there'll be other people talking. They'll have to drop in and interrupt. But yet, if there's total silence, 20 people sitting in here, they'll come in and go, "Oh dear, no one's talking. I'm too scared to say anything," and then they'll just take off. It's like crazy. Cola super deep borehole. Yep. Oh, Duga's back in. You got any more songs for us, mate? I was bashing a few of them out last night. It was great. Better make some noise, the shoppers are leaving.
A disc as a cartoon, a cheap hollow toy. They grin and they point to the infinite void, saying don't fall off of the edge, little boy. They build up a scarecrow of turtles in space, a cliff at the end of the human race. It's easier to fight a thing they invent than look at the evidence that we present. No way, it's not what we claim. Measured flat, you can call it a plain. Mountains and valleys for you and me, a vast level realm as far as can see. You keep on repeating this silly old lie while observing the same ground, air, and sky. I know it's just land you were shown your hand. You're fighting the claim that was never ours. You talk of your globe, a spinning blue ball with gravity's magic that holds it all. You quote a textbook, a NASA clip, with that overconfident smirk on your lip. You say pizza on elephant sea while ignoring the evidence coming from me. You calculate a curve with a stick and a string, but never question the whole damn thing. No way, it's not what we claim. Measured flat, you can call it a plain. Mountains and valleys for you and me, a vast level realm as far as can see. You keep on repeating that silly old lie while observing the same ground, air, and sky. I know it's just land you were shown your hand. You're fighting the claim that was never our stand. We talk of perspective, of sun's gentle arc, of a local light circling over the dark, shooting lasers across still steady lakes, and the claims that turn out as fakes. You just plug your ears, sing your globe song, the same tired verse that we've heard for so long. You don't debate, you just want a cheap win with a joke about where the elephants have been now. Was never our stand. Never our stand. Just listen for once. Just listen, it's all right here. Just look.
Did I read that correctly? We agree that we haven't seen good evidence for a globe Earth, okay? But you can't say it's not a globe. So there's no good evidence for the globe, but I'm not allowed to say it's not a globe. Right. So let's do this sensibly. Let's flip this. Is there any good evidence for flat Earth? Laser tests. Water. Being flat and level when it's at rest. Oh, he's not even in here. He's just another one of these side chat rat. Hey, Doog, it's your turn to play a song. Oh, a new visitor. Fisto, welcome. Don't be shy, we're not going to bite you.
Hello.
Hello, who said hello? Where are we?
Charlie.
There he is. Up the top there. Hi, Charlie. What brings you in here today?
Just looking for globe proof.
You're looking for globe proof? I don't want to sound rude, but you better take a number. Let's see if this fella's got it. Dre Mateo. Did you bring globe proof for the masses? Oh no, AJ didn't. He's hopeless.
Hey, bloody wanker, that guy.
Did you bring any globe proof for the masses? But ask just in case.
Well, I did actually.
Hello, we're on. Assume the position.
Yay!
Let me think.
What globe tard proof have you got? This is going to be good.
I'm actually trying to think of one.
Well, while you're conjuring up a plan,
I could use the usual refraction.
Refraction is proof of curvature.
That's it. Apparently so. That's what I've been told like 10,000 times.
Yeah, same here.
Yep, the refraction makes the Earth look flat, which is proof of curvature.
That's it. See, you're on it.
So the lack of curvature proves curvature. Got it.
Yep.
Yeah, of course. That's weird. People wouldn't agree with that.
What about water curves? Level is curved, yeah. You know how I know? Because when I put water in a teaspoon, it curves on the top.
What, you're holding the teaspoon upside down and the water runs off it?
No, I fill up my teaspoon with water and it gets a nice curved water shape on the top. See?
So
levels
no,
curved.
No surface tension involved because it's such a small thing.
No, that's gravity.
That's gravity. So surface tension's now gravity.
Oh, of course.
It's so easy to get knotted up in here with this, isn't it?
And I'm just talking shit while I'm trying to work. I'm sort of half concentrating on both.
Must be interesting from like the third person perspective, listening into guys just getting knotted up with me playing with their heads. I've always wondered how funny it is.
Well, we've got to have Earth's a globe because look at the moon.
Yeah. I think we live on a globe because there's moons that move in front of Jupiter. Beat that one. Oh, wow.
What are you doing for Invasion Day?
Well, I'm not invading anything. I'll be staying inside as it's supposed to be something like 44 degrees tomorrow. So I'm going to test out my aircon.
Ah, very nice.
I'll probably be in here annoying people, but
well, I'm supposed to be going out tonight, so I may be testing my aircon tomorrow as well, depending on how tonight goes.
Where you headed, mate?
Oh, just going to go out for dinner and then go to the casino, and then got a mate of mine who owns a nightclub, and it's his birthday, so we'll probably end up back at his club.
Nice.
Well, sort of nightclub. It's an Irish bar on a nightclub strip. So, yeah.
I'm actually snowed in here in Texas.
Yeah, well, I think Matrix is getting a heat wave. We're just about to get another cyclone. and no snow in Australia at the moment.
Never realized how many people come in here, Globers, and think that we're trolling.
Oh yeah, it's amazing, isn't it? When you just sit back and listen. Absolutely crazy. Yeah, it's nearly a grab yourself a bowl of popcorn, sit back, put your feet up, and enjoy the show type thing. Hey, cool. Let's go, man. Cool as in zero cool? Hack the planet? Maybe you're not old enough to understand that, Joe.
Do you think about Flat Earth daily, on the daily?
Me or him?
You?
Yep.
Same. I think a Glober came in here earlier and was asking if someone thought about it daily. And I never really thought about it. But yeah, I think about it daily.
I should go and get some dunny paper made up, custom printed with little globes on every single sheet, just so I can wipe me freckle with them. Sorry, I got to translate. Toilet tissue.
Crap wrap.
For use in the bathroom, cannon fodder.
Shit ticket.
Oh, we got a couple of new people. Welcome. We got a pro monkey. Is that any better than a amateur monkey? What is the difference? Pro monkeys don't talk. There we go. And who else was there? Lek. Or Leek. Welcome. Hey, talks. Yes. What brings you in here today, mate?
Well, thank you. There is any topic here or something you want to discussion here?
Well, being that this is the 24/7 Flat Earth Discord channel, most
Are
of the
you
time,
AI or real?
this is real. I don't know any AIs that have got a mad accent like me.
Oh, okay.
So yeah, it's pretty real.
Thank God.
Oh well.
Why everyone's
Anyways,
silent?
normally what gets discussed in here is the shape of the Earth, or for the case of some people, the lack thereof.
Mm-hmm.
So what do you think?
I'm thinking about what?
Do you think it's a ball, 72% covered in water, spinning, tilting, wobbling, flying through the vacuum of
Oh,
space?
come on, bro. We are in
planar?
We are 2026, and
So
they
you're a
are
flat earther then?
they are still they are thought the Earth is flat. Really?
Why do you think it's a ball then?
Yeah, of course. What do you think?
Why do you think it's a ball?
Because they are arrived to the moon.
So someone's ability to fly up in the sky means the ground that they've left behind them is curved. I didn't know curvature was a prerequisite to flight, but anyways.
Bro, do you know you are not trust about NASA? What do you think about NASA? Do you trust about them or no?
No, not trust.
No, not trust them.
No.
Blue Origin, Starlink.
So let's go back to NASA to start off with. You do realise NASA has been reclassified by the government as a spy agency.
Really? Who said that?
The American government, US government, reclassified NASA, NASA, as now a spy agency.
NISI?
NASA, yeah.
Oh, yeah, I know NASA. But you
They do.
You say
they do spying.
they are reclassified. How do you know they are spying? They are spying about who?
Don't know, don't care.
Mm-hmm. Okay, they are spy for other countries like Russia, Iran.
Makes you wonder why they were reclassified. One of the perks as being classified as a spy agency is you are now immune to some laws. So now they can go to court and lie and get away with it. So that means any questions now that you put forward to NASA about their anything space related over the last 50 plus years, they can just lie about it and walk away, and there's nothing you can do about it.
Look, actually, I have a question. You say they are reclassified, okay? And after I don't know after about what, but in the beginning, is they are begin as discover the universal.
Are they universal? I'd rephrase your question.
How you say they are reclassified, but in the beginning, how they are begin. For which purpose?
The original claim was it something aeronautical space advisory or something like that? It actually
Regional
did stand for
claim?
something.
Regional claim for what?
For NASA.
Okay.
What I want to know is, how can people in 2026 still think that this footage from NASA looks real? Okay, look at the footage I just put in the side chat.
Bro, come on. Why they? Why?
Hold on. Look at the footage. Look at the footage in the side chat. I want to know why in 2026 people think that this footage looks real. Look at it, bro.
Wait a minute. Just I want to open the.
10 minutes past the hour.
This is still loaded. Oh my god.
That's actual footage from your NASA.
I can't open this image. Wait a minute. This is still
Probably
loaded.
still loading.
Yeah. Oh, this is GIF.
Yeah, so it automatically plays.
Yeah, what about it?
I want to know why in 2026 why people think that this official NASA footage looks realistic. Obviously, it's fake. It looks completely fake. But people still think it's real.
This GIF from NASA?
Yeah, this is from NASA.
How do you know this is fake?
Oh my god, see? There we go. 2026, and people look at this footage and ask me how I know it's fake. Bro, that's all I need to say. You think that this footage looks realistic.
No, I don't think this is realistic. But if you say something, prove it. You say this is fake. How do you know this is fake?
No,
it's real because it looks so fake.
What I said specifically is that this footage looks completely fake, and I don't know how anyone can think that this footage looks realistic, especially in 2026.
Bro, this GIF is taken in 19. So, of course, you think this is fake.
So you think that this footage could be real footage from space?
I don't know if this is real or fake. Bro, I don't know. But you say this is fake. How do you know it's fake?
No,
how you can
there's a difference between saying something looks fake. Okay, it looks fake. So if I say something looks fake, right? It looks fake. I don't need to prove it's fake. I didn't claim it's fake. I said it looks completely fake, and I don't think anyone in their right mind could think that this looks realistic. I can't validate the footage. You can't validate the footage, but it looks fake. We could probably both agree on that.
Yeah, of course, but that doesn't mean that is fake, right? It's you say this is probably fake, so you don't know if this is fake or no.
It looks like a clothes dryer decorated with cardboard. And it's obviously stop animation.
Okay, do you?
It's like a robot. You know how the robot dance?
Okay, guys.
Obviously, puppetry
are
using
showed,
miniatures on a set.
Guys, you think this Earth is flat, right?
The horizon presents itself as being horizontal.
100%.
You observe it to be, and you treat it as such for all practical purposes. You don't treat the Earth as being a ball. You don't live your life that way.
So how we can prove the Earth is flat, not circle?
Circles are flat. Sorry to disappoint you.
No. You think this is Earth is flat, right?
Mm-hmm.
How do you know it? Do you have
because of the surface of liquid?
Surface is liquid?
The surface of liquid, yeah, has a natural property of being
that doesn't
horizontal
mean
when it rests.
But that doesn't mean the Earth is flat because there is gravity.
Yeah, great. Gravity makes the surface of liquid flat. Cool. Thanks.
Oh my god! Actually, my English is not very well, so some words I miss to understand it.
You're supposed to say it's not flat.
You say
it's not horizontal. It's curving. You're supposed to say that the surface of liquid at rest is not horizontal. It's not level. It's not flat. It's a curve. It's curving. That is supposed to be your rebuttal if you think you live on a giant sphere, because every surface of a body of liquid would be the partial circumference of a sphere, the partial surface of a sphere. So it can't be flat. But that's not what you measure, and that's not what you observe, and that's not how you utilize it. Is it?
Okay, it's curved, right? It's curved. The Earth is curved, right?
No.
But no.
When?
Why no? You say that, right? Or
if you're a glober, you think that the surface of liquid at rest is curving. Period. If you think the Earth is a big ball and gravity